My name is Kajsa Hultén, and I'm the co-director of Area of Advanced Transport. And we welcome you to the Initiate Seminar 2021. Today, we are streaming from Chalmers, Runan, to 238 participants that are now connecting online. But obviously, we would have had you here. But we will have to do with this until next year, when we hope that this whole facility that takes around 450 people will be filled up with people interested in transport. So even though if we are here at Chalmers, the Chalmers campus, we have a close collaboration with Gothenburg University and Chalmers within this area of advance, where we conduct research together within this area of transport. And we do this because it's so important to have our complementary but different research focuses to sort of approach these very challenging issues that lay ahead in front of us with regard to the role of transport in society. So, where are we going is the theme of today. And what trends and directions of research could we see, could we foresee? And what such challenges can be identified within transport and its role in society? So, in order to discuss this, we have divided the day in 5 different themes that we will discuss. And we will first then delve into the role of hydrogen in transport, in the transport system. Is it as promising as we hear about? In what different modes can hydrogen be used, etc. We really look forward to that. And we have then Selma Brynolf that will help us to discuss these issues in a while here. And Selma is a profile leader for sustainable vehicle technologies within the area of advanced transport. I welcome you up, Selma. So we will hear more about Selma in just a couple of minutes. Then we also will discuss active mobility. So how can we promote more active modes of transport, like walking, like bicycling, and how could we incorporate these into the city center in our urban environments? Are there any challenges with that? We will also listen more to that in a while. And Magnus Granström, being the profile leader for traffic safety, will help us with that during the day. So welcome, Magnus. Then we have, as a third issue, how transport relates to urban development, because we need to sort of connect the transport solutions that we have. There are so much new initiative, so much effort in creating these new technologies, these new solutions, but these will need to be matched and fitting within the urban development. So we have Michael Brown here, who is a co-profile leader for TECAL, Transport Efficiency and Customer Adapted Logistics. That is always a very hard, we never understood who came up with that. Oh, it's the next moderator. So then we welcome up Dan Andersson, who is responsible for that. We most often say TECAL. Don't we, Dan? Now, he hasn't a microphone, so he cannot answer. So, then Dawn will also then help us later on with the fourth theme of today, which is horizontal collaboration. And that deals with how firms at the same level in the supply chain can share data, collaborate in new ways in order to, for example, increase fill rates, and in that way promote more efficient and effective logistics in the supply chain. And then we have, as a last theme of today, we have issues relating to traffic safety, transport and traffic safety in the value chain. So that also relates to a UN conference that we had in Stockholm the other year, and that initiative, and how we can then deal with these issues in society. This is a little bit on today's agenda. So we wish you again very, very welcome here. And we hope we will have a super interesting day dealing with all these issues together. And I can also say then that we encourage you to send in questions or reflections in the chat forum at YouTube. So bring it on, and we will maybe not be able to answer all of them, but we will definitely approach them. So now we will start for today's event, and the first theme is then related to hydrogen. And obviously there has been, you hear Selma, you being the moderator for this session.
Yeah.
So we hear a lot about, hydrogen, a lot about talk. Why is it so? Why is hydrogen so important and interesting?
Yeah, and I think there are many reasons for that. One reason, I think, is that we are now starting to use more and more renewable electricity. And we see that renewable electricity is reduced in price. And with more and more renewable electricity, which is also intermittent, we need to store energy. And hydrogen could be one way to store renewable electricity. But now, today we are talking about transport. And we have heard about hydrogen being the next fuel in transport long time ago. It has been coming up and disappeared again as a solution. And now why it's coming back might be due to, I think it's due to a lot of things why we are discussing it again. We see that it's challenging to use electrification in some parts of a transport system, such as for aviation or for long distance ocean transport. So that might be some of the reasons.
So this, it seems really interesting and intriguing. So I guess we will get all the answers now to the future of hydrogen and how useful it will be in the future transport systems.
Oh, I don't think we will get those answers today, but we will hopefully get more insights. We will know more about the pros and cons of using hydrogen. And some of the challenges that we might face. We might also get to hear something about why we should use hydrogen in internal combustion engines instead of in fuel cells. But typically when you are talking about hydrogen, I think most of us thinking of that we will use them in fuel cells. But it's also possible, and that's also well known, that you can use it in combustion engines. But see if we'll hear more about that.
Yeah. That seems really interesting. So we will get some answers maybe, and also some discussion about the challenges and the pros and cons. And
I'm really looking forward. It will be interesting, and we have a very interesting speakers that will present here today. We are a bit ahead of time, but I guess...
But we can also maybe say that this day involves not only research. We have researchers from our two partner universities arranging this event, where we have researchers, but we also complement that with super interesting speakers from industry and other actors in society. So we will have a great mix of that. And we think also that is one of the things that make this seminar so special, that we integrate these different perspectives on the societal challenges that we are approaching. So we are sort of now going to transfer to the hydrogen theme, and I thank you. I will be back later on. This afternoon. Should we take a really small break before, or are we ready to go? We are ready to go. Then I leave it to you.
And I can then start and introduce the agenda for the hydrogen session. So we will have 3 speakers today. We will have first David Sebon from University of Cambridge, and he's also director for sustainable road freights. He will speak about long-haul road freight, hydrogen or electricity. And after him, we will have Julia Hansson. She is a researcher at the IVL Swedish Research Institute, and also works part-time at Chalmers. And the last of the speakers will be Bengt Johansson, and he is a professor with combustion engines here at Chalmers, and also the director of the Combustion Engine Research Center, CERC. After the speakers, we will have a panel session where we have representatives from different transport modes. So we have representative from AB Volvo with trucks. We have representative from shipping, and the researcher that will have to represent aviation and air transport. Okay. So I think we will. I'm very interested. I'm looking forward now to hear the first speaker, David Sebon. I have heard you before presenting very interesting thoughts and very critical thoughts connected to the role of hydrogen in transport. So I leave the word to you.
Thank you very much. Can you hear me?
Yes.
Yep, excellent. And you can see my screen?
Yes.
Very good. Thank you very much. Well, I'm very delighted to be here to talk to you today about the role of hydrogen for long-haul freight. Let me just talk very, very quickly about our centre. The Centre for Sustainable Road Freight involves three main disciplines. That is vehicle technology, operations and logistics, and policy. So we have three universities involved. University of Cambridge, where we do vehicle technology, Heriot-Watt University, where we have a logistics research centre, and University of Westminster, where a very famous professor from Chalmers University used to work. And we still work with that group. And we have industrial partners that fit throughout this, from logistics partners on the right-hand side to vehicle industry partners on the left-hand side, and government partners in the bottom on policy. So we are a centre trying to look at the whole picture of sustainable logistics. So what is certain? What do we know is going to happen? Well, I think what we know is going to happen is electrification of urban logistics. And it's happening now. It's happening largely. In the past, the force has been from air quality emissions, and that combination of parcel delivery, home delivery, delivery to urban shops, stores, refuse collection, it's all becoming electrified. In 10 years' time, we'll look back and we'll say, why did we ever drive diesel trucks in cities? So I think that that's a certainty that we're going to electrify urban vehicles. What is going to happen with the long haul? Well, that's a question. I've just got a picture here which shows the concept of the Siemens e-highway. But really what I'm showing you is an electric vehicle with a pantograph. And my reason for saying that is that the electric vehicle which underlies this, which has a generator, it has an electric machine, it has a battery, it has an inverter. That's the same electric. It may not have necessarily have a generator. That's in a hybrid range extended version. But without the generator, that's the same vehicle which will run on batteries, which will run on e-highway, which will run as a hydrogen fuel cell vehicle. It's the same basic platform. What you have to add, you add a bigger battery if it becomes a battery electric vehicle. You add a hydrogen fuel cell and hydrogen storage tanks and whatever if it becomes a hydrogen vehicle, and you add this rather low-cost pantograph system if it is an e-highway vehicle. The pantograph system picks up electricity from an overhead wire. So whatever happens, we're going to have an electric vehicle platform. And it's just a question of what you add onto it as to how the logistics system plays out. So I want to talk about green hydrogen. I want to talk about blue hydrogen. These are different kinds of ways of making hydrogen. I want to talk about electrification of the long haul, and I'm going to draw some conclusions. So when you make green hydrogen, well, sorry, let's start off with an electric vehicle, a battery electric vehicle, like the one we just saw, but it's got a big battery. If you start with 100 kilowatt hours of electricity, at the top comes from nice green electricity comes from a wind turbine or solar panel or maybe a nuclear power station if you believe in that. Then you take it by the electricity grid. There are some losses in the electricity grid, maybe 10% losses, so you end up with 90 kilowatt hours. You convert it from AC to DC and put it in and out of a battery. And that process is about 85% efficient. So you end up with 77 kilowatt hours. You put that into your battery electric vehicle, which has some inefficiencies as well, about 90% efficient. You end up with 69 kilowatt hours, say 70 kilowatt hours at the wheels. So in this process, you've lost 30% of the energy. That's a battery electric vehicle. That's any battery electric vehicle near enough, whether it's a battery electric ship or a battery electric car or a battery electric truck, a battery electric train. Same story applies. If you go via hydrogen, this is what happens. You take your 100 kilowatt hours, you convert it by electrolysis to DC. You electrolyze, and modern electrolyzers are about 75% efficient. You take that hydrogen, you compress it, you transport it, and then you decompress it and put it into fuel cell. Now, a fuel cell is about 50% efficient at best. All current fuel cell technology is around 50% efficient. And you put it into an electric vehicle, you end up with 23 kilowatt hours at the wheels. The reason that this has happened is because of the change of very useful electricity into rather less useful hydrogen, the pink part. You're converting what we call, in thermodynamic terms, work into what we call heat. And when you convert heat back into work again, you are limited by the second law of thermodynamics, which gives you an efficiency of about 50%. But this is something which you can't change. You end up with about 23% efficiency. And that means you've thrown away near enough 3/4 of the energy that you started with. In going from electricity back to electricity again, you've just simply thrown away 3/4 of the energy. That means that the the energy you've got is much more expensive because you only got 23, but you had to make 100. So you had to make 4 times more electricity than you're actually going to use. That is the green hydrogen route. If you go via the electric road route that I just showed you, the Siemens e-highway, you get the advantage of not having to go in and out of the battery, and that makes it more efficient because you can power directly from the overhead lines to the wheels for much of the time. That makes it much more efficient, and that gives you 77 kilowatt hours at the wheels, which is the most efficient way you can run an electric vehicle. That's how the efficiency of an electric train, and that's the best you can do. Can't get any more efficient than that. That's the minimum losses. So if you reverse this calculation, you say, okay, we know how much energy we need to power all the trucks in the UK. We can estimate that. It's not very difficult to estimate because we know what it takes how much energy it takes to transport a 1 ton kilometre of freight. And we know how many ton kilometres there are. So we know how much energy we need to transport all the current UK freight. And if we say, all right, how much electricity would we need by these 3 routes? Well, let's look at 2 of them. Let's look at the one on the left and the one on the right. The one on the left, we can see that if you want 23 kilowatt hours of the wheels, you have to start with 100. So you need to start with 4 times more electricity. The one on the right, if you want 77 kilowatt hours at the wheels, you have to start with 100. And that's about a factor of 1.4. So a lot less electricity needed if you're going to do an electric road. You can plot that out on the map. And here it is for the UK. And for the UK, if you did electric road system, this is the area of onshore wind turbines that you would need to generate the electricity. And you can see you would need 10.6 gigawatts of power. That would be 3,500 onshore wind turbines. It would require a land area of about 5,000 square kilometres, and that is shown to scale on this map. If you did it by green hydrogen, this is how it looks. You need 36 gigawatts of power on average. And that compares to the UK's total power consumption, average power consumption today, which is about 31 gigawatts. You need to more than double the UK's power system by adding green wind turbines. You would need 12,000 wind turbines and a land area of 18,000 square kilometres. Now, of course, you wouldn't put that on land, you would put it offshore, but you would still need a factor of 3.3 times more wind turbines or solar cells or nuclear power stations if you wanted to go by green hydrogen than if you wanted to go directly by electrification. Now, somebody has to pay for that 3.3 times more electricity, and that will be the government, the taxpayer, and the country, the national economy. Here's just an interesting alternative view of this, which is that if we look at the carbon intensity of the UK electricity grid at the moment and convert it into grams of CO2 per tonne kilometre, so this is government data on the carbon intensity of electricity grid, you can see this. If you use electric roads, this is the grams of carbon dioxide per tonne kilometre as we go forward. If we swapped everything in this year to electric roads or to green hydrogen, this is what it would look like. And so the carbon intensity of the electricity grid of a diesel vehicle is about a little over 100 grams per tonne kilometre. And you can see that if we change to an electric road system now, we would reduce that by about 70%. And if we went to green hydrogen now, the carbon intensity would be about the same as diesel. You can see that it would be 2035 before green hydrogen even caught up with the carbon intensity of the electric roads if we did it today. So it would be 15 years before, due to decarbonisation of the electricity grid, 15 years before green hydrogen would catch up with the carbon intensity that we could get by electrification right now. So going with green hydrogen means locking in a whole lot more carbon emissions than we could get to by direct electrification. If we went by blue hydrogen is made by a process called steam methane reforming. You take methane, that's natural gas, comes from the North Sea, or it comes from Russia, or it comes from liquefied natural gas from America, or from Kazakhstan, or from Iraq, Saudi Arabia. These are the places that make natural gas. If you take natural gas and you steam methane reform it, what you do is you add hot steam, out comes hydrogen, and out comes carbon dioxide. And you have to take that carbon dioxide and sequester it. You have to put it down, you have to capture it, and you have to put it down a hole in the ground for its forever. Now, when you do that, you learn something interesting. The calorific value of methane is 36 megajoules per cubic meter. That's how much energy you get from a cubic meter of methane when you burn it. The calorific value of hydrogen is 11 megajoules per cubic meter. It's about a factor of 3 and a bit less. Now, what are the implications of that factor of 3? The first is that you need 3.3 times more hydrogen to flow than methane for the same amount of energy. People often talk about hydrogen, use of hydrogen for heating, and you would have to flow 3.3 times more hydrogen along the gas system than you would have to flow methane. That means you need 3.3 times the pipe area for the same pressure. And that means you need nearly factor of 2 times bigger pipe. So if you want to transport hydrogen around the country in gas pipes, you have to increase the size of every gas pipe by a factor of nearly 2. Now that's fine. If the pipe is 25 millimeters, you increase it to 50 millimeters, that's kind of doable. But when the pipe is a 1 meter diameter main, you have to increase it to 2 meters. Now you're talking about a pretty serious infrastructure project. You also have to replace all compressors and pumps in the entire system. So you can't get hydrogen around the country using the existing gas grid. You have to replace the existing gas infrastructure or transport hydrogen in trucks. And remember that for every 1 ton of hydrogen you generate, you have to, by blue hydrogen, you have to transmit 10 tons of carbon dioxide in the opposite direction to where you're going to sequester it. sequestration. So let's look at methane. So suppose we went through this steam methane reforming route. We would take 100 kilowatt hours an hour of methane, not of electricity, of methane. We could go through the steam methane reforming process. That's 90% efficient. We would get hydrogen, we would compress, transport, put it into a fuel cell and our electric vehicle. We would end up with 29 kilowatt hours of electricity at the wheels, or of energy at the wheels of our vehicle. When we go, now this time we're going from methane to hydrogen to electricity. That's the blue methane route. And we have to capture the carbon dioxide. Now, an alternative to this, which we could start with methane and end up with an electric vehicle, is not to do hydrogen at all, but it is to use a power station to generate electricity. If you use a combined cycle gas turbine power station, that's the type of power station we use today to generate electricity. It's about 64% efficient. And it takes you straight from methane to electricity, blue to yellow. You can transmit that electricity via the grid. You can put it into AC to DC conversion. And now you get 49 kilowatt hours at the wheels of your vehicle. So you get a lot more if you go via the power station route. You end up with 49 instead of 29. Of course, in both cases, you have to do your CCS process. And it's about as difficult in each case to capture the carbon. But you can see that if instead of going by hydrogen, you just took the methane and burned it in our existing power station and did the carbon capture and storage business, then you would end up with a whole lot more energy than if you go through this hydrogen palaver. Because in the hydrogen game, you strip all of the good energy from the methane and you lose it because you just take it, remove those carbon atoms, which have all the calorific value, and you put them down a hole in the ground and you lose the energy. But if you go via the combined cycle route, you at least get to use that energy in the carbon atoms before you sequester the carbon. So that is the route which I would call gas turbine plus CCS plus electric road vehicle. So in energetic terms, hydrogen is terribly wasteful. Let's just have a look at the UK's picture for natural gas. I would like to do all this for Sweden, but I don't have all the data for Sweden. I've done it for the UK. Here it is how it looks for the UK. This is data from the government about how we use natural gas in the UK. You can see the inputs. This is production, UK production, 450 terawatt hours in 2018. Imports, see, bigger than our production. Our imports are bigger, 520 terawatt hours. And this is where it's all used. It's used in the iron and steel industry. Domestic is a big part, 309 kilowatt hours. That's mainly heating of houses. Power stations use 273 kilowatt hours. And you can see all the other sorts of uses. And here is biomethane. That's an interesting one. 3.3 terawatt hours of biomethane came into the gas grid in 2018. If we went via a blue hydrogen route, what would it look? How would this change? If we went via blue hydrogen for road freight. If we went directly by blue hydrogen, we would have to add 124 terawatt hours to the imports. Yeah. And the outputs, the imports and the exports would both increase by 124 terawatt hours. I've shown that to scale on this same scale as the thickness of the bar indicates the amount. If we went by combined cycle gas turbine plant, which was the alternative on the previous slide, then we would increase this by 73 terawatt hours, which is a lot less. So the imports would be a lot less. If we wanted to do biogas, then, and if we use Volvo's HPDI gas engine to do that, we would need about 90 terawatt hours of biofuel, of biogas. So just to summarize that, we need 70% more methane by the blue hydrogen route than the combined cycle gas turbine route, by just burning the hydrogen in a power station and sequestering the carbon dioxide. And that's the same sequestration process that we need to do for blue hydrogen. We would increase the methane emissions by 24 imports by 24%. So that blue hydrogen has to come from somewhere. It has to come by increasing imports because we can't make any more. The North Sea it's declining, is the amount of gas from the North Sea. So we need to increase our imports by 24%. Now that has energy security issues. That means that the UK's total gas imports go from about 55% to about 60%, which is a significant problem because we have to import our gas from Russia and Qatar and from Iraq and a bunch of places where we'd really rather not be dependent on for energy. Of course, the CCS process that's in blue hydrogen is not perfect. The carbon capture rate is only somewhere between 70 and 90% across all CCS that exists in the world at the moment. And it may be that it can improve in the future, but at the moment, that is 70 to 90%. That means 10% at least of the carbon dioxide is going to escape into the atmosphere anyway. The other problem is that the whole natural gas system has a really serious problem, which we've been hearing a lot more about, of so-called fugitive methane emissions. And that the oil and gas industry in the world vents and flares and leaks methane, and the amount that they vent and flare and leak is equal to the entire carbon footprint of Europe. Now that's pretty staggering, because if you use blue hydrogen, what we're talking about doing is increasing the amount of methane which is imported and manufactured and vented and flared and leaked, unless something is done about fugitive methane emissions. So fugitive methane emissions is a massive problem, and increasing our reliance on natural gas exacerbates that problem. And finally, I would just comment that if you wanted to use biomethane for trucks, you would have to increase the supply of biomethane by a factor of 27 on what is generated at the moment. And that is a pretty difficult thing to do, and a bit of a question as whether we can actually do that. So what do we do about the long haul? What I've shown you is that, in my opinion, hydrogen is just mistaken. What can we do? Well, we believe that we can electrify the long haul, and that the best way to do that is a combination of battery electric vehicles and the electric road system. The electric road system looks completely crazy, although you've had a good go at it in Sweden and had some very good results in Sweden. And there's work going on in Germany as well, and we're working on a project in the UK. Here's a little bit of analysis for the UK. We've looked at rolling out e-highway across the UK, and this is what we conclude. We'd like to do a three-phase project. The first phase is a pilot, which we're working on at the moment, which is a rather small length of e-highway. The first major phase we would do in the most heavily trafficked roads in the UK. This is about 3,000 lane kilometres of road. It would cost about £6 billion. That's about 7 billion euros. I'm not sure what it is in Swedish krona, so that's a question. That's about 10 times that, I think, isn't it? 8 times something. This would interestingly cover about 47% of all heavy goods vehicle kilometres on the main long haul network, and it would decarbonise about 32% of UK road freight, which is pretty good for a first phase to get to 32%. As we go on through future phases, we add more money, we add more decarbonisation, until we get to the third phase here, where we'd have 15,000 lane kilometres. That's 7,500 kilometres of motorway in two directions. It would cover 97% of heavy vehicle kilometres on the network, on the strategic road network. It would decarbonise 65% of all UK trucks. And that 65% is pretty much all the long haul. Most of the rest of it is urban, which would be electrified in the way that I said, by battery electric vehicles at the start. So we could pretty much electrify, decarbonise all of the UK's road freight by this move, and it would cost £19.3 billion. Well, how much is £19.3 billion? It sounds like a huge amount of money. let me give you some other numbers. The Department for Transport's budget for building roads between 2020 and 2025 is £28 billion, which is significantly more than this. So the road building budget for 5 years is much more than this. We have a big high-speed train project which is going on, a single high-speed train line, and joining London to Birmingham and the north. That's going to cost £106 billion, which is 5 times more than this. So one train project is going to cost 5 times more than decarbonising all the UK's road freight. How would this work in terms of revenues? Well, we've made an attempt at looking at the revenues from this process, building out this system. Green here is the current UK government's current tax income from oil sales, diesel sales to trucks. And you can see that through the 3 phases of this project, that would decrease significantly because vehicles would be using electricity instead of diesel. The yellow is the tax we think we can recover from taxing the electricity that's sold to these vehicles. And you can see that by the end of the 3rd phase, you can almost get to the same place that you started with. That is, you can almost raise as much tax as current diesel. Now, if you went by a hydrogen route, it looks like this, the same calculation. That is a very large-scale subsidy for hydrogen with decreasing subsidy with time, but you're still subsidizing out to 2040. And so not only are you not generating the tax revenue, but you're also providing a subsidy for the industry. How have we calculated that? This is the basics. If a truck operator pays 25 pence per kilowatt hour, a quarter of a pound per kilowatt hour, 5 pence of that would go to the wholesale price for the electricity provider. 7 pence would go to the infrastructure provider, and that would pay for their infrastructure, and 53% would go to tax. That 24p, the important thing about that is if the vehicle industry was paying, the operators were paying 24p per kilowatt hour, they would be able to pay back the cost of the additional cost of their electric vehicle in 1.5 years. So this would give them a payback period of 1.5 years, which would mean that it would be a compelling switch to change from diesel to electricity. So the vehicle operator gets a compelling reduction in cost. The infrastructure provider gets to pay back their infrastructure in a financially attractive way, which means infrastructure could be provided by private finance, and the government gets most of its tax revenue back. Why does that happen? Why is this such a good deal? It's a good deal for the vehicle operator, it's a good deal for the infrastructure provider, and it's a good deal for the government. And the reason that it works is because it's so efficient. It uses so little energy in comparison to the alternatives that provides the financial headroom to make it attractive for all of the players. So some conclusions here. Electric urban delivery is coming, and that's building supply chains for electric vehicles. It's going to make electric vehicles much easier to build. Green hydrogen bioelectrolysis is inefficient, has high economic costs, and it requires a massive amount of renewable electricity. And it's highly questionable, in my view, whether it can be done in any sort of timescale. The amount of renewable electricity that's needed is so massive that there's no way that we can make anything like what we need by 2040. The blue hydrogen route uses 3.5 times higher volume flow. You have to replace the entire gas grid if you're going to heat the country that way. You need to use 70% more gas. That gives you than just doing it with a power station plus an electric road. It gives you energy security problems. It gives you a trade deficit problem. And you have the problems of carbon dioxide and fugitive methane emissions. It's not even a clean solution. It's a dirty solution. The electric road system gives you the lowest energy, the lowest carbon emissions, the lowest cost, significantly less than other infrastructure projects. It's well tested, including the tests in Sweden. It can be implemented immediately. So the approach of a national electric road system plus battery urban delivery operation would get us to decarbonising most of the UK's freight operations by 2035, 2040, and that's what we are promoting at this stage.
So much, David. I think we need to
Move
move
on, yes.
on. But maybe even if we are a bit behind, I would like to just ask you if you can try to answer rather fast on this question.
Yeah.
But because we got a question about that you seem to, that if we would use the HPDI biogas solution,
yes.
gas engine, that would be more efficient than blue hydrogen. Why is that? And it seems like you have already decided on what's the fixed engine to choose in your calculations, or?
So I chose the HPDI, the Volvo vehicle, because it's a very good example of a gas-powered vehicle. If you run that vehicle on natural gas on the long haul, it reduces carbon emissions by about 15% compared to diesel. So that's good. That's a good interim measure. Scania has a
okay, maybe the question was, why can't we use hydrogen in that engine, perhaps?
You could use hydrogen well, you can't use hydrogen directly in that engine. It's possible to burn hydrogen in a combustion engine.
But in a similar concept, yeah.
You still have the problem of NOx emissions, which we have now, but you have to provide the hydrogen. And the big problem with hydrogen is providing the hydrogen, not burning it. So you're going to have blue hydrogen or you're going to have green hydrogen, but you've still got the same problems. It's less efficient than a fuel cell engine to do hydrogen, to burn hydrogen. So you're more efficient to do the fuel cell. If you're going to do hydrogen, you're better to do it in a fuel cell and hybrid fuel cell vehicle where you can take advantage of the electrification for regenerative braking and all those kind of efficiencies. That's going to be much more efficient than burning it directly in the engine.
Okay, thank you. And now maybe we will come back to that also after our third presenter. But now I would like to introduce Julia Hansson. You are a researcher at IVL, Swedish Environmental Research Institute, and you have worked for a long time with assessing renewable transport fuels and also with focus on biofuels a lot. And now we are going to talk about what role hydrogen could play in the Nordic transport sector until 2050.
Yes, thank you very much for that. And thank you for having me today. So now we will continue talking about hydrogen, but now from a even more system perspective and talking about not only road transport, but also other sectors. So what's good with hydrogen? We've talked about that it could be used for many transport modes. Now we've been focused, as I said, on the road transport. Now we will go also into shipping and aviation. And also a good thing with hydrogen is that it can be used in different ways. You can use it in fuel cells and internal combustion engines. You can use it in gaseous form and liquid form, and also as electric fuels or turn it into electric fuels, which is when you produce hydrogen and then combine it with carbon, or mainly with carbon dioxide, and then you can produce a range of different liquid or gaseous fuels. It could also be called then power to X. So what me and my colleagues are doing at the moment, we are looking a lot into then the future role of different alternative transport fuels for different transport modes. Of course, since there is a hype on hydrogen, we are looking into the future role of hydrogen. And that we can do in quite a lot of different way, or the assessments you can do in quite different way. But what I will present today is assessments of cost-effective alternative fuel options for aviation, shipping and road transport, having an energy system context, and also assuming that you have fairly stringent carbon reduction requirements that you need to fulfill. And what I will show is that beside the technical and cost development that will take place for sort of all options, and in particular newer options, the role of hydrogen will also depend on the development in other sectors, and not the least on the policies that are after. Okay, so now going into this cost-effective alternative fuel options. Well, how do we do that? Well, the result that I will present today are based on energy system modeling, a model called Open Nordic Times model, which is an optimization or cost minimization energy system model. And the model covers not only the transport sector, it also covers power and heat and industry and residential. And in the first part, we focus on Sweden, Norway, and Denmark, so sort of the Scandinavian countries. And this is also why, as David said, it's important to look into this efficiency in the system, not only looking at sort of the end use. So we put a lot of data in the model about cost estimate, technical performance, like energy conversion, etc., and also the CO2 emissions. And then what the model does is that it tries to sort of meet the energy demand for all the energy sectors during the studied time period by sort of using the technology mix with the lowest costs, but also while fulfilling the CO2 constraint. And in this particular study, we have had the CO2 constraint added as no net CO2 emissions by 2050, aiming for that to see what then would be the cost-effective fuel options. And of course, there's a range of different fuel options in different sectors, but besides fossil fuels, in the model we have biofuels, we have hydrogen, the electrofuels, and in the first part of the study here, we only have electricity for road and not for shipping and aviation, but in the latter part, we have included that as well. And since I'm focusing on the sort of Nordic here, I just also wanted to say that we have included not only sort of domestic shipping and aviation, but also the international shipping and aviation that the Nordic countries sort of stands for, or try to represent that as well. So it's Nordic, but it's also like trying to be total Nordic. Okay, so going then into sort of our results of this energy system modeling and the sort of role for different alternative transport fuels. Well, we have made a range of different scenario cases because, of course, it's very hard to know how the future will look like and how different things will develop and what the potential will be for different options. So then we have tried to represent that by having different scenario cases. And one thing that we change in these scenario cases is the availability of biomass, because that will be important for how much biomass can be used in different sectors, not only for transport sector, but also for other sectors. So then we have one scenario case where we limit the biomass supply potential and another scenario where we not put any limit more than the global sort of global biomass supply potential. And then the model can use it if it finds that it's costly or not that costly to use, but it's a price for it. So it's not that you can use it for free. But then we also look into this carbon capture and storage, which is sort of being implemented at the moment, but not, but to a rather small extent so far. And also there's a lot of uncertainties around carbon capture and storage, not only for cost, but also about acceptance and how it will be implemented in the future. So there we also have two different scenarios. One where the model can choose to apply carbon capture and storage if the cost is found good enough for the model, but also one where we limit the possibility to use carbon capture and storage due to that maybe the acceptance level will be not so high for this after all, or other things that will limit this technology. And also, of course, very uncertain are the cost estimates for the future. In the model, we make assumptions based on existing literature. But of course, they provide a range of different costs. So then we tried to have a scenario where we made a base case where we had cost development for electric and fuel cell vehicles, but we also had another scenario where we added a higher cost for electric and fuel cell vehicles and not being as positive as some of the scenarios for that development. And then we combined these scenario cases, ending up with 8 different scenario runs, but we also made a lot of different other scenario runs, but we will focus on these 8 different model runs. So moving into the findings here. So these are the 8 different outcomes from the different scenario combinations. And you see electricity is red, hydrogen is yellow, we have biofuels in terms of blue and green, liquid and gaseous form. Orange is the electrofuels, and the dark and gray, black and gray is the fossil fuels. And this is the result for the entire transport sector in the Scandinavian countries in 2050. And what do we see here? Well, we have biofuels and electricity introduced in all cases. Electrofuels is introduced only if in the case where you limit the sort of deployment of carbon capture and storage. And hydrogen is introduced also in case of a limited carbon capture and storage deployment, but also when you have limited biomass supply potential. And as you see, you might think that, okay, but how can we have some fossil fuels left if we are supposed to have no net CO2 emissions by 2050? Well, if the model chooses to have carbon capture and storage on biomass-based resources in that, or biomass use in other sectors, then it's possible to still have some use of fossil fuels in the transport sector. And that is what the model chooses in in some of the scenario runs. So this is how it looks for the entire transport sector, and then we could go into the different transport modes. And then if we go into the light-duty road sector, where we're talking now that electrification is coming, that's also what the model says. If you look in particularly to 2050 here, you have a very strong electrification is sort of almost all scenarios. And the role of biofuels, of course, will depend. If you think the cost for electric cars and fossil fuels will be a bit higher, then you might have some biofuels. And also it will depend on if this carbon capture and storage will be deployed or not. But in 2050, there is no hydrogen and no electric fuels for light-duty road transport sector. But going into the aviation sector, the same sort of 8 different scenario cases and combinations. You're looking to 2030 and 2050 here as well, and the colors are the same for different fuels. So what do we see for aviation and the introduction here? Well, we have biofuels in all cases. We don't have any direct use of hydrogen, but we have hydrogen in terms of electric fuels. And electric fuels is introduced in some cases then if there is limitations on the carbon capture and storage deployment, and also if there is limited biomass supply potential. So otherwise, the model finds it more cost effective to go into biojet fuels only. But this was the aviation sector. We will also go into the shipping sector, having the same scenario cases, 2030 and 2050, and the same colors here also for the different fuels. So focusing on 2050, what do we see? Well, here we also see a lot of biofuels, and remember that both blue and green is biomass-based. It's liquid and gaseous. So here we get some use of gaseous biomass or biofuels as well in the shipping sector, which is partly due to the introduction of LNG at the moment in the shipping sector. But we also get, as I said, biofuels in all cases. We don't see any direct use of hydrogen, and the same conclusion as for aviation in terms of electric fuels, which is only introduced in terms or in the case when we have limits on the carbon capture and storage deployment, and also limitations on the biomass supply potential. So sort of similar results for aviation and shipping. But then, of course, where did the hydrogen go? Well, looking into the heavy-duty road sector and looking into 2050, there is more a mix, and the model has more trouble in deciding what is the cost-effective alternative fuel options here. And that means that the model thinks that this sector is sort of fairly hard or expensive to decarbonize, but also that the different options are sort of closer in cost relation. So it's more sensitive to changes here. So you see a mix of biofuels, you have electricity, and in 2 of the cases, or 3 maybe, you have some hydrogen, but in particular you have a mix of the different. And of course, this is when the model does like this, it feels that you don't have a very stable result that you want to do more analysis of. And of course, we have done that. But that was how it looked. And of course, the data in this model, we put it in, I think, two or 2.5 years ago. And of course, things have happened with the cost estimates for both hydrogen and electrification. And I should say that electrification here is both electric vehicles and also this electric road systems. It's represented here, even though we don't display the difference here, but both those cases. So it's a mix of those for the electricity for the road sector, and also for the electric road systems. There are, of course, new data here. So what do we see here? Yeah, when do the hydrogen enter and why? Well, the hydrogen enter in the case you have very limited biomass supply potential and carbon capture and storage limitations. And also when there is a fairly large introduction of hydrogen, that is due to the electric vehicles being more costly, and then that the fuel cell vehicles are not costly to the same extent. So there's a sort of cost benefit here for the hydrogen case when we tested that. So findings from this part of the study, well, you see a fairly low use of hydrogen for transport in most assessed cases. But as I said, for more assessments are needed before you can actually say more about the potential role. And as I said, electric fuels, which is sort of one way of using hydrogen, is cost effective under some circumstances. So we need to sort of update cost estimates to provide more new data to see if that will impact the results. And also globally, there might be a different case. This study is focusing on the Nordic case, where we do have a lot of biomass. Even though we limit it, we do have a lot of biomass. We also have a lot of possibilities to producing renewable electricity. And also, in more generally, sort of the future role of hydrogen will depend on the expansion of low carbon electricity generation, which is possible to a large extent in the Nordic region. It will also depend on the availability of sustainable biofuels. It will, of course, depend on development and cost for hydrogen-based solutions, and also the hydrogen demand in other sectors. And also the cost development of electrified options, of course, since that would be a competitive option. And also, as we talk about the development of carbon capture and storage, and in particular, I think carbon capture and storage applied on biomass and how that would be possible to use that, or how you're allowed to account for that. And also the policies and the design, because if there are policies implemented for a specific transport or transport mode, then of course that might help hydrogen or other options in that segment, depending on the specific design of the policy. But as I said, we have done more analysis, and these scenarios were actually launched just 1.5 weeks ago, so they are very recent. And they are part of a project called Nordic Clean Energy Scenarios, where the same model, this Open Nordic Science model, have been used and updated, and also to include more of the Nordic countries. But still, we're looking into pathways for carbon neutrality. So it's sort of the same basic behind it, but more newer data. And here is the result from that study in terms of the total hydrogen use in the Nordic countries, not only for transport, but for all sectors. And then you can see that there is a lot of hydrogen going into being produced or being used to produce jet fuels. And the black is the part that goes to industry, and you have a certain share going to road transport. You have a certain share going to synthetic gas, which is methane that is produced. And that is used for a range of different applications in the energy sector. And you have some that go direct use in the aviation sector, and some that is used directly in the shipping sector. So with newer data, there's a somewhat different perspective or different conditions for hydrogen in the Nordic transport sector. And I will briefly just end by showing you the introduction in a different part of the different transport modes. So if we start by looking at aviation to the right in this graph, you can see that the kerosene, the fossil is the purple, and then you have the biomass-based in the dark blue, and you have electricity in the sort of middle blue, and you have the electric or electrofuel part in the light blue, and you have hydrogen as red. And then they have two scenarios, one which is sort of just introducing the trying to restage carbon Nordic neutrality, and then they have one scenario where they sort of have more focus on having more electricity produced. But they are fairly similar in terms of aviation, and you see an introduction of electricity and biomass-based jet fuels, but also these electrofuels for aviation, but also a small share of hydrogen is found cost-effective in the updated scenarios. Looking at the shipping sector, for the two same scenarios, you also have some of the fossil fuels left also in 2050 due to the same reasons we've had earlier, and you also get some introduction of natural gas, but in particularly you get introduction of synthetic natural gas, which is based on hydrogen or bioenergy. So this could be either biomass-based fuels or hydrogen-based fuels. So both kinds are possible here, but they are reported in the same way here. And the most part of it is actually biomass-based in the beginning. And then you have some direct use of hydrogen for shipping that is found cost-effective. And the difference between two different scenarios is that the introduction is sort of faster in the second one when they go for more electricity-based scenarios. So here we do get a more sort of positive way of hydrogen use for shipping and aviation. But looking at the trucks, this sort of confirms David's conclusions that the blue here, or the middle blue, is electricity, and the dark blue is gas, and the red is hydrogen. So for trucks, there is a strong belief in that electricity will be the cost-effective, a small share of hydrogen and gas also in the end. So sort of to summarize or So my message is again, well, hydrogen might have an important role for Nordic transport, but partly or to a large extent as electric fuels, given the cost of the movement, and also mainly for shipping and aviation, not so much for road transport, as David also indicated. But the extent will depend on the policies, the cost development, and development in other sectors. And of course, as the questions earlier, we will get the answers. No, we will not get the answers today completely. We will, of course, continue to analyze this. And I would just like to mention short about the project that we had that is called HOPE, where we look at the potential role of marine hydrogen fuel cell solutions for regional shipping in the Nordic region. And also my final slide will be about this global perspective. Together with Selma at Chalmers and other colleagues at Chalmers, we do a lot of also assessments on the global level and the shipping sector. And there we see also an potential introduction of hydrogen to a larger extent, but in a more long-term perspective. But that is also sort of initial assessments. And here we also have the possibility to use ammonia in that sector. So we will come back to that another day. So thank you.
Thank you so much, Julia. And it's so now you have talked a bit about different parts of the transport sector and also about which form we could use hydrogen in. It's not necessary so that we use it in compressed form or in liquefied form. We could also use it in ammonia or perhaps in methanol as an electrofuel. We are a bit behind in schedules, so I think, but hopefully in the panel discussion, Julia, we might come back with some questions. But now I would like to introduce the last speaker, which is Bengt Johansson, which is a professor here at Chalmers and also director for CERC. So, welcome.
So, thank you. Just a sound check. You can hear me loud and clear?
Yes.
Very good. So, time to talk about how to use hydrogen if hydrogen would exist. Obviously, hydrogen do exist currently. It's one of the most used chemicals in the world, but it's mainly done by converting methane to hydrogen today. So I'm told that blue hydrogen is more than twice as common as green hydrogen in the world. The only problem is that that's 0.7% and green is 0.3%. So it's only 1% being carbon neutral today. So that's even worse than gasoline currently. So that's not good. But what's going to happen in the future? Well, who knows? I don't. No one knows. We're just speculating, all of us. But it's fun to guess, and why not do that? This is the estimate from IEA, and they have a sustainable development scenario from 19 to 2070. If you can guess that far ahead in the future, well, if you can, and this would be the estimate. They see that gasoline and diesel will go down quite a lot, meaning that 2070 there will be no gasoline used, very little diesel. There will still be aviation fuel, but there will be a big chunk of the energy from electricity. Exactly where the electricity is coming from is not specified here. It's only what form of energy being used in the transport. We see that the biofuels is estimated to be quite a long term into the future, as big as electricity. Hydrogen, well, coming late, but getting some traction. We also see ammonia and synthetic fuels. These will be then generated from hydrogen in one way or another. So we see that electricity is important, but it's never more than roughly a third of the total solution. So this is from IEA, and that's the total transport sector according to their estimates or guesses. This would be then for trucking, and trucking meaning long-haul freight. We see that there is a significant decline in diesel, so that's all good. We also see that the biodiesel fraction is quite significant, quite some distance into the future. And eventually hydrogen would be at least as big as electricity for all estimates based on the IEA forecast. So this is the sustainable development scenario. They also have business as usual scenarios, which are not that good. But this is trucking, so it seems to be that hydrogen will play a significant role, maybe being the biggest factor in trucking in the future. For marine sector, it's kind of the same, but not quite, meaning that it will still be a fuel not emitting CO2 when burnt, but it will be in a form of ammonia, meaning that you convert the hydrogen to ammonia. And that's mainly because of storage within the vessel. An ammonia tank is much easier to handle than a hydrogen tank. You don't need to have it cryogenic and so on. So neat hydrogen, yes, but it will be mainly ammonia kicking in. But we also see that there is a significant amount of biofuels also in the marine sector. So this is all global. Of course, you can divide it into regional, you can divide it into countries specific, but this is the global estimate. So the conclusions I would draw from this, even 50 years from now, electricity will not be more than roughly a third of what we need. We need to find solutions for the other 2/3. And that means we need sustainable fuels, and we need how to use them in the most efficient way possible. So where's the energy coming from? Well, we can make biofuels, I guess not in UK as much as we saw from the previous presentation. Robin Hood will be kind of disappointed, I think. His forest is not that big anymore. We do have a lot of forest in Sweden though, so in Sweden we can actually make a lot of biofuel as seen in the previous presentation. Electrofuels, that's something different, and it's maybe quite attractive, meaning that you can make the fuel where you have the energy and then you can store it. So this is quite important because electricity from the sun is becoming very affordable. I'm not sure we want to do that in UK or Sweden this time of year, especially not today. It's not that sunny. But there are plenty of sun out there, but maybe not exactly where you want to use the energy. So the problem in the future is actually not generating the energy as such, but store it. How can we store the energy so we have it available when we want to use it? We cannot expect to have a system that relies on instantaneous production exactly when we need the energy, not from solar or wind, at least. So I made kind of a fun calculation. I compared a fuel tank to a battery. A battery is quite expensive. I picked up my Tesla Model S. That's something like 30,000 euros. A fuel tank is like 20. If you fill a fuel tank, you spend more money than buying it. So the fuel tank is really inexpensive, and it's insignificant cost for the entire vehicle. There is really no mass, and it's not leaking. And when you fill up your tank, I did it actually a stopwatch last time I filled up my car, 54 liters in 80 seconds. That's 23 megawatts when charging my tank. That's a little bit more than charging an electric vehicle for sure, a couple of orders of magnitude at least. But the major problem is really the cost. If you want to store a significant amount of energy in a battery, you would spend a lot of money. We can see that if you buy a battery, you charge it, you have to charge it 3,000 times until you spend as much money on the energy as the storage device. I did a calculation. Actually, I wrote something different in the notes, but it's in the range of 4 years of the global GDP you need to spend if you're going to buy batteries instead of storing the US strategic oil reserve in terms of energy. So the strategic oil reserve in US is quite a big volume of fuel. And if you calculate how much energy would that be, it's simply not possible to buy that big of a battery. It's too much money. If you want to calculate the total storage or maybe the annual usage of fuel, it will be similar numbers. It's simply not doable. But electricity from the sun is becoming very affordable, and that's good because that means we can afford a little bit of losses on the way. So this is not forecast, this is actually sold systems, and we're down to less than 4 cents, meaning US cent per kilowatt hour for photovoltaics. And that's really good. It means that we can afford making fuel from the sun, where the sun is available in large quantities. So we don't need to store the energy in batteries. We might need to store it in hydrogen, but we can also go another step using the hydrogen in power to gas, power to liquid, using biofuel, or even direct air capture, meaning that you can run fans collecting CO2 from the atmosphere. That CO2 can then react with hydrogen from the electricity, and you get then an e-fuel price that is estimated to be about the same as you currently sell fuel for in Sweden, but that's including the tax. So if we would take away the tax, we already would have an e-fuel that would be cheap enough. So e-fuel, I would think, would come on. It will come on big. Of course, there is an efficiency problem, and that was highlighted by the first speaker today. But he kind of forgot that we also need to store electricity to have it available when we need it, and that would use the efficiency quite a lot also for the electric route. But even so, there is a significant drop in efficiency when we use the fuel and convert it to useful work on the wheels. So that's where my own research is coming in. That's the Sustainable Internal Combustion Engine Center. So that's an application we hope gets funded starting next year. It's a joint project, Chalmers, Lund University, and KTH, headed by Chalmers. So this is the background. It's a very busy slide showing the efficiency of a fuel cell. We were told it was like 50%, and that's about right. It's the red dots here that tells us what is the actual efficiency of a fuel cell system. The upper dots would be the stack only, but you need to have the entire system. So you can make a plot like this. This is my own added graph showing what is the efficiency as a function of load. And we can simplify that a little bit, taking away unnecessary information. And we see that at 20% load, yeah, it's 60%, so that's all good. But at 100% load, it's actually only 40%. So if you can afford 5 fuel cells, good. We have a 60% efficient system. But if you can only afford 1, and they're not cheap, then we're talking about 40 using the full power. And that you would do in a heavy-duty truck. So going hydrogen IC engines, I do not agree that it's less efficient. I would say that it's in the range of 40–45% or so with the current application at peak load. Then as you operate lower load, it drops. But this is the current situation. But then doing some research, why not? And this is the goal for this CSEC center. That's a hydrogen engine hitting 60% brake efficiency, meaning being on par with the fuel cell, but at full load. And that would be quite a game changer, I think. So let's make an IC engine that beats the fuel cell in all aspects, and that was also including the NOx levels, meaning it should be unmeasurable NOx levels. And we think we know how to do that. This is just a highlight from Volvo, showing that, yeah, it's going to be electrification in the future. It's going to be battery electric or fuel cells or a combo. It's shown as a function of how much energy per kilometer, meaning power pretty much, and yearly mileage, that means energy. So if you want more power, more energy, then it's going to be a fuel cell. But there is a corner of this plot that still will be dominated by internal combustion engines. And those will be the very demanding long-haul, heavy, long transports. So that's still a available, but my idea is to take a bigger piece of the pie. If we can make a hydrogen IC engine that beats the fuel cell, why not to do that in most of the applications and go battery electric where the range is sufficient for a battery. So the concept of achieving this 60% efficiency is to go back to basic thermodynamics, have extremely high compression ratio, giving us a theoretical efficiency of 80%. It's called the double compression expansion engine. I will not go into the details, only telling you that it's like a 10-year-old idea by now. And the basic idea is to use two-stroke compressor, two-stroke expander, and then pretty much a normal combustion engine in between. As I said, I won't go into details, just showing that it's a concept that is kind of ready. The only problem, we haven't built it yet. But it do exist in the computer world. And this is the evolution of brake efficiency, meaning from hydrogen to mechanical energy. And we are seeing that different concepts, again, not going to go through details. It starts at a little bit more than 50, and we're now in the range of 60% brake efficiency estimates. Of course, then we need to build it, but that's another story. We will not do only this. CSEC will work with other aspects of the internal combustion engine. We would do the combustion process, gas exchange, system integration. We will do hydrogen, since 60% efficient IC engine with hydrogen is not existing currently. But we're also planning to do the same with biofuel, e-fuel. And then, of course, when we have carbon in the fuel, we need to figure out how to get rid of soot, etc., meaning local emissions. So there will be areas with diffusion combustion, pre-mixed, dual fuel, focusing on gas exchange, noise, and also exhaust after treatment, mainly if we are not burning hydrogen. With hydrogen, I think we're kind of done. Well, improve efficiency, obviously, below ambient emission levels. That's already there. There are engines out there cleaning the air, and they're quite common, actually. Most people don't know that. But we're also going to go into the details, understanding the injection pressure, how the injection pressure controls the injection as such. How the fuel and combustion interact, and so on. So we have 3 centers currently, and they will be joined into this CSEC consortium, well, provided we get funded, of course, but let's hope for that. Decision hopefully next week or so. So the summary, there is no future for fossil fuels. Most, but not all, light-duty cars will go battery anyway. Heavy duty can't do that because batteries cannot store enough energy. We need something else. Fuel cell is the norm, but I think the IC engine can actually compete. The marine sector will not replace the IC engine anytime soon, but we'll look at sustainable fuels. We will also actually work with handheld equipment, meaning chainsaws, where battery also will be too heavy. So we're going to do this hydrogen converter, but also work with other fuels. So with that, since we're running a little bit late, thank you for your attention.
Yeah, thank you so much, Bengt. And would be interesting to see if you will manage with making this very efficient internal combustion engines and to produce it in the future. I think that I would now like the panel to move up here. And while the panel is preparing, I have a question to you in the audience. And I mean, now we have heard 3 speakers giving different arguments for and against hydrogen and talking about different parts of the transport sector. It would be interesting to hear what you in the audience think. In which part of a transport system do you see hydrogen playing an important role in 2050? So now, in a way, I will also force you to think a bit ahead. Think about how you think that the transport system could look like in 2050. So you can then go in at menti.com and use the code that you see in this slide, and then tick the different parts of the transport sector where you think we will see hydrogen in 2050. And hopefully we will come back to this in the end of the session and see the results. And now I'm very glad that I have a panel session here live in Runan at Chalmers. And I would like to first ask Monica Johansson. You are working at AB Volvo, and you are working with all different kinds of fuels that are used in vehicles, and also thinking about the fuels that will be used in the future. I also know that you are looking into hydrogen infrastructure recently. So it would be very interesting to hear what you think about the role of hydrogen in the transport system.
Okay, thank you very much. Thank you for inviting me to this session here today, and I think it was very brave of you, Selma, to also have David presenting, because this is a hydrogen session and he was not in favor of hydrogen, but still I think then it can be very good discussion, so really good. And at the Volvo, so what do we do at Volvo? Yeah, we are looking at different aspects. We're looking at climate change, how to protect cities from bad air quality, and how to, meet our customers when they are asking for sustainable transport solutions. And we are looking at many different aspects and developing electric vehicles that we do to eliminate these local emissions in the cities. And electric vehicles, as we know, they can be both batteries and also operating on fuel cells. And as we heard from Bengt, also we can have hydrogen in combustion engine, but then they will not be zero-emission vehicles. And from the Volvo side, we don't see that the BEVs are competing with the fuel cells, because they will be operating in different segments. As Bengt here already showed this figure, when we have this different segment where we will have BEVs, we will have a fuel cell, and we will have internal combustion engines in this different. And they are not competing with each other because there are different customers and different behaviors. And depending on what you will use your vehicle for, if you are returning to home base every night, you can charge it. Very good. But if you are not returning every evening and you cannot charge at home, then the electricity will be very expensive. And then you will have another solution. And then if you refill your vehicle with hydrogen, then you're not depending on charging infrastructure. Of course you need hydrogen infrastructure, but you don't need as many refueling stations as charging places. And also, I'm sorry, I can talk forever, but I will just wrap it up now that Volvo has started a joint venture together with Daimler in order to speed up the development of fuel cell system, and also in order to reduce the price of the fuel cell system. We have also started a new company called Volvo Energy in order to work with the battery and the lifetime of the battery, the charging infrastructure, but also the hydrogen infrastructure. And we are very keen on using green hydrogen, because if we want to go from fossil-driven vehicles to renewable, the key is green hydrogen, of course, and we are pushing for that. And we also have a collaboration with Ovako in order to get this mid-Sweden hydrogen valley. But I can talk for that maybe in another session. So, thank you.
Oh, it's very interesting with all your new things. You're looking, new investments and new directions and investigating hydrogen. And that you also actually see a role for hydrogen, even if we perhaps didn't see that so much in the presentations.
Yes, we will go for large-scale production of fuel cell vehicles starting in before 2030 and after 25.
Yeah, really interesting to see that development. Yeah, it's really soon. Now I'm also very glad to have Per Stefensson here from Stena Teknik. He has worked a long time. We were looking into different fuels for shipping, so for marine transportation. I mean, we met each other when we talked about methanol a long time ago now in a research project. But it will be really interesting to hear if you have some ideas of how Stena or you look into hydrogen. Will it be a possibility in shipping, do you think?
The short answer, not in a short term anyhow. Maybe in the future, I don't know. But as we have heard before here, hydrogen is it's quite low efficiency when it comes to produce it from. Do you say sun to wheel nowadays, or what do you say? Or sun to wake. So that is one of the problems, of course. But the big problem is that it is so difficult to handle. It's if you have it compressed, it's still enormous volumes. If you should cool it down, I mean, it's close to the zero point. So it is extremely difficult to handle. So to for instance retrofit a ship for hydrogen, that would never be possible. And then of course we have the problem with the shipping that a ship lasts from between 20 years for a tanker up to 50 years for a ferry and a cruise ship. So in that perspective, we need to have fuels that we can retrofit ships to use. So, but then we are talking also about batteries, of course, and electricity. And when it comes to short routes, like from here to Denmark and things like that, then we are definitely looking into batteries as a good way of doing this. So we have already tried with a smaller battery on 1 megawatt hour on Stena Jutlandica to see what that could do, and that is for peak shaving, meaning that we don't have to start extra auxiliary engines when we are approaching shore and so on. So, and that has been very successful. And now on the table right now we have a concept study that we call Stena Electra, and the plan is to have that built before 2030. But when it comes to the hydrogen, I think that everybody is really staring blind on the coal atom in all the other fuels. Because we heard we can do carbon capture and we can do carbon capture and reuse actually. So if you capture carbon from the air and you put it into a fuel and then you let the carbon out again, that's circular, wouldn't it? So in that way you could actually, you mentioned methanol, and we have of course made good progress with methanol. We have Stena Germanica, which is running on methanol. And that is much easier to handle, and we have infrastructure that could take care of it and everything. And the same goes for ethanol. And I mean, we could also do electrofuels like gasoline and even diesel. And in that sense, it would be much easier to use it on a ship. So this hype with hydrogen, in my view, it is that because everybody is staring blind on this with the coal atom. But coal is not poisonous, and we have it around us all the time. So let's just circulate it, and technology would be much easier to solve. So that's my conclusion, actually.
Yeah, you're having a point that, and it's also, I guess, a bit towards regulation, because a lot of regulations today are targeting that we should have zero carbon emission from the tailpipe. And if we have that regulation, that will steer us towards solutions that are without any carbon atom, I guess. Okay, did you have anything, was I interrupting you?
Well, somebody mentioned ammonia also. Yeah. And I have been participating in the risk analysis about ammonia, and it won't come on our ships for a while, that's for sure. It's extremely dangerous and so on. And it's the same thing there. It's just because it's not a coal in it that everybody is talking about ammonia. But come on, the technology and so on, why should it be so difficult?
Yeah, ammonia is a lot of challenges with.
Yeah.
Definitely. Okay, I would also now, we have an expert on aviation, have Professor Thomas Granstedt here, and you maybe have a different view of hydrogen. It would be interesting to hear what you think. your thoughts. You have thought a bit about this, I know.
Yes, and I'm then served the interesting task of trying to end this and strike a positive note for hydrogen, perhaps. I'd like to start by explaining where aviation came from a little bit, not the long history of aviation, but a few notes. I worked with a project called Ultimate for a number of years, and then we were like Bengt aiming for the ultimate engine, the high efficiency engine, because we looked at 40% efficiency, maybe we could go up to 55-60% efficiency, but then we saw the European goals in aviation that we weren't able to even reach our own targets. There wasn't enough technology that could actually do those 2.5% per year. That's really, really hard to do. So we were starting to look at different fuels. Actually, before people were going back to hydrogen, we were a few years ahead, actually, this time around. And then we saw that, yeah, this could be done. It's flown in the past, and it is less energy consuming than if you're going all the way to electrofuels. And then we discovered that some of the work we did in heat management could actually be used quite well. So you can find some advantages for hydrogen if it's cryogenic, which you do not have with electrofuels because it can recover heat from the engine, and that's a fair synergy there. So that can help actually to make it more attractive. Yeah, that could be a long talk. But then we looked at cryofuels and the impact on climate. Maybe methane is better. I would say hydrogen now, but it's very difficult to say actually. But I think that could be a long talk also. Let's go for uncertainty. Bengt had a very nice point, I think, by saying that we're all guessing about this, and of course that's a bit provocative, and I will end this in a provocative tone. I think it is a bit provocative to say that we're all guessing. So I'd like to remind you of some of the certainties we've provided in the past. When I started in turbomachinery, I was told that wind power was crazy, because we needed like 10,000 plants to replace a nuclear plant. And now there are 15 megawatt plants around, and this is happening. 5 years ago, EVA issued a report about our need for electricity. And then they said, well, it'll be between 140 and 180 terawatt hours. And now we were speculating maybe we need the double. So we are not very good at this. 2 years ago, I was proposing let's bring up hydrogen for Chalmers pitch for COP25, and people were like, hydrogen, really? And now now we're there. We'll almost pass this discussion maybe. So then let me end here by bringing the question back to Professor Sebon. I heard in preparation, I heard your speech in the Parliament hearing, explaining pretty much the Achilles heel of hydrogen, that it's low efficiency. And then Bengt started a little bit on the note that, yeah, but if you really want to store a lot of energy to get a stable grid, then it looks like a possible solution, maybe, or you need something else, but hydrogen could be a way. So my recommendation then would have been not that one, but it would be a bit like electrification helps you to reach the targets, but hydrogen helps you to get re-elected. Because you don't get into those problems that we are already facing in the Swedish electricity grid. So yeah, that's my pitch for hydrogen. See if there's some comments back.
Do you want to comment, David? Do you want to say something?
Yes, I'd be pleased. There's all kinds of speculations I've heard about today about a compression ignition engine with a compression ratio of 60-1. The tried diesel engine community has been working on building the compression ratio of their engines. They've managed to get to 22-1. So Bengt is proposing a 3 times better compression ratio than any diesel engine manufacturer has ever achieved. He says, all we need to do, we only need to build it. Well, keep going with your calculations, Bengt, because I don't think you're going to be able to build a 60-to-1 compression ratio engine. But that is not the question.
That part has already been tested, but we don't need to discuss if I'm able to do that or not. But
the problem is the weight, because the thickness of the walls of a 60-to-1 compression ratio engine makes it prohibitive. So, but anyway, there's lots of fantasies here. There's lots of speculation about what we need to do. I think the idea that we have to use hydrogen because we have to store electricity is not correct. It's absolutely right that we have to store electricity. There's no doubt about that. In a renewable future, we have to store electricity. If you're going to store electricity, you need to store it. The storage system that will win will be the one which has the lowest costs, the lowest cost of storage of electricity, because it will have to be paid for by purchasing electricity when it's cheap and selling it when it's expensive. And in order to make a business out of that, you have to have the lowest cost of storage possible. Now, it is possible to store electricity by hydrogen. When you do that, you go through the process of electrolyzing water, generating hydrogen, and then putting it back through a fuel cell. You only end up with 30% of the electricity back again. There's a 30% round trip efficiency. Now, there are other storage systems that have 70 or higher percent round trip efficiency. For example, you could use a flywheel. You could use compressed air storage. You could use pumped hydroelectricity. You could use liquid air storage. All of these have higher round trip efficiencies than using hydrogen. And that means that in all of those cases, and I've looked carefully into this, in all of those cases, the cost of storing electricity is far cheaper than doing it by hydrogen. So if your problem is storing electricity, hydrogen actually isn't the answer. The answer is something much cheaper and more efficient than hydrogen. And there are a whole set of possible technologies that you could use that would be much better investment for anybody to make for storing electricity. So just because you have to store electricity doesn't mean you need to use hydrogen.
Okay. Yep.
Quick comment. Yeah, I'm not sure that you want to store it in hydrogen, but if there was a 4-day slump in production of renewable energy in Germany a few years ago, if you need to store 4 days of to be able to supply the German electricity grid for 4 days, then how many flywheels do you need?
Okay, let me just make an important point here. You said there was a 4-day slump a few years ago. So once in 1,200 days, we've had a 4-day slump and you needed to store that electricity. So are you going to design your future system for a 1 in 1,200 event, or are you going to do something a little bit more practical in engineering terms and design it, say, for 90% of cases? If you design it for 90% of cases, then what you need to do is you need to store 1 day maximum. You need to level out the curve for 1 day. And if you really have a 4-day slump, then what you do is you leave your combined cycle gas turbine system, which already exists, where you've already paid for the embodied energy of it, and you fire it up for 4 days in 1,200, and you, as a consequence of that, you burn a little bit of carbon, and you put a little bit of carbon in the atmosphere. The perfect is the enemy of the good here. If we have to make a perfect solution, which accounts for every single bit of carbon, and we end up, as a result of that, building this hydrogen infrastructure, which is going to waste energy, which is going to be polluting and expensive, have huge embodied energy. If the whole reason for doing that is to cover 4 days in 1,200, then as engineers, we have failed. As engineers, we're responsible for making sure that we do the sensible, high-impact, efficient things and not go for perfect solutions to account for 4 days in 1,200.
Yeah, but from reality, in a way, we know that we not always get the perfect, right? But okay.
Last attempt then to shed some uncertainty at least. My plan was not to have this rigid build of 5-year plan developing of the electricity grid, but that hydrogen can grow into the electricity system, and that it might play that role. And as you said, with gas turbines, we get a really good efficiency. And something that we did, there were very many things that we didn't discuss today. For instance, synergies when you're combusting hydrogen or when you're using hydrogen. It's all the numbers are assuming that you don't use oxygen for anything when you're doing electrolysis. And another thing which we have problem with is capacity. I mean, you can sell any battery today if you can build it, because everyone needs them. So you don't have to be the best, or you don't have to. It's if you have production of batteries which meet a certain quality standard that 20% more expensive, you can sell them. So I don't think you can draw all conclusions from cost, but.
Yeah, and Per Stephenson wanted to say something as well.
No, I'm coming back to this again, that everybody is steering blind on the coal atom. I mean, wouldn't it be better to have a commodity that we could use as fuel? We could use it for energy storage and of course hydrogen carrier and things like that, and have that and use it with the kind of infrastructure we have today instead of building a new one. I mean, today we can fuel in Sweden ethanol in every gas station. It would be so easy to continue with that and have ethanol instead, or methanol if you want. You could use the same infrastructure. So in my mind, it's crazy that just because some politicians cannot understand that we have coal around us right now and we could use it and we could give it back, just because they can't understand that, everybody is now hyping around this. And by the way, the first time I heard about hydrogen in this new version, that this is what everybody should rely on, guess who was speaking about that? It was, of course, a gas company, because they want to continue to drill for gas, and then this is, as somebody described here today, they will distract the hydrogen from the gas, and they will pump down the CO2 in the hole again. That's their way of surviving. So I mean that is really where this all comes from. If I should be a little blunt.
Yeah, maybe it's. I mean, I heard that argument as well. That's where it's coming from. I'm also thinking. I mean, when you're saying other, I mean, if we're going for direct electrification, of course, it will be much more efficient. But if we can't do that for some reasons in some part of a transport system, when we need other energy carriers, and if we're going for converting hydrogen to something else, like methanol or like ethanol, if that's possible, that will also cost energy, and that will also then be a problem, a challenge with its efficiency. Okay, I think Bengt wants to say something.
Yeah, I think the reason we are talking about hydrogen is maybe the European zero-emission vehicle concept, meaning that the legislation in the European level is focusing on the vehicle CO2 emission, and they then claim that if you have a battery electric vehicle, the CO2 emission is zero. But it is kind of a wrong labeling, because you cannot use energy without producing energy, and there is no way of producing energy without the CO2 impact. So all energy usage would have a climate impact, even wind, even solar, because you have to make those devices, and that would generate some CO2.
But potentially in the future, we have another system and another way to produce steel. Maybe we can have very
No, but it will never be zero. It will be
probably
low.
Never zero, but it will be lower. I'm sorry for interrupting you, Bengt. I'm just see if we can get the Menti slide. Is it possible to show that now to see what the audience said? See if someone can help me with that, because now we are ending up. So just then. What did your audience think? So now I have problems to read. Maybe you will see better, but if not so many think that we will have it in light-duty vehicles, more in heavy-duty vehicles, and also for deep-sea shipping. Maybe that was not that many that answered this Menti question as well. And then we have some, seems to be a bit, now we got more people also wanting to shift the
Any
dynamic.
way of changing the font size? I cannot see the text under the bars.
No, I am sorry, I couldn't do that. But it's first light duty, so then it's heavy duty, then it's short sea shipping, deep sea shipping, rail, then it's regional aviation, intercontinental aviation, and the last is nowhere in the transport system will we see hydrogen in 2050. So it's also some of you that think that. Okay, we really need to finalize this session, and I'm sorry that I didn't have time to go back to all of you again to say some final words. I'm really glad that you were here, and it's really a lot of interesting arguments, and I would like to myself go back and do some calculations and compare the different efficiency values in my own models and see, because I think we're starting up with the same some basic understanding of the world, but then putting it together we come to different conclusions, and it's interesting, and it's a lot of things that is put together. So now we are soon going to have a 15 minutes break. But before the break, I would like to just bring Magnus Granstem up here. And maybe you can tell us a bit about what we will hear after the break.
Thank you very much, Selma. I'm happy to do that. And we will shift focus in the sense we will look at another aspect of the transport. We will look much more into each and every individual. How do we get people to move by themselves, and also using a different type of fuel, that is, because we are talking about food and drink. So we're looking at how can we make sure that people actually move in an active way, that you use your own power inside your body, and what are the hindrances, what are the incitements, and so on, from a research perspective, from a authority perspective, and also from a company perspective. So that is what we will do in about 15 minutes.
So it will be very interesting then. At 11 o'clock we start again, so now it's time for a short break.
Very welcome back. We hope that you all had a chance to grab a cup of coffee, a cup of tea, or whatever you wanted to have in this short break that we had. We will now talk about sustainability. We will talk about sustainability from a safety, health, environment perspective. And one of the things that many of us see, we read reports, we see this in the newspapers and so on, that we need to move, we need to be active. We have problems with obesity and so on. So how do we deal with this from a transport perspective, from an individual perspective? How can we make sure that we actually do this, especially in our part of the world where we really have these issues and problems? So that is something that we will dig into this hour. We will do it from different aspects, as I said before the break. We will also try to answer at least some questions. We will probably raise new questions as well. So what do we actually mean by active mobility? When are we active and when are we not? How do we do this? What do we need in terms of the environment, the infrastructure, and so on. So some of these things are what we will talk about here now during this hour. And again, please feel free to raise questions during in the YouTube channel, and we will try to pick them up, and then we'll see how many we can actually handle and answer. But anyway, please provide us with different kinds of questions during this hour. And first of all, we will listen to Marianne Karlsson, professor, Design and Human Factors here at Chalmers. So please, Marianne.
Thank you very much. As you see, the title of my talk is Changing Behaviors, How Different Perspectives Lead to Different Solutions. And I would like also to acknowledge my colleagues at the division, Helena Strömberg and Pontus Wallgren, who have been involved in thinking around this topic before putting the presentations together. I think I'm going to focus on cycling, which is one way of being active. Active mobility, the case of cycling. This is, of course, one way of being active. These cyclists look very energetic, and they probably cycle for different reasons, including health. These are other cyclists on their way to work or on their way home, perhaps. And the reason here is probably not only to be healthy, but probably just to get from A to B. And we know the pattern of cycling, it looks very different if we look into different parts of the world. In Netherlands, we know that perhaps 30% or maybe more of all trips are actually made by cycle. In the US, it's maybe 2 to 3%, and in Sweden, it may be 10 to 15. We also know that the pandemic has heavily influenced the number of cyclists, which is in a way a kind of positive effect of the pandemic. I read a note from the UK that they noticed 100% increase in the number of bicycle trips made during weekdays, and I think 200 during weekends. So it's a drastic increase. I said then the reasons for cycling can be many. From a societal point of view, it is, of course, one is environmental reason. We know that biking is definitely putting less footprints down on the sort of the soil of the earth. We know that we have less emissions, etc., etc. Less noise pollution is also part of the deal. We know that cycling is space efficient. It's space efficient in terms of, for instance, just parking places. How much space does a bike need in comparison to a car or a SUV? We also know that it's sort of space efficient in active moving around. You can sneak by cars and you can sneak by queues and actually maybe get faster to work than you would if you had been sitting in a car or on the bus. And we also know, and I think other people will mention this too, that it has positive effects on health, both in terms of the cardiovascular system, but also in terms of mental health. So, you know, from a societal point of view, there are all these positive effects of cycling. But are these actually what actually motivates people to cycling? They're probably part of the deal, but maybe not the whole package. So when we're trying to, in a way, change people's behavior, travel behaviors in general, there are different strategies put forward in literature. They are sometimes mentioned structural interventions or strategies, psychological interventions, informational interventions, or simply pull and push measures, depending on who is describing them and categorizing them. Now, me and my colleagues made a slightly different categorization, but we can see that those categories that we have made also pop up in these references. And the reason is really that we see anything as a kind of system. Anything of activity that goes on is a system, which includes people, the tools you use, the goals you have, and the context in which those activities are taking place. Now, if we take one very, very common strategy to try to influence people's travel behavior is by addressing attitudes and addressing knowledge. I could say also that it belongs to certain disciplines, but I think that is sort of narrowing the topic. This is a very, very, very common way of dealing with behavioral changes, all in all. So what could this include? What kind of tools do we then have in our hands? Well, typically we have awareness and information campaigns of different types. So, and this goes on, this takes place all over the world, in Sweden, in Denmark, in the US, in Australia. You see different types of awareness campaigns and information campaigns to encourage people to actually start to bicycle or maybe to bicycle more. Will this help? Will this take us all the way? I put the question down and then we all can have a little thought about it. Another sort of trying to address knowledge and attitude is actually to develop different types of information services, sort of providing information on cycle routes, for instance, and how to take you from A to B using the bicycle. This increases perhaps people's knowledge about what one can do, but it also requires you to actually pose the question, can I bicycle? And if you don't even do that, then these services provide no sort of push effects or no pull effects either. Now I will jump one slide and I do it deliberately, so don't worry about it. What I want to stress here is that when we do address attitudes and knowledge, of all the different parts that we can work with in the system, we only work with the human being and what goes on in his or her brain. We're trying sort of to make sure that you change these ideas of and put sort of cycling as part of what you do, but you don't actually change any of the other parts in the system. And that's why we think that maybe this is not the most efficient way to go forward. And I think that if you look into research on these matters, you can also see that there are limited effects of these type of information campaigns, and attitude doesn't always predict behavior anyway. The second approach would be different kind of incentivizing. And what do I mean by that? It's providing kind of incentives to take on the change. We have competitions, which is one way of doing it in terms of, for instance, Sweden, we have something called Cykelutmaningen, which is a kind of a commercial company behind, and we have different municipalities and companies that organize this, and in order to encourage employees to sort of support each other and compete against each other in order to cycle more. Part of that is often different types of trials, allowing employees, citizens to try things out. And actually now here in Gothenburg, we have Västtrafik, which is the public transport company, who's trying actually to recruit people, 400 cyclists, to also come and sort of continue cycling during the winter by providing them with some equipment. But there are other trials going on, not least in Sweden, to sort of handing out bikes for loan during a certain period of time, just to allow people to get acquainted with the idea of cycling without having to invest in a new cycle. So you can, if you're not happy, you can leave it and go back, or you can invest in your own bike. If you've started bicycling, you know that some people are incentivized by rewards and feedback. So they might still continue to bicycle and compare themselves to others in a way that, or against themselves and their own performance, gaining, for instance, different types of green points that you may exchange for a sort of glass of juice somewhere in a coffee shop or similar. But there are also those rewards or feedback systems where you gain points so that you can take a trip by airplane to another place. So, what you do with these green points can be discussed. There are incentives and disincentives. Quite a lot of the disincentives are economical. So here we have, for instance, the fact that we sort of add tax to the other alternative, like petrol, fuel, or in congestion charges, is a kind of way of desensitizing if you're taking the car and sort of pushing you towards other less or more economic alternatives. But again, I would say that even though you provide people with maybe equipment in terms of lending a bicycle, it's still mainly what you want to do is changing the way people think about it. You don't really address any of the other parts of the system. Why? And this is maybe why we see contradictory results in research, but there doesn't appear to be a kind of long-term sustainable change, even though for the larger part. For some, yes, for the larger part of those who try new things, no. So maybe we argue from a design perspective that we need to take on a more enabling perspective. And what does an enabling perspective mean? Well, it means addressing all the other parts in the system that need to be there. Because if we start to bicycle, there must be something there that responds and enables us to continue to do that. And I just want to mention briefly that quite a lot of people talk about that it's too far to bicycle. We just looked it up, one of Trafikanalys reports on how far people or how long people have to bicycle to get to those main parts. And you can see that the majority of, at least Swedish people, live within a 20-minute cycle ride from work or to the grocery shop or to the elementary school, wherever you now take the bike. So too far can be discussed. But nevertheless, why people don't cycle? And this is really where we think about, okay, so why don't people cycle? What do they argue? Well, most of these things can actually be addressed. And why I sort of want to push this idea about the enabling approach is that a couple of years ago, I read a super interesting paper from Danish researchers who had actually taken on to say, okay, here we have a group of people, they don't bicycle, even though this was Denmark, where lots of people bicycle. Why don't you? And they started sort of to tick all the boxes. Well, I don't have a bike. Well, here you have a bike. Okay. I don't have anywhere to put my luggage. Well, here you have something to put your luggage in. I don't have rainwear. Here you have rainwear. So slowly but surely, all those thresholds were sort of, cut in pieces, and they actually got people to start bicycling. And then the full kit was there. So this enabling perspective is saying, what do we actually need? Well, we need bicycles. Bicycles can look different. I mean, there are different types of bicycles for different people with different needs. a study that was made by my colleague Helena Strömberg, she discovered that that was actually one of the challenges, because people really didn't know what bike to choose. They really didn't know what the available sort of market looked like and what they really could choose from to fit their particular need. It could be a tricycle, it could be an electric bike, but it could also be something else. Infrastructure is, of course, super important, but it's not perhaps the determining factor. Here we have examples from the Netherlands, which is a fantastic country to go to look into what they've done in order to enable cycling, because they've really set out to design an infrastructure that is not cutting pieces away from the cars necessary, but actually creating cycle routes and roads and cycle roundabouts, which is something that I haven't seen anywhere else. But infrastructure can also quickly discourage new bicyclists, both in terms of, for some reason, putting up a signage there, or for another reason, put all the snow in a heap that covers just the end of the cycle route. So maintenance is super important. So is shelters. I mean, if you can't put your bike anywhere when you get to work, you can't protect it from snow or etc. You can't protect it perhaps from theft. You may not choose the bicycle because the car is actually more safe than the bicycle is. Do you have the proper clothing and other protective wear that you need? Do you have showers and changing rooms? And do we have bags or satchels or whatever we need in order to transport things, including children, perhaps to daycare, etc.? What we have discovered is that we think that people know all this, that they know what to choose and they know what they need. But actually, what we have found is that they don't. That some do, absolutely. They're very aware, those who already bike, I would say. But if you're on the sort of route to bicycling, if you're trying to acclimatize to bicycling, you really need support in finding and choosing. So still, information is super important. Trying out things is super important. But in order to sort of get people all the way, we need also this to help them find and choose the proper equipment. And here we sort of deal then with the other side in this system. We deal with the equipment, we deal with the infrastructure, which actually could also make changes in people's head. But we think that this is a more sustainable way forward. But this requires collaboration. And it's a bigger project than merely a new campaign. We need collaboration between planners, travelers, employers, policymakers, manufacturers, maintenance organizations, but also, and I forgot that, sales staff who need to be more knowledgeable, not on selling bikes, but on selling cycling in order for this to move forward. And we believe it can, but awareness campaigns will probably not suffice. That's our message. Thank you very much.
Thank you very much, Marianne. I'm checking here also to see if we have any questions from our audience. I can't see any at the moment. So I have a couple. I will only say post one of them right now. I will save the other ones for later. Okay. Because now you have focused on sort of going by bike, cycling. How general do you think that your results are? Can we also discuss the same kind of behavior and incentives and so on when it comes to walking and running and so on? Or
as a researcher, if you haven't studied it, you're very afraid
yes,
to
exactly.
say anything about it.
It's a nasty question, yeah.
No. I think parts of what I said probably true, but parts are not. But I think fundamentally this idea about an enabling approach rather than pushing or, well, using a little more about pulling, but not only pulling and there's nothing there, but pulling into something that's there and enables you to continue. It's like public transport. You have this fantastic personal timetables that tell you that the bus runs past me twice, or maybe only on Sundays. That, So the information won't help unless there is something there. And lots of things are happening, so I'm not saying it's not. Lots of things are happening, but I think we need to join forces and work more together in order to sort of set up a system that works. I think.
Good.
We think.
Thank you very much. We have another aspect that we want to talk about now, and that will be done by Jolyon Carroll, who is a biomechanical specialist at Autoliv. And one thing that kind of remains the same, even though a lot of things change, our bodies are, well, they do change, especially over time when you get older. But anyway, one thing that remains is the kind of injuries that you get. What does the body actually, what can the body handle and so on. So we need also to protect ourselves and those around us when it comes to these kinds of moving actively. So please, Jolyon, I'm handing over to you.
Yeah, that's great. So thank you, Magnus. Thank you for the introduction. It's a real pleasure to be able to talk to you today on this next part of the Chalmers Initiative seminar. And as Magnus introduced, the topic for my talk is going to be who to protect, what to protect, and how to protect them. And I think this is kind of a nice follow-on from Marianne. So let's go through. I've got a relatively straightforward outline to my talk. I'm going to start with an old story, a little anecdote, but then I'm going to get into the main bulk of who, and that means the modes of transport, what, the injuries that people might sustain, and then the how, the countermeasures and the safety solutions that might be available to us. And I'm going to finish giving a bit of a thought about what might come in the future and where the research needs are as well. So let's start with this story. I'm going to take you back to a time when cycling wasn't quite as popular on the tips of people's tongues as maybe it is right now. So it's the middle of the 2010s. And at that time, we had this situation in London whereby 3/4 of those killed or seriously injured were vulnerable road users. And at the same time, the mayor of London at that stage, who was Boris Johnson, announced quite formally his ambition here to increase cycling by 400% in a 25-year period. Now, on the face value, that's a little bit concerning, because if you're just going to increase exposure and not take care of the risk, then I think that's going to end in a bad way. And we were a bit worried about that. And so were Transport for London, who commissioned a bit of research work to have a look in that. And this, I think, is kind of a flagship study to have a look at historical trends and try and project things into the future. And the thing that made it very interesting was the access to exposure data. So we knew how far people walked and cycled, how far they took trips on tubes. We actually knew how far they drove their cars by car. And we also knew the casualty involvement for those cars as well. So it's kind of unusual to have all of those data available to us. And it really allowed us to dig into how casualty trends are evolving by segment of car and look what that meant for kind of collision risk or casualty risk for pedestrians and pedal cyclists, as well as car occupants. And what you'll see from the figures here is that whilst there are fluctuations, actually things were pretty static over a 4 or 5 year period. And actually for pedal cyclists, there was not very much changing in those, the severity of outcome over a big, long period of time. So despite those fluctuations, what we did is we projected things forward. We looked at how pedestrian casualties might change in the future if you had more advanced emergency braking or improved secondary safety. And what I'm going to tell you here in my anecdote is that we got it wrong, and we got it wrong in quite a big way. So we suggested that pedestrian casualties may be pretty flat, but actually rather than 500 of them in 2019, there were 1,350 killed or seriously injured in the roads of London. And whereas we were worried about this 400% increase in cycling, actually cycling casualties went up in only a modest amount, 6% over the historical baseline, despite cycling as a mode of transport increasing hugely in a 5-year period. So my conclusion from that is really to say that all of the pillars of the transport system are important when you're predicting what's going to happen to casualties and transport safety. We had concentrated on the vehicles, and there was a little bit of road user behaviour modelling implicit within that, but mostly it was focusing on the vehicles. And so that doesn't account for how people would use the infrastructure and use cycling superhighways across the capital of, and how speeds in London might change and how that might influence risk. So we'd done one part very well, but in fact we'd kind of neglected some of the other foundations of a safe system. So that's my anecdote and kind of setting the scene. But now I'm going to move on to think about actually where are the safety needs right now. You will have seen figures like this before. So this is a breakdown of road user groups within the 1.35 million fatalities that occur on the global roads each year. At the top, we have pedestrians and car occupants, motor vehicle occupants. And they also see contributions from motorcyclists and cyclists. And that won't be news to anybody in this event, I don't think. We also understand quite a lot about kind of the historical countermeasures, as I've said in the introduction. So we know that lives are being saved by seatbelts and airbags for car occupants and light trucks. And that's really important. And it's something that Autoliv is very proud of, our contribution to safety through that. But if we look about the whole picture of these 1.35 million fatalities, where are we going to go in the future? If we're really picking out seatbelts and airbags, that's good for car occupants. So we did a little bit of more modelling work to have a look at assumptions about these interventions. We can run through applications in case-by-case analyses and pick out residuals, what's left at the end of that. And if you do that and look into the future to 2060, the business as usual case here is that there will be 2.3 million fatalities on the roads each year. A worrying number for anybody in road safety, I think. The good news is that if 100% of the fleet is fitted with state-of-the-art driver assistance systems and occupant protection, that's going to have a big impact. That's going to have a big impact on our car occupant proportion of this. But we're still left with these pedestrian fatalities. We're still left with a big volume of power two-wheeler fatalities, and we're also left with those cyclists. So the next part of my talk then thinks about what about those road users do we need to protect? Where are we seeing those injuries and what can we do about it? So starting with the pedestrian, we can study that in a bit more detail. We have to look into the in-depth collision data, and the source of information we use comes from GDAS, the German in-depth accident study. And here I'm going to show a couple more figures of this type. And there are three bodies. They show all injury severities on the left-hand side. The middle one is serious, at least seriously injured. And the one on the right is for those fatal road users in that group. And here for pedestrians, you can imagine that if you're hit by a car, the first contact is going to be with the leg. And we see a lot of lower extremity injuries. 45% of all injured pedestrians will have a lower extremity injury. As the severity of outcome increases, we see a transition from the lower extremity to the chest and the head, so that by the time we look at fatal cases, a quarter of those will have an injury to the chest and 30% will have an injury to the head. Those become the dominant priorities at that level. Quite a similar scenario for the motorcyclist. Here we've got a more even distribution of injuries when we think about all severities. It's even across lower extremities, the legs, upper extremities, the arms, the chest and the head. But again, if it's talking about those cyclists who are killed on the road, then the trunk, the chest area and the head become the real priorities. Finally, the third of these groups is the power two-wheeler riders. Here, a huge number of all injuries will occur to lower extremities, the legs and the arms, the upper extremities. That's 78% and 55% of injured power two-wheeler riders will have that body region involved. But again, if you flip it over to the right-hand side in the fatal image, we see equal injuries, lower extremity, 47%, and the same to the chest and the head. Now here, this is a German sample, so we have high helmet wearing rates, but 58% of those killed will have a head injury. So what can we do about that? How do we protect these people? And if we go back to start again with pedestrians, then pedestrian research has been going on for a long time, and we know quite a lot about what happens in those events. Ricard will talk next, and he's done a lot of groundbreaking research in this area, of course, looking at how a car interacts with a pedestrian. We have legislation in Europe trying to make the fronts of vehicles softer and more pedestrian friendly. And an extension to that is that you would have deployable systems pop up on its an external airbag to protect the head, perhaps, in those contacts with hard regions of the car, the base of the windscreen and the A-pillars. And we know that that countermeasure is very, very effective if the head is likely to hit that part of the vehicle. But that's mounting the technology on the car, the striking vehicle. We also know that people fall over. And that's not just true of pedestrians, of course, it's true of pedal cyclists. So we've started work exploring what a deployable solution might look like for a pedal cyclist in a single vehicle form. So here we're mounting the safety countermeasure on the rider rather than on any structure that they might hit. And there's an immediate and very clear benefit to having that much more padding over conventional passive protective systems or your normal clothing. I mean, there are still complications to trigger it and deploy it appropriately, but if it can be done, then it will have a definite benefit to that crash mode. And the last one to really think about then would be, if I go back, having the countermeasure mounted in the vehicle. So in the power two-wheeler in this case, and we've begun looking into the implications of that and how it can reduce injury risk for the power two-wheeler rider. So there we've got 3 examples of putting the countermeasure in the structure that you're hitting, the car, if it's a car, your own vehicle, and also on the person. And of course, a talk like this wouldn't be complete if I didn't mention also trying to prevent the crash in the first place. So the ultimate kind of preventative measure here would be to return people to safe driving, safe riding, safe walking. So when we notice there's a deviation from that safe behavior, bringing them back before it emerges into something critical or where the crash has to be mitigated in its severity. Then looking to the future, what comes next? And I think that when we talk about the future transport system, it's a sustainable transport system. And we need to adapt to any transitions to a more active mode or to a more sustainable mode. So it might be, as in the anecdote, people getting out of their cars and commuting by bicycle. But it could be these days that you take your trip and you make use of an e-scooter as part of that travel. And so the first thing would be to say, well, don't some of these existing countermeasures work? And of course, the answer is yes, they do. So if you happen to ride your e-scooter into the side of a car, then actually there would be a very high and substantial benefit from interacting with a deployable external airbag like this. There are complications in how that would be triggered, but if you can get it into place, then the benefit for the head of the rider is going to be substantial. The alternative that you might have seen is this example, where that solution again is based in your rider's vehicle, in the e-scooter itself. Now, this gives us a bit more confidence that we can put something in front of the rider, because that's where it starts from. Again, we are left maybe imagining, well, what if that isn't true? And of course, a wearable protective system could also benefit an e-scooter rider. So I think there's hope there that something can be done for these emerging modes. So it really just brings me back to the conclusion and to loop round to where we started from here. I've concentrated with vehicle-based countermeasures, something about maybe what we can do with the road user. But that has already fallen into the trap of neglecting the interactions with the road infrastructure. I think that's fair. I'm speaking from Autoliv, so I think it's kind of natural that we're trying to do what we can. But it's important that those interactions with infrastructure, with safe speeds and with the whole safe system are kept in mind. And I'm very mindful of that as I talk to you today. So really my plea then is come and help us to fill in the gaps. I think when a mode emerges, then it's important that we don't wait for 50 years of historical data to figure out what can be done, that we react, and we react quite quickly. And that really is where my kind of plea is. I think together we can research into what needs to be done and come up with something that's powerful and effective. And the usual way of finishing these presentations is to conclude with the slide that each year Autoliv's products save over 30,000 lives. And of course, that's something that can be extremely proud of. When we roll out protection to vulnerable road users, I think that number is going to go up. And really the best and most important way of doing that depends on the interactions that we've talked about. And I think together we can work on how best to deploy the safety solutions. So thank you very much for your time. I appreciate it.
Thank you very much, Jolyon. And we do have a question now from the audience. I think you kind of answered it already in a sense, but the question is really how much you are looking into the e-scooters. So if you want to elaborate on that, please do. Or if you want to say that it's a company secret, that's fine as well.
No, I think that that's becoming a research topic, and we hope to look into that more in the future. Of course, there are already quite a few publications, and most of those publications in the research community focus on injuries that we see presenting to emergency services. So we know something about the injuries, and we know something about how these e-scooters are used, how they're hired, how they're ridden in urban centres. So there's a bit of information to work with. Actually, for me, the interest comes from the research as to how people fall off and how they get those injuries. So there's still a connection to be made between kind of where these vehicles are ridden, how they're used by people, and how they end up with these upper extremity injuries and facial injuries that we see kind of presenting to the hospitals. So it's definitely an area that I'd like to look into more, but I think it's, clearly a hot topic in the community.
It is indeed, and I can just take the opportunity also to mention that in the Research Center SAFER, we now just recently both TIR and VOI have joined as partners. So it will be very interesting to have this kind of discussion with them jointly, then together with for instance, the cities and so on, to see how this should be done in a good way. I have another question for you, Jolyon. Because of course, people are also in different shapes and sizes. When the different tests that you've done and all the evaluations and so on, how scalable do you think? Or let me rephrase it: how scalable do the protection systems need to be, or how general can they be?
Yeah, that's a very good question, and I think it's important that we don't kind of choose solutions that only work for one size of person. I think, you know, there would be that risk if we were choosing a particular size of dummy to use in all of our crash tests, developing kind of pedestrian safety or pedal cycle safety. Actually, the way that that's adopted with component level testing is that you can accommodate a wide range of kind of statures or collision speeds. And so there's some hope that there's a breadth of protection there. Of course, with a wearable system that the road user wears, then we hope that it fits well. And if it fits well, it works well. I guess the gap is a deployable system from the rider's own vehicle, where actually there's a lot of complication and is fairly involved to make sure that it works for a range of statures so that you know exactly where the head of a person is going to be if you're looking to protect the head. So it's not a forgotten art actually to do that, but it's yeah, it is important. I acknowledge that question. It's a good one.
Good, thank you very much. I have a couple of other questions, but we'll take them towards the end here when we have all three of you jointly. So I will hand over to Rickard Fredriksson, who's a senior scientist at Trafikverket, the Swedish Transport Administration. Please, Rickard, let us hear what you have to say from your perspective.
Okay, thank you very much, Magnus. Do you see my screen now?
We do, but at least on the screen that I have here on the stage, I don't see the full screen. Some part of your presentation is outside to the left. I'm not sure if it's just here or if it's a general issue. I'm looking at our technical people sitting a bit further up in the room here.
Okay, let me see
now,
what I can do.
Well, for a short while it was fine.
But then it goes back if I do this. Or...
No, it's fine. Just stay there.
Okay. Thanks. Thanks, Magnus. It was good to see my old airbag tests from the Autoliv time is still being used. It's almost 10 years ago. And it's also good to see that you're still working in this very important area at Autoliv to protect vulnerable road users. It's a lot of challenges there for sure. But I'm now working for Trafikverket, the Swedish Transport Administration. So I will have just a few slides to discuss how we see active mobility or modal shift from a government side. There we go. This is the recommendation, one of the recommendations from the Stockholm conference, and the one on modal shift. I believe it's number 3, where they stress that we have to shift travel toward cleaner, safer, and affordable modes, incorporating higher levels of physical activity. So this is really moving towards active mobility and walking, bicycling, and so on. So traditionally, the focus has been on vehicle mobility. We have built the roads, and we definitely have a fault there from our side in Trafikverket. We have built our roads and infrastructure based on the vehicles, and really then try to squeeze in the pedestrians and cyclists with not a very good result, I would say. Back in the 80s, almost 100%, almost all children walked to school, to their sports activities, and everywhere they needed to go, they walked or biked. Now, 30 years later or 40 years later, it's only 50% who do this. So that has really been reduced. Another reason for active mobility is diseases. I'm sorry, this slide is in Swedish, but what it shows is that the reduced risk of just increasing your physical activity a little bit, moving 30 minutes per day, 5 days a week, just slight increase, you reduce all kinds of diseases and the risk of those a lot. So there is really see a benefit there. And the biggest benefit if you start from no activation at all to just a small level of activity, you really see the biggest benefit. E-scooter was mentioned, and it's been a big hot topic in Sweden, and a lot. It has really been questioned. We, from the government side of Trafikverket, we really see the benefits of it. We can reduce vehicles in cities and reduce congestion, and also get people out of in a way more active mode. But of course, we also see the difficulties, the challenges with the increased injuries and so on.
So we really have to look at maybe redesigning this e-scooter, setting rules, and design the infrastructure for it. So we need to work there as well. But we really think we need them, especially for the last mile problem where you want to take the bus or public transport somewhere. The e-scooter is a perfect complement to get to the end of your journey. We really, since last year or last couple of years, we from Trafikverket has really seen this safety now has to be part of the sustainability as a whole, and that was really a big conclusion from the Stockholm conference as well. So I'm a safety person, but we see now that we cannot work with the safety alone in a separate pipe. We really have to work together with other sustainability goals and make it work together as a system. So that's really the way forward as we see it now. And there are different areas then that really need to work together. Not only safety, as I said, we have to have the environmental properties like healthy, clean air, fossil-free vehicles, but also surface and cost-effective solutions for this to get this model shift working in all aspects of the sustainability. But how do we manage this? One challenge is, of course, the crash energy, because if you walk or bike, you're unprotected, and it's hard to manage the crash energy. We see several aspects of doing this. We need to reduce the speed in cities to maybe 30 or 40 kilometers per hour. We believe vehicle systems can be really effective part of this. Auto brake systems for vulnerable road users we already see are very effective, and that's the area where I come from. I work with vehicle safety, but that is not enough. We also have to do more with the infrastructure. We can speed-proof zones and crossings to make sure that there's a safe crossing for a pedestrian or a bicyclist. Not only set the speed limit, but actually design the road and the crossing so that vehicles need to reduce the speed. That could be speed bumps or narrowing the road or other solutions. And in some streets, we think we need to have a collective speed, that you have the same speed limit for all road users. So that would be set by the most vulnerable road user. We can redistribute the surface, give more surface to vulnerable road users and less to cars. And finally, friction surface is also important. We see a lot of injuries of pedestrian single accidents, pedestrians falling because it's slippery. So that's also a really big problem that we need to solve, especially for older people that are more fragile. So to conclude this short presentation, we have to start from the sustainability goals and create mobility for these conditions. Okay.
Very good. Thank you very much. Thank you very much, Rickard. We have a couple of questions that have come in. I think they are kind of general, so we will take them to all three of you. I just wanted to dig into one thing that you said, Rickard, regarding the sort of the speed control and so on. And of course, the narrowing and speed bumps and so on are ways to do this. But at the same time, that will also limit sort of the efficiency and the flow. Because it's one of those multivariable optimization problems with a lot of different aspects. Anything you would like to comment on? I think we will come back to that kind of question later, also in the afternoon, when we look at sort of the city planning perspective and so on. But if you want to say something.
Yeah, I believe vehicle technology has a role to play there. For example, geofencing or communication, vehicle-to-vehicle communication can reduce the set speed limit on the car, for example, in a certain area. So I believe that is one important way forward there, for sure.
Good, thank you. Then we have about 10 minutes left until lunch. So I would like to gather the three of you, if we can have all of you on the screen somehow. I hope that we can all hear each other. As I said, I have a couple of questions, and I'm also curious to see if you have questions to each other, because we've covered sort of quite different types of issues related to active mobility. But I think we should start with one of the ones that we've got from the audience, and one that I had on my list as well. Just as recently as last week, I was in a rather heated discussion regarding, do we count the e-scooters as active mobility? Anyone who wants to start on that one?
Maybe I can start. I'm not sure about active mobility, but it's definitely part of a model shift that we need to do to reduce congestion. And then you can discuss if it's active or not, because you don't get the exercise maybe. But it's definitely an important part of the model shift, I would say.
I would agree so too. I think that they are there. People are certainly using them, and we need to find ways by which they can be introduced in an efficient and safe way, evidently. And I think it shows also that changes in travel behavior is possible, given these type of changes as well, not only attitudinal but actually offering new solutions.
Julian, anything you would like to add?
No, I totally support those comments. I think, and particularly if the modal shift is from a more polluting mode to something like an e-scooter, then it's got to be kind of viewed in that way, that it's a step in the right direction from a sustainability point of view.
But what, if I may just comment,
Please.
because I think in a way, I could see that we all agree on that we need to work together in order to solve the issues, whether it's increasing active mobility or it's safety or whatever. We cannot work in sort of narrow paths. We really must look into the whole system and see how we can contribute in different ways, and also actors who are not here to see that the system sort of the system development moves forward in a positive way. It's safety systems, it's regulations, it's knowledge about people, etc., etc. So I felt that we agreed on that.
Absolutely. Another question that we got from the audience here is when you look at the different protection systems. So maybe this is mainly to you, Julian. How about the back protection that people use when they are skiing and so on? How much of the injuries do we actually have in that part of the body? And would we need to have those kinds of protections also when we go by bike or scooter or run or whatever we do?
Yeah, it's a very good question. And I think it's slightly difficult to answer. I think what we see with power two-wheeler riders is that there are some spinal injuries, and certainly you can hurt your spine, your back, in severe cases, and that can be a problem. So undoubtedly there's something to protect there. But actually I think that with many of the protective systems, they cover not just your spine, but also your back. And then the question is, well, is there a benefit to covering the back of somebody? And yes, there almost certainly is. Now that's going to be more moderate severities probably that we're looking at. Relatively simple rib fractures or cuts and bruises or something of that nature, then they could be really, really effective, and we shouldn't undervalue that. So I think that there's a merit to them. Actually putting my finger on exactly what they're going to solve kind of depends on the application and exactly what they look like. Yeah, I think there's space for something to help with protecting the back of the person.
Good, thank you. And at the same time, we don't want to have to force people to wear a full suit of armor when you go out in the daily life. I mean, it should be, as you were saying, Marianne, it has to be simple, it has to be easy, it has to be really something that you want to do rather than something that you have been pushed to do.
Yeah.
So there are definitely these kinds of issues. Another question, I will combine one question from the audience with one of my own, and that is, okay, we're talking about active mobility. We use it as a fairly sort of general term. We've had some focus here and so far in the discussion on bikes and to some extent also the e-scooters. But when we look at the city planning, I'm not sure if you are really feel able to answer, but please feel free to comment. When we look at the space that we have, especially in our cities, and we want to make sure that we can actually use bikes or whatever it might be, and different types of micromobility devices and so on. There will always be this competition of space. So again, I think the answer is kind of collaboration and make sure that all stakeholders are there. But please, if anyone wants to comment on that. I'm looking at Marianne because you seem eager to.
No, I don't seem eager at all. I'm showing the wrong face there. No, but certainly I feel that whether urban or other infrastructure is important for all sorts of different reasons, and not least from a sort of traffic safety point of view, but also from a kind of usability point of view. There will be challenges, of course, to allow walking, cycling, e-scootering, and other e-cars, etc., and public transport moving in the same areas. But I also think that if we consider new types of vehicles with different types of safety system, but new types of vehicles, different types of solutions where you cannot drive as fast as you like, even if you want to. I think that there are ways by which, again, if we collaborate around these solutions, I think we could certainly have a more accessible city and a safer city. But safety is also a matter of perception, so that's also important to actually design the space so that it's perceived as safe enough to move in, but not safe enough to act in any way you like, because that could actually increase the risks. So I think urban planning is super important to consider here, for sure.
I think also, Rickard, you mentioned something on that topic about kind of providing areas with consistent speeds between the different road users. I think that's kind of a nice feature of this, is that you could have in automated vehicle terms, it's a design domain or an operational domain, whereby you kind of have a consistent speed between all road users, so you know how fast other people are going to be going, whatever they're in or on, or how they're walking, and it's at a speed that's manageable from the survivability and injury point of view.
Yes, exactly. And I think we need to redistribute the space. The cars actually have to give up some space to give a safe room for bikes and pedestrians. And also, I hope that when we go towards automation, that those vehicles will be programmed to actually be in a safe speed, not only the legal speed, but actually when they have pedestrians or bicyclists around, they actually detect those and adjust the speed to be safe, not only legal.
And interestingly enough, we kind of had a major experiment the last year and a half where this has kind of happened to a certain extent, at least, especially I would say in some European cities, where like Paris and Brussels and so on, where they really moved away the cars. And then it'll be very interesting now to follow what is happening when the pandemic is sort of slowing down and so on. And will these things remain? I think the speed limits in Paris definitely will be there onwards. And so let's follow this. And there's been a large number of different research projects, of course, following now what is happening. Good. It's now 11:59 and 30, so we should wrap up and let you have a lunch. I would like to say thank you very much to all our three speakers and to all of you who have raised the questions. We do have some additional questions that we didn't have time to talk about here and now. But by that, I would like to thank you and close the morning session, and we will be back at 1 o'clock.
Okay, so welcome back to the seminar for the afternoon session. I'm Mike Brown. I'm from the University of Gothenburg. I'm working mainly in freight transport and logistics with an urban focus. And I'm really happy to be the moderator for the session this afternoon on transport and urban development. In fact, it's very good link to the morning session because we finished with a question this morning following the active travel presentations. We finished with the question, but how are we going to have enough space in the city to manage all this active travel? So I'm hoping and looking forward to getting some answers to that from the presenters this afternoon. But I don't think it's necessarily the case that we'll answer all of these kind of questions, but I think it's important that we go deeper into some of these things. So this afternoon we've got a very interesting session, 3 different perspectives. One focused very much on logistics. This will be the first presentation in a moment from Sönke von Wieding from SSPA. The second with a broad question about mobility and how does mobility fit within the urban spatial system now and the future. And the third with a company perspective, and that will be by George Giel from Chalmers University. And the third with Stefan Christianen from Volvo Cars, who will tell us about the Green City Zones project, which is a very concrete initiative about how we fit transport and mobility into the urban centre. Then we'll have a panel discussion with the 3 speakers, and we'll be joined by Kajsa Hultén, who's the co-director of the area of advanced transport, who those of you who were dialed in this morning at 9 o'clock, you met her in the very first session. So I think that's enough from me. I'd like to hand the word to Sönke, and Sönke, I can see you on the screen in front of me, so it's very nice to see you again. And I can tell you're in Gothenburg because you have those cranes behind you in this picture I can see. So welcome to the session. And you're going to talk about this, in a sense, dilemma, perhaps, or a question, an open question. The role of the local authority, regulate, build, operate, or perhaps a little bit of everything in there, which is why it becomes a difficult challenge for them. So Sönke, I hand the word to you, and we look forward to your presentation.
Okay. Yeah, thank you, Mike. Thank you very much for the introduction. I'm actually hearing a kind of echo still. I don't know if this is for everybody or only for me.
You sound fine here.
Okay. I can still hear you talking. It's a bit irritating, but I hope it stops soon. Great. Yes, thank you for inviting me. I'm very happy to be able to present our work here at the seminar. Before starting with the actual results, I would give you a little bit of background. Okay, it's really, I don't know what is wrong. I have to check it. Yeah, but I can hear myself all the time. It's a small gap in between what I'm talking. Let's see. Yeah, that was, sorry. I was still online and looking at the seminar as well. So that was the reason. Good. I'm sorry for this. Yes, background to this project. It was a small project called Framtidens varulogistik i städer, which is Swedish for the future of urban logistics. It was at the time when I still was at IVL in 2019, just before the pandemic started, and it was financed by the government offices of Sweden. So what we were asking to do there actually to challenge the traditional urban logistics methods, so go beyond what we used to do, the actual tools which we currently apply in order to somehow regulate or steer logistic operations in cities. So we want to go beyond that and try to, what can we find more in order to do it in a different way? And this is what we did in a case study in Uppsala in Sweden, the city of Uppsala, where the city currently plans new development areas like high density housing and city areas. So that was the city district where we looked at, and we wanted to do it in an interdisciplinary and holistic way. So what does it mean? Usually coming from as an urban logistics expert, we used to say that city planners, they don't know anything or very little about logistics, and this is a problem when they build the cities. But to be honest, on the other hand, it's also the other way around. So we logistics experts know very little about city planning. And I think that was the interesting part of this project, that really tried to look at it from a holistic perspective, and including both logistics, city planners, and also looking into passenger transport. So we want to have a holistic city perspective in this project. A little bit of background when it comes to current trends. Everybody knows that we have urbanization as a strong trend, but also densification. I like this with the visualization from the city of Gothenburg on the left-hand side. You see everything which is going to be built or already under construction in the city. So it's a lot of construction going on and the city is densifying. At the same time, we want to use the urban space in a different way. This is shown on the right-hand side here. So every little box here shows a type of urban activity, and this is going to take place in the road environment, in the road space, which maybe in the past was predominantly used by car traffic or road traffic. But in the future, we want to use it differently, and we actually increasing the competition for space. So we want to use the road space more like an extension of the living room in the future in these urban areas, and not only as a traffic area. And this, of course, creates a lot of conflicts because we need to be very smart in how we divide the space and how we use it in order to share it more efficiently. A second trend, of course, is linked to e-commerce and digitalization, and also COVID-19, I think we have to mention here. So everybody knows we have increasing e-commerce activities and e-commerce sales, and this was extraordinarily big growth of e-commerce in the last year due to the pandemic. You see on the left-hand side here, 40% increase in Sweden compared to 2019 was 2020. And it's expected to continue even after the pandemic, which is hopefully soon come to an end. And the right side, you see that actually we saw the trend that, of course, e-commerce increased, but also at the same time, physical stores, their sales volume decreased by quite a margin as well. So we see a shift towards e-commerce. Linked to this as well is also very important in this context is the question how things get delivered, which we order online. And we see here an increasing demand for home deliveries, which is maybe triggered by new actors which came to the market, like you see on the right-hand side, Best, Budbee, and Airme, just to mention a few. On the left-hand side, you see how actually it was a survey among e-commerce customers, and they were asked how they got their last internet purchase delivered. It's the blue bars, and you see that still 53% were delivered to pickup points, and parcel lockers click and collect, so where you're actually going as a customer to a point and picking up your order. While home deliveries were 35%, but the desired delivery alternatives, what people like to use most, is actually the other way around. So home deliveries are very popular and will probably grow due to that in the future. Why is this important? If you look how these, from a logistics perspective, is organized, we see actually that these deliveries with a pickup point system, which the big logistics companies like PostNord, DHL, Schenker, and so on have built up in the past. It was built up in order because they are very efficient from a logistics perspective. And that is because we actually outsource this last mile or last meter delivery to the final customer. So they have come to the pickup point and pick up their orders, which makes it easier for the transport companies to have larger volumes and use larger vehicles to transport to these pickup points. So focus transport efficiency in that way of delivering. As I said earlier, home deliveries are the new actors which come to the market, and they compete with the big other companies on terms of delivery service. So they offer quick deliveries and home deliveries to your door. And that, of course, has consequences to the way how it can be executed, because we obviously need more time in these districts to deliver to the different doors. And that time, of course, we can not have the same amount of parcels in these vehicles. That's why we need more vehicles in order to do the same amount of deliveries. So there's obviously a trade-off between transport efficiency and delivery service in this respect. And that is problematic because as I said, we add more traffic, and this contributes to congestion of the access roads. But even more important, I think, is that we get this conflict in these high density areas where we suddenly have logistics traffic because we have vans going from door to door and deliver the parcels. And these areas are usually not designed to handle logistics traffic. So this is a conflict and has consequences in terms of safety issues, emissions, and also competition for space. So before we started looking into how sustainable urban logistics solutions can look like, we try to define criteria how actually we can measure if a solution is sustainable or not. So we came up with 5 different criteria, and the first 2 I already mentioned: transport efficiency versus delivery service, even conflict level I also mentioned. So what is the issue with competition of space, safety issues in these high density areas? And then of course we also have to look into the environmental impact, so carbon emissions, air pollution emissions, and so on. And at the end also it needs to be cost efficient, and the cost also need to be divided in a fair way between the different actors in the transport chain. And it's important to remember that these are not independent criteria. I already mentioned that transport efficiency and delivery service, there's a trade-off. And this is also true for the other criteria. So I would like to highlight that it's very difficult to achieve like a maximum goal fulfillment in all these criteria. So sustainable solutions need to handle this trade-offs and achieve a sufficient amount of goal fulfillment for each of these criteria. It's difficult to achieve maximum goal fulfillment in all criteria, or maybe even impossible. So having these criteria in mind, we looked into the current way home deliveries are executed. So the conventional home deliveries, and if you look at that, they're usually performed by vans. And vans, we call it like it's a bad compromise, because they are neither optimized for inbound transport on access roads, nor are they optimized for distribution in dense city districts. So a medium-sized vehicle, we have issues which limited efficiency on access roads, where we only have to drive a certain amount of kilometers from the suburbs to the city districts. So there would be much smarter to use large vehicles, trucks, because we have a dedicated infrastructure for road traffic and do not have to have these issues with emissions or noise and so on. While in the high density districts, the van is too big to be on a human scale. So we want to use the space differently. We want to use it more like a living area, social area. We want to use it for active transport modes. So there, the van is actually a disturbing factor. So we have high conflict here. So neither of these cases, access roads, transport efficiency, or low conflict level in the high density districts, the van is in this way a bad compromise. And of course, due to the amount of resources we need, it's also high impact and high cost level. So what we then came up with in order to define how sustainable urban logistics services can look like, we studied a lot of solutions which are out there in the market and tried to use the experiences to come up with a system which fulfills all the criteria. And we found out that we need to have, in this case, have intermodal logistics services. That means we want to use different vehicles which have strengths in certain parts of the transport chain and use them in combination. That means having trucks on the access roads, where we have a high transport efficiency, and then going to this cargo bikes or other micro vehicles in the high density districts, because we know that there are cargo bike deliveries out there, but they are of course limited in capacity and limited in range. We cannot use them for the whole transport chain. So we need to combine them with larger vehicles. We also need to consolidate, most probably. That means transporting the volumes of a certain amount of carriers so that we achieve the volumes large enough to have efficient operations on the inbound access roads. And finally, we also think that this idea with pickup points and parcel boxes, though they're not very popular actually, that they still have a point to fulfill, because it's very good that if we can outsource still the last meter of the transport chain to the receiver. And that way, as I told you earlier, we can be more efficient in the way we transport the parcels into the area. So having higher resource efficiency requires that maybe the receiver still takes part of the work. And of course, we need to discuss how far away this reception facility has to be from the actual apartment, so that the receivers can use active transport modes and not take their car to pick up the parcels, because that will destroy the whole point of using sustainable urban logistics services. So this is how sustainable urban logistics services can look like. But what we also found when we studied the consolidation projects, that they actually not continued after the project has terminated. So very often these projects are not continued, and this is because they are too costly. And the reason for that is, it's obvious, we need transshipment points here in order to use intermodal operations. In order to consolidate, that always involves additional handling, and that is too costly. So the key here, when we looked into what authorities can do in order to support these solutions, is about how they can have a larger or more important role in the provision of infrastructure. And for that, we defined 3 scenarios. So as I told you before, we wanted to go beyond the conventional way of how local authorities work with logistics and challenge a little bit the common way. And there we looked into how the authorities work in other areas where they have a more active role. And the first scenario, which we call here plan and regulate, so there we actually look into the conventional ways, so using planning and regulation procedures, but using them really to the maximum, I would say. While the second scenario we call infrastructure, there we assume that they do the same as in the first scenario, but in addition, they also provide the logistics infrastructure, for example, a microterminal or areas for parcel boxes. And that we copy a little bit in the way authorities work, for example, when it comes to maritime transport, where they often provide the port infrastructure. They're not provided by the shipping companies, but they use the public infrastructure in that way. And finally, the third scenario, we imagined what would happen if municipalities would take a similar role as in public transportation, where they provide actually the transport services as well. Just to go through the 3 scenarios very quickly. So here you can see what would happen if the municipality would take like very radical planning and regulation methods into account. And what we think would be necessary to achieve this kind of system is that first we use very strict traffic regulations in the local roads, where we forbid actually the operations of van. At the same time, we know that we need to provide this infrastructure, so we need to reserve area for this infrastructure in the detailed plan. And the third very important issue, which we think would be very interesting to study further, is that what would happen if we copy the same approach that authorities have when it comes to parking for passenger cars, when we apply this for logistics infrastructure as well. So we know if you want to build some apartments somewhere, you are required to provide off-street parking places, like, for example, 0.3 or 0.1 parking places per apartment. And we also know that it can be outsourced, that the real estate companies can pay a fee, and then this is built for by the municipality as a whole for the city area. We would like to introduce requirements for off-street loading zones or for reception facilities for parcel boxes, so that the real estate companies are actually paying a little bit for providing the infrastructure. And a third issue here is very important. If we apply this kind of system, it's very difficult for smaller companies, for example, a retailer with own vehicles, to have these possibilities with trucks and cargo bikes in combination. So what we need to do is to somehow provide a system that this retailer, which cannot afford cargo bikes, can hand over their goods to be delivered to these bigger companies which can have the resources. Building infrastructure is somehow very, very similar, but in this way we want to actually provide the logistic infrastructure, and that is a microterminal, but also having these reception facilities. So maybe you can call them operator neutral parcel boxes. So the picture before, you saw that each operator, 3PL company, has its own parcel boxes, which as a receiver can be a bit complicated, that you have to go to several places to get your deliveries. One step further, thinking would imply that, we see it as a public infrastructure, like a bus stop, for example. We have parcel boxes which can be used by all the transport companies, which has the advantage that as a receiver, you always know where your deliveries come to, and you do not need to consider having the different operators' parcel boxes.
Sunke, could you just perhaps speed up a little bit, because we should have time for a couple of questions at the end?
Yes, I'm almost done. Thank you. Good. The final option here would be to operate transport services like in public transport way, and that would, of course, does not imply that the other companies are not allowed to operate their own system, but we want to have it as additional system. And in that way, if we provide this system as from a public authority perspective, we can put even higher requirements on, for example, low emission zones or zero emission operation, and that would provide you an option to have even more sustainable logistics services. To conclude, the question was regulation, building, operation, and which system you should employ, I think is very much linked to density, because the denser we build, the higher land use conflicts we have and the higher requirements we have to reduce the amount of traffic in these areas. So I think actually, as I try to visualize here, that this operation scenario, which I presented last, is of course maybe only relevant in the very, very high density areas, while and building and regulation maybe already in medium density areas. But the big question actually, and this is something what we would like to study further actually, what is actually the density threshold? I showed you the picture for the density, but we don't actually know what areas require this kind of intervention. Is it a city like Gothenburg or Stockholm, or even higher densities which we require for that type of pollution? Then of course also we need to find out more how to design the infrastructure. We have to look into, is there a need for adapted legislation, for example, when it comes to this logistic requirements for buildings and so on. And also, of course, very important, there are actors which are specialized on providing deliveries to own parcel boxes or very fast deliveries to the doors. How are these stakeholders affected with their business models? Yes, I think I will stop here then.
Okay. Thank you, Sönke. It's great, and I really like the way that you've categorized the three different ways of thinking about it. And I know that you know a lot from practical experience. You know that it's a big challenge to actually do that. I have just one question because we have some time at the end, I hope, for questions in the panel discussion. So my question is, when you were looking into this, did you find some examples that were good examples of the build and operate side of things? Because I suppose regulation is pretty much ubiquitous, but build and operate are less common. So did you find examples that you feel we could learn something from in those two areas?
No, we didn't find any real examples for this, for the whole city areas, I think. But I think we can look into Chalmers campus, for example. There we have an internal transportation system, and we see it also in other areas. So where actually, the real estate company or operating an own internal transport service, and this works in a similar way, I would say. But of course, it's very difficult to implement it for a whole city area in that way.
But then I think your study gives us a good framework to study those things and put them in place, and then to see how they relate to each other. So I think it's really valuable that you break it down into those different topics, even though it can be hard to populate the first two of them. But I think for sure we're going to see a lot of developments there.
Yeah.
Okay.
If I just may say 1.5 sentences. It was a limited project, and we discovered a lot of more questions actually how this could work in practice. But it was very interesting to look in this more unusual terms how logistics can be planned from a city's perspective.
Yeah.
A lot of more things to do, definitely.
That's great. Well, Sönke, thank you very much. And I think you will stay now until the end, and then we will come back and see how the time is going. So Sönke, great presentation. Thanks a lot.
Thank you.
Okay. So a very good start to the afternoon. I'm now going to move to the second presentation, and I invite George Giel to come on the stage. Please, George, come up here. And you have your water, I have my water. We're being very correct in all this. And George, I'm delighted to welcome you, and you're going to tell us a perspective from urban design, essentially. And we've talked about this quite a lot, so I'm looking forward very much to hearing what you've got to say. George.
Thank you. Thank you very much for inviting me. Really great to be here and in this session. So I'm going to give a more high-level story of our perspective from urban design, how this fits, having a lot more questions than solutions and answers. So when we see the topics being discussed in the transport domain, we see a lot of great solutions of technologies, future technologies of future transport. We see autonomous vehicles, connected vehicles, both for freight, for private individuals. We see electrification, both of the vehicles, but even the roads. We see new modes, shared modes of using, we see micro modes of mobility, electrified micromobility, such as scooters, e-bikes, used both for private purposes, but also for delivery. So these are all great solutions, but how do they fit together? So in our perspective, or rather from an urban design perspective, we see these great new developments. How can we imagine the future? The truth is, with technology moving so fast and new things happening all the time, for example, we had this session this morning on hydrogen fuels. How can we predict what's going to happen in, say, 100 years? What's the city going to be like? How is transport going to be like in 100 years? We can't really predict it. But what we can do, and what we usually do, is plan and design for an urban future that we want. So we imagine what future do we want to have. And as we all know, I mean, we want a sustainable transport and mobility future. What is sustainable transport and mobility is a bit broader than when we just think of, for example, reducing emissions or reducing pollution. That's certainly top on the agenda. So, for example, in this table, I list several of these objectives. It's top on the agenda, but there are other things. We want to reduce land consumption and avoid sprawl. We want to reduce accidents and have traffic safety. We also want to even reduce travel, because if we travel more, we spend more energy, and it's not sustainable in the long run. So there are many aspects to sustainable transport to go beyond this reduction of improvement of technology and reduction of emissions and energy, especially for urban design and planning. Aspects of modal shift within the urban environment and accessibility are critical. What are the solutions? Certainly efficient vehicles and infrastructures and alternate fuels, as we've discussed already, but also regulations, new regulations, as we've just heard, suggested for the case of freight deliveries, but even information and education of the users, and also land use changes, where we locate things, the density question that was just also discussed. So how do we design an urban environment that delivers and supports this sustainable future? So a question for urban design is this of who owns the street, because all these actors, be it the freight, the transport, or the spatial planning actors, are actually competing. As Sanka shown in this section, there's a lot of competition for space on the streets. So from the urban design perspective, of course, we have a very specific view. We want walkable neighborhoods. The 15-minute city is a new paradigm, like they're proposing it for Paris, this idea of the 15-minute city. You want to have everything within a 15-minute walk, for example. Or multifunctional smart streets, where everything they can accommodate everything, and they're not just for travel, they are for other social uses. But certainly priorities for people, including aspects of diversity, equity, are critical for spatial planning. So spatial planning and design guidelines are very clear in setting restrictions. One might say regulations, but if you read the regulations, when it comes to the cars and to the freight, they're really restrictions of curbing volumes, speed, access, etc. So that's our perspective. We want to stop all of that. The reason being the dominance that vehicles have had and transport has had over the street over the years. So this is a very classic image of walkable neighborhoods activism that shows what space cars take. So if you want to move 60 people, what space the cars would take in a city as compared to a bus that takes the same 60 people, or bicycles. Another view is also this. What space would be required for 60 electric cars, 60 Ubers, or 60 autonomous cars? Actually, is the same. So for us, when it comes to technology solutions, those certainly address parts of the problem, but they do not address all aspects of the problem. So what kind of visions do we have? So priorities for us is people and active modes of transport first, public transport and bicycles second, even eventually shared modes, the cargo bikes, etc. are great ways of having a second level of access to the street and use of the street, but really reduce the space that other modes such as deliveries and the private vehicle take on the streets. So this is again the section, the competition for space. How do we fit all this? Because we want green, we want social aspects as well, people to sit on the pavements and socialize. We want space for public transport, space for parking, space for bikes. How do we fit all that? And this is a vision, let's call it, of a street in the 15-minute city. So in this small circular inset, you see the current street where multiple lanes are dedicated to multiple types of vehicles and to parking, but the future street is actually more green, more sociable, and multi-use and multi-mode. But is this viable? So essentially, regulations, this is what they offer. They recognize that actually we have different types of streets. Also, Sunke touched on that. We have city centers. So in this diagram, we have two scales. One is the place value, so places that are central at the local level, for example, or even at the national level, a central plaza of a main city, and places are strategic for movement. Some places are both, but some places are really central and they should be prioritizing pedestrians above everything else. Other places are less have less value in terms of place, but have more value in terms of strategic movement. Therefore, they should prioritize transport, public transport, or deliveries and freight, and the private vehicle. So we have to understand the different flavors of place and really regulate and set priorities. But these are the regulations and priorities already in place. They really restrict, when it comes to the city, access to cars and to deliveries. So apart from regulation and following on from the different options we heard before, designing utopia or dystopia, what visions can we create? And what role and space do different modes and technologies occupy? So we really need coordinated transport and spatial planning and shared visions. So we need to develop these shared visions. The urban design visions that I will show, they just come from this restriction and containment of the access by car, while if we take a vision from transport, it is going to be rather different. So this is a vision, as I've shown, this is kind of a mock-up, that we do a lot in urban design, a mock-up of what a city street could look like according to this multimodal shared streets vision. So really no space for cars, hardly. You can't imagine how you could fit a truck in here or make deliveries. Another of these visions, so visions of the future. What would this future city look like in one of these micro-mobility neighborhoods, as this one is called? So it's a vision of a micro-mobility neighborhood where only bicycles and maybe scooters would have access. But you still want cafes, you want public services, you want everything in that neighborhood. How would they be provided with goods, and how would people access these places? So there's in these urban design visions, there is also a lack of a vision for freight. Freight is not really present. How does that work? Or a lack of vision for what about flow of higher intensity flow of traffic? How do we move between these or through these neighborhoods? If we take another type of vision from Ford, for example, so it's not an urban design vision, we have a very different picture. So they say it's improved walkability, but really is shifting and pushing the pedestrians to these walkways right away from the streets. What we have is a very regulated and technologically driven street full of automated vehicles and technologies for really making a very optimal and efficient flow of traffic, possibly safe as well by separation, but an urban designer would always look at this and say, sorry, we reject this vision. This is not the city that we're going to create. Or if you look at the vision of a future rail, again, focusing a lot on the different solutions, different technologies, but really how does this fit together in a city and with people? So that's why I'm saying we get visions from the two sides of this story, but we really need shared visions that make these solutions viable. There are some attempts where we do see, for example, here, some maintenance robots in this crazy vision of a green city of the future. A lot of people, but definitely a lot of mix of modes, mix of use of space by different modes and different vehicles and different people. Or in this one, another futuristic vision where we do see the autonomous vehicles, but we see also a much freer and sort of chaotic, green and natural and social environment where these vehicles move. And we probably might see some delivery vehicles, but I don't think freight, for example, is addressed in these sort of visions. So essentially, to answer who owns the street and how we create the future streets and future cities for new transport modes, we need to start having visions that are shared, not just the urban design vision, which is very clear, and is the one that drives these visions, but we need to bring the other perspectives also on board. Finally, when we talk about the future of transport, is it about optimization? There is a clash here between improvisation and optimization, really, because reality is messy. So we have these visions that I've just shown. They are like these glossy, futuristic pictures, but reality is messy. And if we think of the freight delivery aspect and the last mile aspect, it is complicated to park, it is complicated to negotiate obstacles, it is complicated to negotiate people and other modes that share the street. Some of them can be autonomous, as the image on the bottom right, there's an autonomous car driving around, but still, how do we create a system that accommodates this diversity and is flexible to improvise and operate in this complex reality? So rather than finishing with solutions, I finish with a lot of questions. So the question about the future transport, how to address future transport sustainably. So how to address it sustainably means addressing it from all its dimensions, and how to balance the competition for urban space, because we need to find solutions to share space between all the different modes, and how to create a transport system that works for all in a wide range of urban and rural contexts. So this is answering these questions, is answering the question of how to address transport, the future transport sustainably. Then we have great technology solutions, and human invention will always be sure to find a solution for our problems that is technology-based, but how to make it work as a system, how to make these technologies integrate with each other and with the human system and the urban system in all its complexity. So what is the right role for each of these technologies in each place and for each purpose? There will be competition between them, so we need to find a balance, and we need to find a role for these in the system. And how can they address the need for creativity and improvisation? A lot of these technologies are optimal, and they require a lot of infrastructure in place to function. They don't just work if we throw them out on the street. So do we need to accommodate for them, or how can we make them be more adaptable to this creativity and improvisation demand? Thank you.
Great. Thank you very much, George. Thanks. We've got time for a couple of questions and observations, so I'd like to just ask you that. I think, do I need to stand closer, or is it okay here? It's okay. A bit closer. Okay, we could be a little bit closer.
Okay.
So, George, you ended with the sort of question of flexibility, but before you got to that, you talked about the 15-minute city. I think I was in a meeting the other day where one city told me that it was going to be a 10-minute city.
Yes,
so
it depends.
I fear this terminology, like the smart city one, and you can't find anyone that isn't. But okay, but with this flexibility question, which you ended with, some of the visions you show are way away from that. I mean, they're less flexible because, you know, we have streets that were designed, or they weren't even designed, they just evolved for horse-drawn transport, yet we've managed to fit things into those streets. So this flexibility and improvisation, how does that sit with a designer? Because don't you want to put your stamp on the thing in some ways?
I think the message is also for designers.
Yeah.
For sure. If we look at the first vision of this micro-mobility neighborhood with all these ramps and circular ramps, I mean, it might be a great design, look really good on paper, and maybe in some cases it could be interesting experiment, but definitely it does not accommodate and is not flexible enough to accommodate every user, every activity in the city.
Yeah.
So I think it's a message for all sides.
Yeah.
The reality, the demands, the needs are many and complex. So it is by sharing visions and opening up. So we also do have designers that just follow the mantra, okay, walkable only. And they don't even think about freight. They don't even think about, actually, people don't just walk in their neighborhood. They have to go to work. They have to travel for holidays. They do other activities that go beyond the 15 minutes. So how do we accommodate for that? How do we integrate that?
And I think you raised a really interesting point about who, in a sense, owns this space, and you can have ownership in many. And I think by that you meant many different things, not literally.
Literal ownership. No.
For instance, in London, I was reading that 80% of public space is indeed roads. But in that sense, of course, it's not much. So a lot of it is not much use as public space in the sense that they were thinking about livability and so on. But I think this ownership question is something that we should come back to. And I suppose it's interesting to me to think how you, as an urban designer, see those sort of things. You know, the ownership of the space, and how again how we could be flexible with that, because at certain times of the day, perhaps it could be for other uses.
Indeed. So there are solutions needed for that, because the example you just gave is sort of what the urban designers are reacting against. The realization that public space that is apparently for everyone actually is owned by the vehicles and is highly regulated and for those specific users. And so we saw that during the pandemic, all these movements about creating improvised cycle lanes, public space, widening pavements. It was a sort of there was freedom to do that, and because there's no one on the streets, and there was a big goal, the pandemic, but indeed it was a reclaiming the streets, and there was a huge excitement within the urban design community about these initiatives, and thinking, can we actually make them stay? Can we actually reclaim space now? So there is this fight for space and this notion that, public space is largely owned by the roads, and we need to. There's a sort of a fight going on.
Good. Okay, so George, thanks very much for that. I think you're going to stay, and we can come back at the end if we have a little bit of time. So thanks again.
Thank you.
Okay, I'm going to move to the third presentation now, and I'm delighted to welcome Stefan Christianen. Stefan, this is the first time I've met you and shared the stage with you, or platform, whatever this is. And so that's great, and I know that you're very active in this area. You're leading the Green City Zones project within Volvo, and also you are putting a lot of effort into the sort of knowledge sharing and knowledge building, so capacity questions. So we're really happy to have your presentation this afternoon, and I hand over to you.
Thank you so much. And there's going to be quite a few slides, so I'm going to rush through them a bit. So thank you, Mike. So first of all, I just wanted to put this in context, or we want to put it in context. This is a communication of the European Commission, because this is a truly global, or at least pan-European issue. Mobility is at the very heart of Europe. It's a necessity, and it's a fundamental freedom, and it's also a very, very big part of our economy. So let's remember that just going forward. At Volvo Cars, we focus Gothenburg for natural reasons. even if this is truly a global issue, just as I said, there are more than 750 different cities around the globe who've signed up for different forms of carbon zero and green and dense city design frameworks, as we heard about. Within the Gothenburg mobilization, we have the Green City Zone and the Gothenburg Green City Zone initiative. So I'm going to go through context, vision, and the strategy challenge perspective, and a couple of ideas about what we're going to look into. The mobilization agenda is rather broad. It's about our company in the city. It's about the city of green innovation and also our new effort close by here, World of Volvo. But here, Gothenburg Green City Zone is very much about the joint challenges we face as a company, as citizens, as car drivers, as bikers, walkers, pedestrians, as city designers. We have the European Union framework. You have Gothenburg or any other cities, different perspectives and policies and urban development policies. We have density going up in Gothenburg. We have people moving in. We have new traffic strategies. We have a 50-minute or 10-minute city concept. We have new integration through digitization, electrical power grid, different system integration aspects. And we have our promise to everyone, the freedom to move in a personal, sustainable and safe way. And by the way, we are not a car manufacturer. We are actually registered as a company that provides freedom to move. We changed that a couple of years ago, if you don't know. So the vision is to ensure the continued good life of individuals and organizations with regards to transport challenges. And a good transport system with different good choices to choose between or among as transport of goods or a citizen or customer. This is a very important part, and this vision has been worked out together with City Gothenburg, Volvo Group and RISE. And it's something we believe in very much. That the system has to relate not only to environmental or the financial or economical aspects of the city, but also to the needs of people, of students, visitors, the businesses in the city, and of course health. I mean, a green city won't be very nice if it's not healthy. Or safe. So from our part, why do we engage in something that in all likelihood actually will end up with less cars in the cities? Well, it's our business strategy. It's actually part of our transformation as a company. We want to provide convenient mobility to battle climate change and to really reach out to new customer segments. Now, I realize there's a lot of cars in these pictures, but we truly mean this. We truly think it's so important for our companies to stay ahead of the curve and lead the change, not to wait for the demands and policy changes to arrive. And we have 5 selected use cases, messy, because the reality is messy, that we are starting out with. We have consumer trends and technology shifts on one side, and we try to create value for society's customers, employees, and of course our owners. We have charge, park and pay, traffic flow, safety, one-stop mobility shop. You recognize before anyone go and think, didn't I hear this 2017 or 18, whatever? Yes, you did, but not in this version. So this is building on a lot of work for many years, and only at Volvo Cars, it's more than 100 person years put into this before we arrived here, I want to stress. So why the Green City Zone Initiative? Why is zone? And how does that connect to our corporate strategies? Well, it's scale. Scale is difficult. Scale is messy. If you want to, like this, what does put the traffic outside Hamburg to stop, standstill every day, more or less? The odd case. And BMW, an old one, being overheated. Someone blowing a tire. Or someone just seeing an accident on the other side of the road, slowing down. The odd cases. You never address the odd cases if you only do proof of concepts with 3 cars, 4 cars, 5 cars. You need to multiply it by 10,000 cars, 10,000 users to actually start studying, to really come up with something that works. I talked to Mikael Iver at Trafikkontoret in Gothenburg a couple of years ago, and went an old idea, of course. Why not use the diamond lane, the bus lane, for connected autonomous cars? And said, well, his response was, what kind of uptime can you guarantee? If one Volvo car breaks down there, I guarantee you, you will see a really, really big standstill in all of Gothenburg, or a big part of Gothenburg. So you need to guarantee us 99.9999 something. So scale. Scale is really difficult. So if we put Volvo car challenges here, we put the cities challenges over here, and you find out the joint challenges, the physical challenges, the legal challenges, the individual challenges. You come up with convenience, accessibility, healthy city life, traffic strategy, safety and security. And I just go directly towards this. You are supposed to read this clockwise. Okay, hi Volvo, I want to go into the city and work as usual. Well, let's plot a road for you. Our soon-to-be or future-to-be smart assistant help you. Read this clockwise. We skipped all the animation in the interest of time. You arrive to the designated parking spot. There is a charger actually working there. Could I just put it in? Yeah. Close the door, just leave. No hassle. It's the only way to get people to use these things. Zero hassle, zero extra time. Same thing here. I need to go to see Anders in the city, despite that, okay, for some reason, you need the car. Okay. You get the route. Well, something has happened. There's a standstill. Do you want another route? Yeah, sure, I get another route. Now you're actually entering a quite difficult and accident-prone area. Do you want a warning? Yep. Well, I have used my settings to get warnings. Okay, at this time of day, this particular crossing outside of school is really dangerous. Okay, you get an alert. And note the picture further down to the left. Even if you're on a bike, the same crossing is still dangerous. You get the same kind of warning. Doesn't matter. Now, if you leave your bike or car, you go to a meeting. Again, you live outside the city. You take the train into the city. Maybe you're from Stockholm. I'm born there, so I think I'm allowed to joke about it. You get to Gothenburg. You do not have an access card for trams. Do you want everything to be handled? Yeah, sure you want that. And I know there are a lot of other integrators out there talking about the same thing, and we are not saying that we are going to be integrated, just that there's a need for it. You want to take the tram or why? Maybe you want to jump, take a seat in the RoboCab. It starts to rain. A lovely November Thursday. It happens that it rains, even if you plan for other things. And then your boss calls and you have a meeting halfway out towards the airport. You really need a car. Well, why don't you take a fleet car? You turn the fleet car, get back on the train and back to your home. It's a way to make things smooth and easy and get your freedom provided. Now, a lot of this is data-driven. Of course, we handle the data in the car. But there are, and then people go, oh, why did you hook up to the system? Well, there's not the system anyway. Maybe we should be happy for that, considering all Hollywood dystopias about systems. But there's a lot of cost involved in integrating with all different systems. If you just consider the number of parking companies having their own APIs, it doesn't scale, not very well. We need to work a lot more with standardization. Internet works because of standardization, not because there's one big supercomputer you hook up to. We killed that idea in the 80s. We need to do that here too. And we need to do the same thing with energy. There are standards on the way. We're very happy to work with them, but we want to really push this. It's extremely important, but we push this together, as you see it. And now, if you overlay this with only one more city, Berlin, you get a whole bunch of new actors. It's only if you use the same kind of data exchange protocols you can actually make this work, pan-European. It's dead on arrival, otherwise. You can't go, let's do this for this particular block. Does that cost us? Yes. Will we ever gain enough return on that? No. It has to scale. And, well, everyone else has to draw their own conclusions, but this is one of ours at least. Now, Jan goes in next step then. There are more than 300 cities in roughly the same size as Gothenburg in Europe. For every one Paris, you have a whole bunch of Gothenburg clones. And they all have harbors, airports, railway stations, and bottlenecks. You have high flow density areas, you have modern and older work areas, living areas, and so on. Now, how do you address a future scale problem doing research or action research or innovation actions today? Well, you do that by borrowing an idea from New York City or London or other areas in social sciences, where people said, New York City, it's like a country. It has the same amount of people as Sweden. You can't change the entire city at once. These ideas originated already in the 70s, but got famous in the 90s. You take one borough or one district, or in this case, one zone, or 3 zones actually, and say, well, if it's big enough to have its own ecosystem, you can actually address scale issues and study them. But it's still small enough to have one major stakeholder for every kind of stakeholder. You can actually get them into a room and let them talk to end. You can actually agree on stuff around one zone. The entire city is too big. The block is too small. The zone is a good size. It's big enough to do statistical hypothesis exercises on. And we have, and if you say that you go for 100% electrical, 100% connected, 100% automated in the zone, if you say for the city, you would have to wait until the entire world is the same. But in the zone, you can try to push that, or at least to reach 70 to 80%. So you get something similar enough to the future state to study. So that's our idea. And of course, we have our own goals. zero CO2, improved air quality, zero seriously injured people, 50% increase to the transportation until 2030 in the zone. And of course, you have, let's see, that's the time. And what we say, zero emission, it's not the steel, even if you're buying zero carbon steel now, but it's zero emission tailpipe, including the power generation. And for this zone, for the 2030, or for Gothenburg, we're talking about 150,000 more inhabitants in Gothenburg, 80,000 more in apartments, 80,000 more jobs, and 5 million more visitors. At the same time, we're talking about 25, and these are numbers from the city, 25% less vehicle or fewer vehicle miles traveled in the city in absolute numbers, the total sum. And bike plus 71% from today's level, walking plus 10, public transport plus 20, private car minus 30, 33. So that's the framework. This is our ambition, and we invite you all to join us on this journey.
Great.
Thank you.
Thank you very much, Christian. Really nice presentation, and I liked a lot of the things you said. Particularly, I think it's very interesting to talk honestly about things being untidy, messy even. So I think if we confront that, then it's better than pretending we can have this perfect solution. And I also think it's important sometimes to be willing to try things before, which are not guaranteed to work, because if you try only the things that are guaranteed to work, well, you probably don't try very much in some cases. So I thought it was a great presentation. I'm going to ask Kajsa to come down and George to come and join in a moment. But while they're just doing that, you mentioned right at the beginning about the challenges. And I just wondered, without going in depth, but which sort of the areas that you outlined regulation, behavior, technology. I realize that they're all challenging, but which one sort of wakes you up in the middle of the night and you think, ooh, that's a struggle, that one, it's always tough?
Yeah, so the first one, there are two actually. Yeah. The first one is very well known and debated intensely right now, and it's charging power basically.
Charging power, right.
And to get enough power at the right time and so on, distribution. But I think there's so much debate on that, so I don't have to comment that further. Yeah. The second one is surface space.
Right.
People do not, I mean, like this, people talk about let's park the car and you have vehicle to grid and you can add value. Fine, but you can also build a condo on top of the same parking space, and that's worth 5 million kronor.
Yeah.
So the space is the gold of the city, and there was someone in the city told me.
Yeah.
So it's really competition for space.
Yeah, it's a critical thing. Yeah.
Yeah,
great.
And we can't make more space. We can make more of everything else, but not space.
Yeah, sure. Okay, maybe you would like to come and stand in the middle, Kajsa, and George, that's fine. And I can, if I stand here, is that, do we need to be closer? A little bit closer, okay. Is this okay? More over this way.
Oh.
I have to go over okay. Like this. It's okay?
Okay.
Okay, oh, you should be by the tables. Okay, then I have to ask you to pass my phone. Okay, just to remind everybody that if you use the chat facility, you can send in a question. We have had a few questions, but not so many. So I'm going to give the word to Kajsa first, but I'm going to ask you to tell a little bit about something, because you and I discussed this beforehand, and I think, you know, we've heard a lot of things today which are sort of about things that are actually quite disruptive. So some of them are around fundamental changes, like to move to a hydrogen as a fuel. But others are much more about sort of technology, and sometimes just a tweak to the technology, you could say. So, I mean, I know in the active travel, electric scooters came up, and this is something. How should we kind of, you're a person who works with logistics and systems, when you see this kind of unruly things that happen.
Yes. The messy things.
Yeah, the messy things.
I think messiness has come up as a concept several times. But I, when listening to this session also, I think relating to both what Senke said about the role of local authorities, but also about the problems with pilots, only staying with pilots, not being, it's hard to scale them up. And I think you also mentioned that. And then you mentioned, Stefan, that scale is messy. And then I came to think about when listening to you, and I mean, George, you were talking about all these new technologies that we are also good at Chalmers and Gothenburg University to develop. We are good at that. That is our core business. And these technologies, they are well working, good new technologies. We could even provide different solutions that actually end up in value for users, and there are business models. But then and we say that they are we need to scale them up. And then we have these electric scooters. And now I think we all see that, wow, the scale is enough now. I mean, you see, here we have scale. And then scale is messy, as you said. And then I think that is really true. Sometimes scale is even messy. And then it relates back to what you were talking about, George, I think, about how do we fit these in a one sense, perfect solutions that provide value and firms can actually gain profit from them. But then when you put them in this transport system that is built around total other logics, it gets messy.
Yeah.
And obviously there are no solutions. And we see like the city trying to sort of resist by introducing geofencing, by now starting to charge these companies for placing these out in a sort of, they try to reduce. So it's this fine-tuning, and you talked about converting or making use of bus lanes in new ways, and how different actors try to fine-tune these changes to sort of, I don't know, manage. I don't know if that was
that's fine.
But it was some reflections from the session that we had.
Okay, so what I'd like to do is I'd like to start with one of the questions that came in while we were there, and I asked Sunke first, as he was the first to speak, and it was, who do you think should be taking the lead in developing this vision for the city of the future? And just while you're just thinking a little bit about that, just to say that in all the pictures, it was great to see that it doesn't rain in the city of the future. So Christian's comment on November was, it won't be like that. I have to get my computer while you're just thinking. But Sunke, please carry on.
Yeah, I think you might. Looking out the window, I think it's raining right now. And I realized I live in the green Gothenburg city zone. That was interesting to see as well. Who should take the lead? Yes, following the topic of my talk, I think it should be the authority side, actually. And I think we have seen now a lot of new concepts, technical new systems performing very well for a long time. And Kaiser mentioned we cannot achieve scale. We cannot go from pilot into large-scale introduction. So maybe we should think about not only promoting, giving incentives to new solutions, good solutions, but also somehow punish or regulate or the unwanted solutions that we have to work maybe more on both sides. I think when coming to freight, it's always very high reluctance to actually regulate a bit tougher and somehow to exclude diesel trucks or so. So I think we need to work more with both ends of the spectrum, like punish the unwanted solutions and incentivize the wanted solutions. And that is, of course, an authority task, I would say.
But I think it's very interesting when I heard the presentations from all three of you, although you say this is about freight and logistics, and in a sense, Christian is saying it's about mobility, and George is somewhere between the two. In the end, we go back to the same question that they're all sharing this space, and you can use it for so many different things in some cases, or not in other cases. And I think it is very interesting who can take this lead in different circumstances, which is why I like the structure that you had for that. But I also think that we have to then look at these zones because they become quite interesting. So I will come to George afterwards. But Christian, I get the feeling you put 100 years of effort into this. You see sort of the role for industry to sometimes take, if not the lead, but to at least be well up with things.
Well, I think we have seen recently many times now in different areas where technology and industry actually tried and offer new solutions but sometimes not, there aren't even regulations for them. Because you have to invent them after the fact, so to speak. Now, in mobility, there are a lot of regulations. We work very closely with authorities on a number of issues, especially safety, since many, many years back, but also in environmental issues. So of course authorities have to step in and deal with, for instance, scooters. But the scooters appeared first, and the policies appeared afterwards, or are beginning to appear now, like in Copenhagen and so on. So, but let's turn down and let's not wait to be surprised by the next technology revolution, but actually do this together. The private-public partnership is a very good concept. We have this new development area, Forsåker. We work together with Mölndal City on, and also within the older, messier part of Gothenburg. Let's do this together. And I would say something, more of a personal observation, because this is going back, those 100 Persian years goes back like a decade, so it's accumulated. But still, we tend to, in Sweden, to go for the tidy solution, the perfect solution. Now we're running out of time. We have Fit for 55. We have pledged 2040 for carbon free. We all, I mean, like the Skanska scrapers at Ulvi, they're going to be populated very soon. There are no additional road space anywhere. We have to go for the less tidy, a bit more messy, but functional solutions now.
Yeah.
And then we can spend a decade on the tidy them up, I think.
Sure. And I think that's an interesting echo of one of the comments in the hydrogen session this morning, where it was suggested that, you know, the search for some sort of perfect solution is driving away a pragmatic way forward, perhaps, at times. But George, you kind of presented an overview in which, as you said, there's a hierarchy of use here, which cities have developed with slightly different ways, place versus movement, vulnerability, perhaps, versus you know, the lack of the danger of large vehicles and so on. Those come mainly from the city side, I suppose. So, but do you think, is it enough for the cities to have the vision, or do we have to widen out the actors who have the vision, if I can put it like that?
We definitely have to engage with other actors.
Right.
I think that's why I was calling for sharing the visions or developing shared visions. I agree with Sanka that the municipality must be involved. The space is municipal, the space is public, it's ours, everyone's. So they must be involved. What happened with the scooters, for example, is sort of a very kind of rebel way of doing it, which is throwing out the technology out there without people knowing. So the guidelines that exist, and cities have been for decades trying to develop the perfect street and the design for streets, but all of a sudden comes something totally new that they were not aware of, that kind of falls through the loophole of these regulations. And so it's been at the public cost and social cost that of accidents and time that slowly regulations have been implemented and are just now being implemented. And I don't think it can happen like that all the time for everything. So we really need to have some dialogue, and we need to have people working together. I agree that the municipality must be involved and should most likely lead, because it's ultimately the public space. But the technology providers, the designers, and all these other actors must be part of creating this vision.
And I think it's still challenging, though, even within a city, because within the city you have people who are concerned about, you know, long-term plans, maybe 30, 40 years ahead, because infrastructure lasts, well, longer than that even. And, you know, at the other end you have people dealing with the traffic regulation for this street, and not even this zone, but or maybe this corner or something like this. And this is also quite difficult to put together, I think. And I think that's also why sometimes these are really apparently rather simple things become actually very complicated in practice. And I think if you look at the e-scooters, and we will move off the e-scooters after this, it's quite interesting. I chair the Central London Freight Partnership, and this group of people have become, I would say, slightly obsessed about the e-scooter trials, in which the use of the scooters is much, much more curtailed than it is in Gothenburg. But already they see huge problems in terms of these trials even. And so it's kind of very interesting that this one thing does draw some people together in a particular area.
If I may, I think you touched upon something extremely important here, that the timescale of infrastructure is very long. from the perspective of digital transformation, we have seen the event of the gig economy, of Uber, Lyft, all these new, and God knows what's waiting us around the corner. But these changes appear close to momentaneous compared to the age of the infrastructure of a city of London.
Yeah.
And it's important for us to address that and realize that. And the problem, as a scientist myself, I also realize that even in my own subject, the speed of science is rather slow compared to the speed of the gig economy or whatever you want, if we leave the scooters out of it.
No, but I mean, I think it's an
it's
important question, because what you can also see is the things in retailing, for example, where I know, Kajsa, you've looked a lot at e-commerce and the rise of e-commerce. And who was to predict that rather than having, next day delivery, then it's same day, then it's within an hour, and now it's within 10 minutes of grocery baskets being delivered to people using e-scooters, or not the scooters like here, but e-mopeds and e-cargo bikes. But this is this change has happened really, really fast, and a lot of it's funded by venture capital and other ways of looking at it. And it's very hard to regulate that or design a policy that fits it. So I don't know if you have a comment.
No, I just have a comment, because you could also read, I know that the e-barometern for the second quarter in 2021 just arrived today.
Right.
And there you could read, I read it a little bit this morning, that the share of e-retailers that offer free shipping and returns are increasing, and that is interesting, and it's a problematic, because you have sort of fooled the whole society that freight transport is free. And as long as these large companies continue doing this, of course the smaller ones need to follow. And it's really, I mean, it touches upon, I think, also what Sönke talked about before.
Yes. Okay, but maybe we can go sort of extend a little bit on this discussion then, because you touched on another thing which Sönke mentioned, which was that the city, and in a way it comes to all of your presentations, we talk about the city, but the city isn't just the city. There's at least this central area, then there's an outer area, then there's, and one of the problems, it seems to me, is that it's not easy to find simple solutions. So, Sönke, when you presented your work, do you find people want to talk about the centre of the city, or do they actually go to the suburban area, which in a sense, in terms of urban freight, I would say is a little bit ignored to some extent. So when you present it, do people immediately just think about the centre, or what about this question of the city isn't just the city?
Yeah, that's a very good point. I've been working in the projects that were mainly dealing with high-density new urban areas, as I mentioned before, like in Uppsala, but also here in Gothenburg, the density project with the Frihamnen case study and so on. So usually if we hear about urbanization, densification, we think about these areas. But I totally agree. I think if you look at where urbanization takes place, where people are moving, it's not into, the majority is not moving into these high-density areas, but more on the a little bit less dense areas in the suburbs and so on. So, and if you look at what is defined as an urban area in Sweden, it's very small areas actually, in small towns. They are also called urbanized areas. So I think definitely it's relevant to look into not only into these very special high density areas where we probably see these solutions which I presented as well, but also how we organize passenger mobility and also freight mobility in this much more relevant in terms of population size areas, and even also rural areas. We have the divide between cities and the countryside as well, and there actually the accessibility to home delivery services, so it's much less than in cities. And knowing that e-commerce is getting more important for accessibility to goods, it's also an issue we need to look at in the future.
Yeah. And Christian, you mentioned about the zones, and you did, because the presentations we've had to squeeze everything very short, of course. So, but the three zones are different to each other, aren't they? And I mean, that's obviously intentional, so that you can learn different lessons.
So we have a high flow, high density around Korsvägen and Liseberg and all that. So you have millions of people going through. Real difficult there. And then Forsåker is this new area where you have basically span of cars in the central part, and you have parking houses outside, and a miniature version of a 15-minute city, maybe a 5-minute city. And then you have Lindholm and with new tower and all that. So you have both an urban but also a very intense working area. But what really actually, if I may make a comment on the scientific part of things, we have come to the conclusion that it's extremely useful to try, but it's difficult to find these numbers. Key numbers, key performance indexes, like the money generated or the income generated per square kilometer, how many people you have per square kilometer, how many miles of road you have, or lanes, because 3 lanes are 3 times as efficient as 1, of course, and the average speed. So you actually have like the maximum throughput numbers, things like that, and also electrical power available, the delta between available and used, because that spells available charging possibilities, things like that, just to break it down. And it's surprisingly difficult to find, because in these debates we tend to look at London or Paris, New York City, but New York City has 60,000 people per square mile. LA 12,000. It's a factor of 5 in difference, which means if you read the journals, some business models are dead on arrival in LA because you don't have a density. And Gothenburg is actually it has the lowest density of Stockholm, Gothenburg, and Malmö. So these numbers would be, in comparisons, just to classify, would be immensely helpful.
Yes, and also that's, as you say, to define, to describe the city in a more meaningful way for decision making to some extent. And I mean, that reminds me a little bit of your work on the loading zones in the Spanish city, where you actually started to calculate some things around, well, I knew other work, George, but do you want to comment on that question about data?
So, a couple of things. Definitely we need to be able to describe the city and the different parts of cities and parts of the built environment regions, metropolitan regions. And in our field, we do that. I mean, we have both models, like the idea of the transect, of different levels of density and different levels of land use mix in different zones, in different areas. But we also, based on the work that I do, is more like using geodata to start quantifying and extracting precisely this sort of quantitative KPIs that define what this part of the city is like. And this is really fundamental to identify these typologies of city neighborhoods. I've done a work, for example, on the Randstad region, where I subdivided in some 4,000 neighborhoods that have a very unique profile based on the characteristics related to mobility. So this is fundamental. Why? Because solutions, as you say, are not the same everywhere. They cannot work the same anywhere. So knowing what place you're working with is a very important starting point.
And the characteristics of that.
So characteristics of that. The other thing is, from the urban design perspective and the visions that I've shown, of course, they focus a lot on the city center, on these high density areas. There's various reasons. One is there's more people there, and also there's more challenges from the space perspective. So if you move to rural, suburban, space is less of an issue. So the question of whose space, how do we, the competition for space is lower. There's less people, less demand, and more space as well. So there are other questions. Still, the sustainability challenge exists, because it means there will be longer distances travel, more energy spent on travel or on deliveries, etc. So there are certainly many questions that need to be solved there that are just different.
And I think there's also a kind of forgotten thing about space, and that's where one space joins another space, if you like. So like the interface between things is not so well understood anyway, I think, to some extent. So how things get to, how people get to buildings, maybe we're better at that. But how things get to buildings, we don't have very much insight into that. We know, we know surprisingly little about how products get to typical, when they're delivered, get to buildings. And when Sunka shows the map of the pickup point and the person's home and so on, you know, some of those things involve very complicated walking trips by the person delivering it and very complicated trips by the person receiving it. And all of it is about this sort of interface. I think the interface is also a very interesting area to look more into, yeah.
Yeah,
Kajsa.
I totally agree about the interfaces and thinking about what Sönke brought up about the issue of consolidation in these systems as well, with these last mile logistics. And for example, the delivery boxes that we can now see popping up. We have different freight carriers, but all having their unique unique boxes. And so this is also, I don't know if you investigated that, Sönke, about sort of that kind of sharing space in delivery boxes and how that could be also improved.
Yes, it's a very interesting observation what is happening right now. We have, I remember when I presented this project, which I presented now to the Regeringskansliet, at that time, I got the reflection, it was January 2020. No, it will never work with operator-neutral parcel boxes because you have to make the decision how to deliver when checkout, and I don't really understand everything what they said there, but it was said, no, it will not work. In the meantime, now we have iBoxen, maybe you've heard about it, a new actor, which is not a transport company, but just a company providing parcel boxes, and they're offering them for the transport operators to use them, and there are a few using them now. So it's happened very quickly. On the other hand, we see companies which are specialized in home deliveries like Airme and Budbee. Sorry, not Airme, but Budbee, they started to put up parcel boxes as well. But in the beginning, there were home delivery companies. And on the other direction, we have Instabox, which is by the name a box provider, but they start now also to deliver to the homes. So it's, it's a very exciting time. A lot of things
I think there's a lot of change
right
happening in that area. And I was at a conference in California 2 years ago, almost now, in this period, and this topic of the boxes came up, and quite incredibly, one company said, "Well, we will never put our package into somebody else's box.
Exactly.
We will never ever." Yeah. I mean, this can't be the true but I mean, I think we will be quite surprised when we look in, say, 20 years or so to think. So you remember when they used to make all those deliveries, and they used to do nearly all of them between 7 in the morning and 11, and because they said it was too noisy at night, you know, and we can't solve any of those problems. So I think we do have to solve some of those things. And I suppose we're coming to the end of this session, so I don't want to open another question. I suppose I'd like to ask you quite a hard question in a way, but I was thinking about presentations, and I think in common with people who are attending today and with you, I go to lots of things, and sometimes I remember some things and sometimes I don't. So I wondered whether each of you could say, what's one thing you'd like me to remember, or not me, but I mean, what would you like someone to remember who was listening today about what you were talked about today? What's something that you think, this comes back to me time after time, that this is what it doesn't get remembered, or this is what's overlooked? And Sönke, you went first, and you have the benefit of a little bit of distance, as it were. So I'm going to put it on to you to lead off on this. Just what should we remember?
Okay. I would like, if any city authorities in the audience and listening, please do regulate freight more than they do today. So that is a requirement that we can implement these innovative solutions which work technically wise, logistics wise, have a good environmental outcome, but we need to regulate the bad guys a bit more.
Yeah, to change things in a different direction. Yes. Okay, good. And George?
I would say that we cannot predict and optimize everything. Therefore, we need to sit together and develop shared visions, both municipalities, designers, freight operators, and
Yes, and also I like the slide when you had the optimization versus improvisation. We have to think a little bit about this. I said this, that I came to Runan not to here, but to a slightly different meeting last week, and across the road they're rebuilding that building to be a residential place, I think, for Chalmers. And there was a very big digger moving a huge amount of gravel, and I needed to go past it. And the person saw me, and I went like this, and he went like that. and I went behind the digger knowing it was perfectly safe to do that. And I was thinking, what if it had been an autonomous digger? We'd have had to invent some system around that. So improvisation can be very attractive in some ways. And Christian?
So, well, we already said it, but stop looking for a grail.
Yeah.
Scale is messy, and we're out of time.
Right. Yeah. Good. Kajsa, did you want any last word, or we can close the session?
I think you should have the last word.
No, okay.
Yeah.
Well, I can just say that although I know a little bit about some of these studies, I always learn something new when I listen to the different perspectives that you have. In the case of George and Sunke, of course, I know something about their research, but other things always come to my mind. And the green city zones, I've heard a lot about it and read some things about it, but still for me, it's different when somebody talks about it. So for me, I really appreciated a lot what you all had to say, and I think it was great that you would join Kajsa at the end to join the panel and make a little bit more livelier discussion. So I'd like to thank you all very much, and thank you to everybody who's been listening today on this part. We will take a short break, I think of 15 minutes, and then we will come back and we will have a session about horizontal collaboration in the supply chain, led by Dan Anderson. And this will talk very much about how we can improve efficiency, improve environmental quality, and how we need to, in order to do that, we need to rethink how we manage and run supply chains. So it will have a somewhat different focus. If you have questions or comments, please put them in the YouTube chat. We may not get to answer all of them today, but we will be something that we think about, and we can also take it into account in thinking about initiative, seminars and other work. So please comment, questions, put it in the chat, even if it was about a presentation that you heard earlier today. Don't worry about that. So we'll be back in 15 minutes and start with horizontal collaboration in the supply chain. Thank you very much.
Right, I'm Dan Anderson, and I welcome you to this session about horizontal collaboration. In order to reach the sustainability goals and make the transport system more efficient and effective, we can't only rely on technology, infrastructure, or changing people's behavior, as we have heard about earlier today. We also need to change the way companies organize their freight transport operations. And one way to do this is by utilizing horizontal collaboration. This is something that has been recognized by a number of organizations in Europe, governments, EU Commission, and also the Swedish government. And therefore, I'm very glad that we will hear a little bit about what assignment they have given to the Swedish Transport Administration, Trafikverket, that we will start with that. But it's not only authorities that has realized the opportunities with horizontal collaboration. Businesses are increasingly embracing this type of collaboration. However, it's going very slowly. And therefore, I'm also very glad that we could get some insights from a real ongoing horizontal collaboration. We're not talking about demonstration project, we're not talking about test or anything. It's the ordinary everyday operation that we will hear from the experience. And that will be the second out here. And finally, we'll get some academic perspective on what's going on in Europe and also in Sweden. So by that, I leave the word to Christer Strömberg from Trafikverket, and not the floor, the screen is yours, Christer.
Thank you very much. You can see me and hear me?
Yes.
Can you see? Yeah, perfect. Well, thank you very much for inviting me to talk to you a little bit about our government assignment. My name is Christer Strömberg. And I work with the assignment together with my colleague Katrin Wallinder, who is the assignment leader. And this assignment is called Horizontal Collaborations for Increased Load Factor with the support of data sharing. And the Swedish Transport Administration got this assignment in connection with the National Freight Transport Strategy that came in 2018. And the purpose of the assignment is to increase transport efficiency and the load factor in freight transports through mainly dialogue with relevant actors. And this work is a very long term, and that is the reason why the assignment will continue until the end of 2029. And the assignment came about because there was requests from some industry actors to get an open database for data sharing. So when we got the assignment, its name was in the way that you can see in the left rectangle. And the more we have worked with the assignment, we have found that it is very difficult to speak in terms of open data, and have instead chosen to rename the assignment in the way you can see in the right rectangle. The funding from the government is 1 million Swedish kronor per year, which is not that much money. So we are very dependent on alliances with other projects and initiatives and collaborations. And we also try to initiate research and development projects that explore issues related to this assignment. And so far we have produced these reports within the assignment. And the report, the one you can see at the top left, is the first we delivered to the government in 2019, in which we more or less responded to what the government commissioned us to investigate, namely to propose a system for exchanging information and open data for horizontal collaborations. We would also suggest how such a system could be organized and managed. And the second report we published last year, and that is a feasibility study where we looked at paths for continued focus of the assignment and what measures that needs to be implemented in order to scale up horizontal collaborations and expand the knowledge of how players in the industry can collaborate. And the conclusions we made in these two reports are that certain conditions are required to be able to pursue horizontal collaborations in full. Technically, it's possible to create systems for open data, but under certain conditions. When we did this first study, we interviewed a lot of actors in the industry, such as transport buyers, carriers, and representatives from technical support systems. And many of them stated that they are willing to share data under certain conditions, and that this can generate benefits for their own organizations. We also noted that issues of security, legislation, and the GDPR needs to be resolved, as well as the compliance with the Swedish principle of public access to information and the Competition Act. Other issues that needs to be resolved is who should have a coordinating role in this. It's very difficult for a private actor to take that kind of role. And several of the stakeholders that we interviewed stated that a neutral party should have that facilitating role. And lessons learned are that several prerequisites are lacking for horizontal collaborations to be able to function fully. One conclusion is that measures for creating conditions for collaborations need to be explored further, and projects need to be initiated where these measures are tested. Excuse me. This is needed in order to be able to scale up the work in the longer term and increase knowledge of how collaboration can become a reality. Then it is probably not, when we have studied this back and forth, it's probably not just about horizontal collaborations, but probably a combination of horizontal and vertical collaborations. And we have also concluded that it's not relevant to discuss in terms of open data, and it's far too costly to build an open database. It's rather data sharing between actors in a secure way and at a level that the data owners want that is realistic to talk about. And when we reported this to the government, it turned out that they're not interested in creating a system of storing and managing open data for this purpose. And that's why we have chosen to rename the assignment to be about data sharing instead of open data. And when we did the feasibility study, we defined these three key concepts in order to clarify what the assignment is about. And in the case of horizontal collaborations, there is no accepted definition really of that concept, but it means more or less that two or more actors who are at the same organizational level share information about their goods and traffic flows. And regarding load factor, there is a consensus that a high load factor is important both to reduce transport costs and the environmental impacts. And previous studies, however, describe the load factor primarily as a part of a larger follow-up system, especially regarding efficiency, environmental issues, and costs. And when we have discussed the concept of the open data, which we have done a lot, I can tell you, it came to the conclusion that it's really more, as I said, it's about data sharing than open data that's available to everyone that is interesting to discuss. Within the assignment, then, we have made an action plan for the next few years based on the knowledge that we have gained from the feasibility study. And the activities mainly focus on measures to create conditions for horizontal collaborations and data sharing. And the activities you can see here are about gathering information and building knowledge. And since we only have 1 million Swedish kronor per year, there is no room for much more than that. So several of these activities are also about initiating and having a dialogue with the industry and disseminating information from good examples. And discussions are also underway with research actors about some development projects where horizontal collaborations are a part and where knowledge from the listed activities above is tested in practice. This is now I'm coming in into a few examples of these activities that we're doing. At the end of last year, RISE presented a report of legal conditions for information exchange systems for horizontal collaborations with the aim of increasing the load factor. And the study was conducted within the framework of Drive Sweden Policy Lab. And we at the Swedish Transport Administration, we are currently finalizing a summary of the most important legal aspects related to horizontal collaborations and data sharing. And within the near future, this fall, we will publish this in a report on which you can get access to from the Swedish Transport Administration's website. And the conclusions from the RISE study are that the Swedish Competition Act is really an obstacle to horizontal collaborations, and it's unclear what it's meant by open data and how it is compatible with the copyright. And that part needs therefore to be further explored in this government assignment. But there are really no legal obstacles to data sharing as long as there are no formation of cartels or the risk of identification of individuals, or if individuals can be identified. Then we have another project in the pipeline together with VTI, the Swedish National Road and Transport Research Institute. We have initiated a research project where the purpose is to develop key figures to analyze the Swedish freight transport system. And the key figures will be developed considering different segments. And the overall goal here is to generate new knowledge that makes it possible to evaluate the Swedish freight transport system in a reliable way, based on resource efficiency and efficiency potential. And this project will start in the beginning of next year and continue throughout 2025. And the third example is a project with NTM, Network for Transport Measures. They are completing a study for us of transport efficiency and load factor, where the focus is on a number of case studies of various actors in road traffic and in rail and in shipping. And this study sheds light on various aspects of an increased load factor. And in these case studies, particular measures, practical measures, and the effects achieved at the different companies are described. And the picture shows on the low right here shows how optimization of flow and resource efficiency can constitute conflicting interests in markets where resources are not priced correctly according to corporate and societal costs. And with expanded system limits, some claim that both flow and resource efficiency can be achieved through an approach which is similar to lean. And I forgot the last one, but this is the last example of projects we have right now. And this is a demonstration project with the city of Helsingborg, which is called Transparent Transports. And the focus of this project is to increase knowledge about goods and freight transport flows through a cooperation between different actors. And the project is, this is a living lab within Federated and DTLF initiative. I can get back to you what that is later if you haven't heard about it. The purpose is to, with this project, is to, in dialogue with suppliers and carriers, see if it is possible to coordinate the distribution of goods to the city's units. And more specifically, it's about collecting and analyzing flows of goods and traffic that arise in the distribution of goods to a school in Helsingborg. And this project started in September last year and it will run until December next year. And to get back to Federated, that's a research platform within the European Union with the aim of creating efficient information flows in transport corridors by all parties sharing information and at the same time going from paperwork to digitizing the accompanying documents. And the Swedish Transport Administration's mission within the Federated is to intertwine traffic types in multimodal system solutions for primarily shipping, road and rail, and demonstrate these solutions and clarify the benefits for different stakeholders. And the DTLF, as I mentioned, is the Digital Transport and Logistics Forum. That's a group of experts that brings together stakeholders from different transport and logistics communities, from both the private sector and the public sector. As I mentioned in the beginning of my presentation, a very big part of this assignment is about collaboration. And there are many initiatives, projects, and focus groups that to some extent deal with these kind of issues. For instance, within Closer Lindholmen Science Park in Gothenburg, where there are collaboration groups dealing with digitalized and connected logistics, urban logistics, e-commerce, and so on. And Closer is a neutral platform that gathers actors from the business community, industry, universities and institutes, cities, regions, etc., etc., and to establish collaborations and projects that lead to enhanced transport efficiency. And beside of that, we also try to stay informed about what is happening at the European level. For instance, this ALICE platform or project. On the Swedish Transport Administration's website, you can read more about this assignment and get access to these reports that I showed in the beginning of my presentation. Unfortunately, this is in Swedish, but if you can contact me later, then we can see if we can do some translations of it. And that was my presentation. Are there any questions?
Yes, thank you very much, Christer. I was just looking for if I could see if I got any questions. I can't see any, but perhaps there will come. But in the meantime, I could ask you something relating back to what we already heard about this. We strive for the perfect, but perhaps we should more try to reach what's feasible. And when it comes to there's a number of things that are lacking, you said a number of measures. I wasn't really sure. Could you give some examples what type of measures that are lacking, and what do you need to get something that is feasible? Perhaps not the best solution, but what do you think, based on what you've learned so far, what do we need to do in order to get this running?
First of all, it's more or less this, as I mentioned, the security, the GDPR, and the Competition Act in Sweden. Many of those kind of issues are not investigated enough to go ahead with this kind of work, and this uncertainty of what is open data and what is shared data. I think a lot of actors are reluctant to get into some kind of cooperation if they're just told that there will be you have to share your data. It's more or less up to have to open access to data. It's more about sharing data, of course. So and we haven't really seen so much follow up on this work either. So it's very hard to have something to some kind of a stepping stone to go out from, so to speak.
Also relating back to just the previous session, what do you see in the future? Now you are handling an assignment and doing some investigations into this topic and so on. But could you see any role for authorities or for Trafikverket in the future operation or handling horizontal collaboration in some way?
I think we certainly can be an actor, part of others, but I don't see the Swedish Transport Administration as this facilitator, as I mentioned. The actors that we interviewed in this during this pre-study that we did, they said that they would like to see some neutral actor that take on this role. But I don't think Trafikverket or the Swedish Transport Administration is that actor. But we can certainly be a part of some kind of work as another actor. Another neutral actor can have.
Right. Thank you very much, Christer. Now we'll take it to the next step, to the next part of this session. And I welcome Patrick Strömberg, who is the CEO of Logs Logistics. and Magnus Eliasson, who is the logistics manager at SSAB. Now we will hear from them, from their real experiences, and also from a business perspective on this. Please, Patrick and Elias.
Yes, thank you. We will talk about how we do this on the daily basis. We combine traffic on the Northern Steel Shuttle. And who is going to present this is Patrik Strömberg from Logs Logistics, and I work as a CEO.
And me, Magnus Eliasson from SSAB. I have the role of responsible of our railway transport. And yes, like Patrik said, we will guide you through this topic about how we are up and running this solution today. And a little bit about the background, what effects we can see and what is the actual present state of today, and also if we look a little bit into the future, what it looks like. So what made us start with this? It was some years back in time at the procurement part of SSAB. We wanted to reduce costs of our inbound goods, actually. And as you know, we have a mill of SSAB based in Luleå, a steel mill, where we have a lot of inbound goods being transported. And we thought about how to do this in a more efficient way. And at the same time, we were in contact with LKAB, who had the same challenge, so to say. And they were already having a solution up and running where they consolidated goods on truck. They had a hub in Gävle by the time, and were doing this. And in this discussion, we also realized and put together that we have a system train, a railway running in between Luleå and Borlänge. We call it the Northern Steel Shuttle, with the 3 trains per day with steel slabs from Luleå down to Borlänge for further production and processing. And the thing with those trains is that they run almost empty in the northbound direction. So we realized here we could do something to utilize this transport on rail. And by that we started to move forward on this track. And we also needed another partner to deal with other things related to it, like terminals, trucks, storage, and also being a control tower. And here we got together with Logs Logistics being that partner. And what would we like to achieve then with this setup of intermodal traffic? Yes, we of course the environmental impact is one big thing where we can reduce a lot. Instead of transporting the goods by truck up to Luleå region, doing it by trail, we would reduce the CO2 impact by at least 90%. We also have a high departure frequency of these trains. We have them 3 times per day, every day, year round, meaning a high level of service. We could also reduce the freight costs by utilizing this in a good way. And also managed in the right way, we could improve delivery precision and also cut transport lead times. And it's also possible, of course, to add on more suppliers or customers, what we call them, to this solution and consolidate goods and also having it being used by others.
And then, of course, it was some risks and obstacles with this project, but we did focus on the right things, and we understand that we need to have a transparency and openness in our discussions when we start this. Of course, we had to have the right attitude because we know that we was preparing for a rather windy road to get to the goal. But we had a sustainable model that we like to work with, and we like to ensure that we had a common agenda for this. And now when we talk about the presence, we like to tell you about the business model that we are working with, the production setup, and some opportunities and challenges that we had during the years. Logs are the control tower for this setup, and we are the link between the different operators. We coordinate flow of goods from supplier to the end customer, and we always work with track and trace in real time. We use our warehouses and our vehicles to be the coordinator. The production, it's intermodal transport with the Northern Steel Shuttle between Borlänge and Luleå. And as Magnus told us, it's daily departures. We have a lead time under 24 hours. We have a drop-off time in our combi terminal in Borlänge at 9:30, day 0. And we actually have a delivery time at Luleå combi at 04:30, for 4:30, day 1. That's a good lead time for that kind of transport. When we do this, we are working with a product we call Green Line. In Green Line, we are working with FDL. Today, it's almost only FDL, but we also work with groupage and LTL. Here is logs control tower that we are working with. We get a transport order from our customers or a warehouse call, and a request for a delivery. And we make booking confirmations to Green Cargo, who is handled the steel train, the steel shuttle for SSAB. And then we get a confirmation to our carrier in also Sweden. So they know what's coming. So they could be ready with the trucks to take it to the end customer. And we also have a contact with the spot market. So if there is a spot customer who is wanted to try this, they could call us. During this year, we have doing this. We between 2017 and 2021 today, we have reduced CO2 emission by 95%. It's about 1,000 kilos CO2 per trailer between Borlänge and Luleå. And to the right, we see a model, how much CO2 we are used per trailer if we are going by road with diesel, or if we are going by rail and truck, an intermodal transport. So it's quite a big difference. Between 2019 and 2021, we have actually put on 3,562 northbound units. And the utilization for this northbound is 100%. it's 7 trailers a day. And in southbound, we have goods for about 2 trailers a day today. But hopefully, in the end of the year, we have 4 or 5 trailers southbounds.
A little bit then about what opportunities and challenges do we see in this. One thing is that this combined system to a big extent has relatively fixed costs. And because of that, it's important to utilize the capacity in a good way. And the different parts in that, we need to load the trailers full. We need to make full use of the carriers, and we also need to balance north and southbound goods. And it's not a secret that we have had some trouble to get this solution profitable. And the key in that we know is to add on more southbound goods as well. Like Patrick showed, we have more northbound at the moment. And that is possible to do. We also need to understand what actually drives costs and work with continuous improvements here to reduce it even further. There are things to do there, both smaller and bigger things. There are also one important thing to mention here is that the steel slabs we transport southbound from Luleå, they are transported in one type of wagon, special wagon for steel slabs. And these wagons, which we put the combined trailers, those wagons, those are also special. So it's two different types of wagons. And as you realize, the steel slabs wagons, they need to be transported empty northbound as well, meaning that the train is long all the time in both directions, loaded in one direction and almost empty in the other. And that put a limitation on the length of the train as well, which make it limited on how many combined wagons, trailers we can add on to that train. So, and use that to full extent up to the limit, so to say. Also, another technicality is that it could be a key here to develop the wagons further. If it would be possible to use the same type of wagons, then it would open up a much bigger potential in capacity. There have been tests made and so on, but there are hurdles to overcome in doing that, to put a container on top of steel slabs, for instance, both regarding load profile on the rail and the hot slabs being below a container, and also having having the container being big enough and so on. So we're not doing much on that track at the moment, but it is a possibility for the future. But like you hear, there are possibilities in develop this much further from different angles, and if you do it in a good way, we could have a really good solution, a sustainable alternative which works.
Yes, and our first delivery, I like to show you. It was being done April 2017. We load one trailer for LKAB and one trailer for SSAB with steel plates. And here we see our terminal in Borlänge when we make the lifts. And when we are arriving at Luleå Combi, we take it off. And when we arrive at LKAB in Kiruna, 350 kilometers away. This was about 4 years ago that our first trailer was going on the steel shuttle. And it's still working today, and we are extending, and it's working really well. The future, we like to develop this, of course, and we like to continuously improve and adapt different solutions to more operators. We have a target for 2022 for about 9 to 10 trailers a day northbound and 5-6 trailers a day southbound. And we think if we could use the ordinary wagons like Magnus told us about, we could have much more potential to move more goods. What's important is coordination and the long-term approach, and that we can be competitive with a sustainable alternative like this.
Yes, and finally, SSAB and logs together works for a stronger, lighter, and more sustainable world. And by this solution, and this statement is actually the vision of SSAB, and it connects very well, I think, to this solution and what we are doing in this by this setup. Thank you for listening.
Thank you very much, Magnus and Patrick. And I was just going to look again if I got any questions. No, I can't see any questions, but I could just have a comment regarding this. I mean, it's extraordinary figures that you showed us, that 95% reduction on the CO2. I mean, everyone is talking about how to reduce. Now you could tell them this is the way. But the question is, why is not everyone doing this? And of course, perhaps you can't tell us about that because you are doing it. But Trafikverket, they were talking about the difficulties with sharing data. You also stressed that the importance of transparency and sharing data. Do you have some comments on that? That what should one think about to facilitate that sharing of data or information?
Yes, I think when you are doing this kind of project, I think you need to know each other quite well, and you need to have some trust within the group who is sharing.
Magnus, do you have any other comments on that, or from your side, you feel secure with this?
Yeah, I have a strong belief and conviction, at least. Actually, we see that it works. It's just that we need to do some further improvements, but this is not rocket science, so to say. So there are things possible to overcome for sure, and it works well with some improvements to be made. I don't have any additional comments, I think, about sharing of data. It's important, like you say, but yeah.
Oh, thanks. One thing you said about that you improved or hope to improve the precision, delivery precision. That was quite interesting regarding the type of setup, because I think many people listening here think that this type of system, all right, reduce cost, reduce CO2, but the precision will not be that good. Could any one of you say something about that?
I can start, Patrick, and you can maybe add on. We have had big challenges regarding that, I would say, and it is a demanding rail transport for a long distance, and a lot of winter-related problems, for instance, mostly regarding wagons and wheels and also locos and so on. And when these customers are coming in for this combined intermodal solution, they have really big requirements on delivery precision, which we have a struggle with. We also have a transport leg up in Luleå where we need to reload and get back out on the track again. And when we are late, we miss a time slot and so on, which is really challenging. So that statement is more of a long-term ambition, I would say. We have really challenges at right now, but yeah. Patrik, do you have anything to fill in there?
Yes, we have some challenges, but it's working quite well anyway. And what we are doing, we are trying to make this better, to make this work better and be more safe for distractions. But of course, we have challenges, and we had it during the years. But I think it will be better when we are working with it continuously and finding new aspects.
Thank you very much, and you have put in a very good work in this, that's apparent. And I started saying that it's not sufficient to only rely on the technology aspects, you need these collaborations and so on. But we also show, you have very clearly shown that we also need technology development, and if someone please could develop new wagon for you, I suppose you would be very grateful for that. So thank you very much, Magnus and Patrik. And now we move to the next part and then the final part of this session, where you will meet Gunnar Stefansson, who is an associate professor at Chalmers, and he will provide us with an outlook both in Europe and Sweden, but also perhaps an academic perspective on this. And please, Gunnar.
Yes, let me see here. Okay. Do you see my slides in full size? And do you hear me well, right? Okay, very good. So let's go on then with this. My name is Gunnar Stefansson, and as Don said, and I have my position at Chalmers, Division of Service Management and Logistics, and I belong to the group that would be called the Transportation Research Group or similar at Chalmers. I got this got the opportunity to talk about this horizontal collaboration for some time ago, and for me it's a really an interesting topic, and I thought it was a welcome opportunity to be able to join this, hear what you other guys have been doing, and see what is bringing this topic forward, we can say. My past, I have been doing quite many big projects, specifically on European level throughout the years, stretching almost 20 plus years in those big projects. And I will talk a little bit about those projects and maybe my main, let's say, contribution to this session today. That would be how academia and research can have some role in bringing this about. And then I'm somehow hesitating that this has been brought about, but I know, and we have heard today, some examples of, yes, horizontal collaboration exists, but we also heard about there are struggling difficulties to get it up and running and so on. For some reason, I highlighted my title, which is, of course, the title of the session, but efficient and effective. And so there's a lot of focus on efficiency, has been for decades in the transportation industry. And the efficiency has always been linked somehow with, of course, increasing the resource utilization, as we know, and bringing automatization around, sharing data, more data, giving access to data, common data, and so on. And that's all fine, even if it has been going quite slowly, if you would ask me. But also the effective logistics and transport, bringing the terminology around here and saying, are we really doing this in the right way? And I think that is some of the things that we have have to look into not only the efficiency of the processes and the operations, but also if you are doing really these things in the right way. And that is effective in my mind. And that must be in the picture, in the solution matrix from the beginning, that probably we can do things differently, not only make them more efficient, which is also important. Don't misunderstand me there. But what I would like to do is to have a little bit on the background here. What are we dealing with? We have already had some definitions of what horizontal collaboration is, so probably we don't need to stay too long on that, but I would still like to bring to the table thoughts on that. Then I would like to go a little bit into what the industry, is the industry really taking care of horizontal collaboration, and why not? Today we have seen why, and we have also had some evidence of why not. I would like to dwell a little bit on that. And then I would like to finish my speech on the issue of how can academia or research contribute to the, let's say, make horizontal collaboration more appealing for companies and more interesting to do that. The session and the whole day is really is on these questions of sustainability goals, and new technology has put horizontal collaboration in focus. And I guess sustainability was probably not the terms, beside terms of economical sustainability, has been the driver, of course, from the beginning, as there's opportunity there. But technology, where are we on that issue? And I probably would state some things later in my talk about, yes, the data sharing issues and the things that relate to technology related to information exchange and data sharing. So that is definitely something. But what does it really mean? That's a good question. How can you open up new collaboration partners and think outside the box? What needs to be done to enable new solutions? And I think we have had earlier today, and also during this session, we have had some answers to these questions, and that's just good and all necessary for us to understand what we're talking about. But I would like to begin to talk about what does it really mean. And for that, I would like to step a little bit back and talk about, okay, horizontal collaboration is something that we're talking about today. I will talk a little bit about why we haven't been able to drive it as fast as we wanted, maybe. But then what have we been talking about? Because we have been talking about cooperation and collaboration for very many years now. How companies can cooperate, and the driver behind many of these projects that I'm going to talk about later on is that we want to increase this collaboration or cooperation, depending on how you define those terms. But the goal of the vertical cooperation has always been to establish mutual beneficial cooperation, so that you have two partners that would like to gain something out of it, but they work in different levels. So there can be a producer, a warehouse operator, a distributor, transport companies, and so on, that have cooperation because they see mutual beneficial issues there. That would be the vertical integration or cooperation that we have been seeing throughout the years and decades, actually. And that also goes into the lateral cooperation and brings us, of course, down to what we are talking about today, the horizontal collaboration. This was already defined in the first presentation, and that is the most important part here, as we are talking about the same level. And this is a thing that we obviously care a lot about, because the horizontal collaboration has been from the early beginning and from when we first were talking about these terms, and actually we may actually realize that when we talk about the literature on horizontal collaboration in logistics, the main body of the literature, it comes 2005 and later. So within that, the main body is relatively new. And one of the reasons why we have seen less of it than we maybe would have expected is that probably majority of companies were not really driving this development. They were hesitating. There were, of course, always a risk of the legal issue. We mentioned that a little bit before. But everybody has somehow seen that, yes, we can increase the utilization. And of course, we may not undermine the importance of legal and regulations here, because there is a risk, of course, that horizontal collaboration can be misused. We have also seen that, and we have seen both in the theory and in practice, that there is a potential to improve capacity utilization. That has always been the driver behind it. And what I think is important to realize is also that meaning going to horizontal collaboration does not mean that we don't do vertical collaboration or lateral collaboration. Absolutely not. The thing is actually that we probably can see that the horizontal collaboration benefits from integration of both vertical and horizontal collaboration. And I guess systems could be optimized in a way that they are working very well, because there is an established, well-functioning vertical collaboration as well as horizontal collaboration. And that brings me to the next thing. Is industry taking care of the horizontal collaboration? Why are they doing it, and why not? Some answers to that questions have already been said and revealed, but I would still like to just bring some of them around to the table. What is the enabling thing? Of course, business relations, that companies can build an organization around it. There we often have problems because let's say that the end goal may not be the same as in vertical collaboration. We talked about trust before as well, a huge issue. We can talk about communication, which is the IT systems architecture and data sharing, process integration, and so on. I will just say that with my experience working with research in this field for that many years that I've been doing it, these issues are always on the table, trust and the data sharing issues. And the willingness to share data, that is even going for vertical collaborations as well as horizontal collaboration. Now, the reason for that is valid also for vertical collaboration is, of course, that with the system as it is today, you go for vertical collaboration with the producer or service provider, and that producer or service provider is actually giving your competitors, selling his services to your competitor as well. So there's always been this huge, not lack of trust would not be the word, but really hesitation to have 100% trust in your service providers or the parties that you're dealing with, because you never know what happens really. Your relationship will be ended. How will the data be handled after that? Will there be any leakage of information between the partners, and so on? So that may never be undermined. The trust issue is in this, because if there is no trust, I don't really see that you will be communicating the information needed. And that goes for vertical as well as horizontal collaboration. We have the drivers, we saw this previously. We have the cost reduction issues. We can see the economies of scale and scope. And of course, we can see that there's a different kind of service possibilities that can be brought into the industry. And these partners or these stakeholders doing collaboration can share as well. Barriers as well we have. We have, of course, finding the right partners, trusting them, negotiating with them, how treating confidentiality, the IT, as I said, don't really realizing what will it bring in the end, savings for me, more market share for those guys and less for me. There are so many things in this, and obviously sharing the benefits, if it will be successful, that is a little bit difficult to determine in the beginning of it. I mean, this was a very rough, short introduction to the drivers, enablers, and barriers. We have seen what is enabling it. We have seen examples of it, but we also have to realize that these are the barriers. And I would like to end my short presentation here today with talking about a little bit. Okay, so horizontal collaboration is obviously benefiting the stakeholders that participate in that. I asked the question, why aren't everybody doing it if it's so beneficial? And there are barriers, as I said before, but the academia and my background, my experience is that we are seeing more academical work being done within this area that could benefit and drive, let's say, the increase in horizontal collaboration. As companies read about it, they see it, they're exposed to the good examples of it. That's what often is done in academia, that they write off and publish results of successful collaboration. So they will learn and get into that with their solutions. I have seen previously very big projects, but they are very often driven by strong partners that have their own agenda. They are including dyads, one up, one down in the chain at the most. Often not willing to open up for other partners because they see the competitors. And we see now a shift towards more project related horizontal collaboration. And these have been touching upon freight markets, technology development, standardization of information sharing as an example, and of course the last thing, data sharing, which is of huge importance. And we have been working in Chalmers recently on a very big EU project called AOLIX, which was a living lab, 11 living labs throughout Europe, which is absolutely a new way of dealing with how research comes into the picture, driving those living labs and really developing solutions that can be brought into the industry for those that are willing to get in there. DreamIt was another project, and we have also been involved in Phoenix, which was actually took over from AOLIX. But these projects are very much data sharing projects. Another thing that we can see where academia can contribute, and that is through the platform, the industrial platform. ALICE was mentioned before. ALICE is a platform that Chalmers specifically has been working on since start, some decade ago, and we are still very, very active there in the groups. 3 out of the 4 groups we are active within, where we are looking into the projects, how we can develop the calls, how we can participate in the consortium, and how we can really contribute to these platforms. We are involved in many more, but ALICE has been one of the major platforms that we've been working on. But that's a European-wide platform. But we also have, of course, I think, a contribution that we can work with and within, and that is, of course, the transport area at once, where we are doing quite good and effective research together with Gothenburg University. On where many of those projects are actually dealing with horizontal collaboration. So my expectation is that in the future, we will, in academia, both Chalmers and KU in this case, and the area of transport areas at once, we will actually be working more closely with those concepts of horizontal collaboration, probably to more extent than the vertical ones, even if they will always be there, because that's an important, let's say, source of data for us, the academia, because we are, of course, in our work, we are really depending on getting data from an industry. So my hope is that we can see more horizontal collaboration projects being brought to the table in the academia, and we can develop our theory and our frameworks towards that more companies will be able to benefit from this research. That was it. Thank you for listening to me. Dan, over to you.
Thank you very much, Gunnar. And I also thank you, Christer, Magnus, and Patrick for your previous presentations. And thereby I say thank you for us. Now it's exactly 15:45. Thank you very much.
Thank you very much.
Thank you. Bye-bye.
Welcome back. So now we have one of the 5 most important and most exciting sessions that we will have today. So what will we talk about now? Well, a year and a half ago, February 2020, almost 2,000 people were gathered in Stockholm. That sounds a bit strange, actually, standing here right now. There was a UN conference focusing on road safety on a global scale. It was the 3rd ministerial conference, looking back at what had happened the last decade and what should happen in the coming decade. And a lot of things were discussed, a lot of things were agreed upon, a lot of things were probably disagreed upon as well during that meeting. Things were mentioning and delved into, like the lack of pavements in small towns in Uganda to fully automated vehicles in the US. One of the things that was brought up, both in the conference as such, but also very much by the academic expert group that put together a number of recommendations ahead of the conference. And they were then decided as a UN resolution afterwards, was what are the responsibilities? What happens in the large value chains that we have, the global value chains and the national and local value chains as well? Companies, large public actors, and so on. So that is what we will talk about now in this last hour. And to start off, to begin, we will listen to Claes Tingvall, who was also leading this academic expert group ahead of the conference. And please, Claes, you're most welcome.
Thank you very much, Magnus, for that. And yes, it was a fantastic gathering. I think many of us still sort of feel that, well, life stopped for a year and a half since then, but it's coming back again. We're pretty sure about that. But in traffic safety, there hasn't really been any more gatherings since then. But a lot of things still sort of happens out there. And I will describe a little bit about that and describe a little bit about the sort of the new buzzwords for us in traffic safety and sustainability and so on. So first of all, I mean, this was the sort of the heading of the conference. It is about sort of a lot of countries and stakeholders meeting and discussing sort of what's going to happen in the next 10 years, the next decade. It's called the 2nd decade of action. And the background is really something, it's something big. I think it's one of the sort of major game-changing things we have experienced for the last something like, well, 20 or 30 years or something like that. Is really a major thing that we are now in the safety community a part of the 2030 agenda or the strategic development goals. It's going to mean, it means a lot for us, and it will be very important for us to understand what kind of new mechanisms we can be using, and where we can play a role in making sure that other important goals in the community will be fulfilled, or at least improved. First of all, as you're probably aware of, it is about health, climate, and equity, and how they are bundled together. That these kinds of goals are absolute, and you can't sort of trade one thing over to the other, or you can't cherry pick and say, I mean, I think this is important and this is not so important. It is about sustainability practices and reporting. It's about the mechanisms of public procurement and so on. And one thing that is really important is that it is really the public and the private sector, sorry, in partnership. But one thing for sure that needs to change, of course, is transport policy, which does not really go well hand in hand with the 2030 agenda, where sort of conventional transport policy really is a trade-off between different kinds of qualities. Here, you need to fulfill many things at the same time. this also means that for us in our traffic safety community, it's more important that we look at other things than look at just that we have a target now. That was just the sort of ticket to get there, but it's really about what you can expect public organizations and what you can expect, especially large corporations, to be doing within the next years, and how that interacts with traffic safety. So look at 12.6, 12.7, and look, for example, also at working conditions, about sort of workplace safety and things like that. And look at it with the eyes of that organizations, because this is about organizations now, don't wish to harm. I'm not saying that this is a blame act towards organizations or something, but organizations, of course, is a matter of what kind of trust they have in the community, both towards customers and, of course, towards their owners and the future, the investors of the future into them. And just understand how many organizations out there, in this case, very much of the private sector, but also the public sector. I mean, we all know that the public sector runs so many organizations, owning a lot of enterprises, but also running different kinds of services and function of the community. I mean, just look at the health sector, for example. But in this case, of course, it is expected that an organization does not harm people, in this case, in the road transport system. So we see, looking at this kind of picture, we don't see it as sort of the individual standing there. What we see is a corporation operating in the environment of where people actually are living, and what you can expect from them in terms of not harming anyone. This is just an example. There's nothing against Coca-Cola, of course. This is a part of what you call the sustainability journey. We have expected private, and in particular private organizations, to, through philanthropy, help to fund prevention in our field. And we have a lot of examples of nothing wrong with that. But now we're moving towards that you expect the organization to, within its own operations, to comply with things, to run innovation, and to transform in not only doing bad, but of doing good things out there. This is what is expected from, said customers, but also from the financial sector. The companies doing this kind of sustainability journey are the ones that is worth to invest in, and to know that they will return that kind of investment, increase their value. An organization that would not have this kind of sustainability journey would actually not be interesting at all, because it is a business risk if you're not going through this kind of journey. And if you apply this now to what you said, Magnus, the value chain. I mean, for us, this is a complicated word, but we need to learn about it, what they actually mean. You have talked about the supply chain. That means all the transport that goes from the raw materials all the way to sort of distributing things to the customer. If you add the word value chain, you also include the values that the customers might have and those who get the service provided by the organization or through the supply chain. So this is everything, and it's not only about those who are employed or something, it's also about the suppliers, and it's about the transport services that you use as an organization, as a company. And of course, it's so, for many corporations and organizations, there's so much transport in this value chain. I mean, you need to transport the raw materials. You need to sort of, from where you manufacture things to produce it to warehouses and to the consumers. And of course, today, and we discovered that during the pandemic now, that these value chains, they run through the whole world. often start, of course, in the low and middle income countries and maybe end up in a high income country. But these value and supply chain, they run across the whole world, and they are a massive part of the transport system that we have. No one has sort of a real calculation, but there are claims saying that in every place in the world, in any situation, at least half of the road transport you see around you is involved in some kind of an organized transport, or it could be people going to and from work and things like that. So this is a sort of massive part, and I like that expression when we say everyone that is killed or seriously injured in the road transport system is killed or seriously injured within someone's value chain. And if you look, for example, at all the children that are, more than 40,000 children below the age of 5 that are killed in road transport, most of them are actually hit by a truck or a bus or a commercial vehicle of some kind. Now, because the 2030 agenda and the financial sector says that it's not only that you should apply sustainable practices, you should report on it, and you should report openly about it to the community, to the customers, and in particular to those who are investing into your organization. Means that there is a structure for that kind of reporting, a quite well-organized framework. It could be what is called the Global Reporting Initiative or Global Compact. There are other sort of reporting systems, but they're well-organized, and large and even smaller corporations follow them. And it's in many countries and in the whole EU, it's actually mandatory if you have more than 500 employees to have this kind of sustainability reporting. And it should be about human rights, about and the labor, it's about workplace safety, it is about, of course, the carbon footprint. And what happened now during the conference was that it is recommended that all corporations also now report on the transport system and its safety impact, that it is reported throughout the community, and it ran all the way to what is called the Stockholm Declaration that sets up sort of the framework for the next 10 years. In going to be a global plan coming out from that. But it says very clearly that you should apply safe system principles to the entire value chain, and of course include then reporting. And it was even now repeated by the United Nations resolution, I think it's 74299 in August 2020, that we talk about the entire value chain. Now, the big thing is going to be sort of what you assign to an organization's value chain. And we've said it's going to be, Sanna Everby is going to tell you more about this, but the really sort of the core of what we are talking about and the core of that buzzword that runs through the world now, the safety footprint of an organization. This is what we at least think is a reasonable definition. It's based on ISO 39001, and it's based on other types of definitions. Sorry, I need to clear my voice. It talks about the entire value chain. It talks about all relevant and significant activities, services, and products, which means both the transports, the employees, the contracted, the third parties, but also the customers. I mean, for a car manufacturer or a vehicle manufacturer, it would be, of course, the supply chain of sort of making the trucks or cars or whatever it might be, transfer them to the customers. But it would also be what happens to them when they are used by the customers. So the safety footprint would include all the stages in this. And for some or for some organizations, it means we're talking thousands of sort of in that safety footprint. And one thing, of course, is the safety footprint could be shared by others, of course. I mean, everything is sort of integrated with each other, but I think we will understand more of that. So thanks for listening. Watch this space. This is going to be one of the really game changers. Probably, as I said, one of the biggest in the history of traffic safety. It's when you not only assign death and serious injuries to nations and cities or streets or whatever, you assign it to organizations that, of course, wish to control and to have targets and to make their safety footprint gradually smaller and smaller. Thanks. Back to you, Magnus.
Thank you very much, Claes, and just also to everyone who's listening in. I mean, we really wanted to have this with us here today because we see this as also as a teaser to the research community, because as we have been talking a number of times, Claes and I and others, this really goes cross-border. We have to do this, join up. We see different solutions, but these have to be put together in order to really make a change. So I'm just checking here if we have any questions from the audience. We do not yet, at least. Mike,
yeah.
I'm sure you have one.
Sure. No, that was really an interesting presentation, Claes, and it's very nice to see you online. I don't think we've met, but it's a great pleasure to meet you even in this way. So thank you very much. You said quite a few things that I thought were very interesting. I'm working in the field of freight transport and logistics, and I think one of the things that really sort of strikes me is the importance of the service side of things, the service sectors, which I think we often, to be honest, we overlook rather in transport. And I think that it's really great that you're going to try to, that's part of it. And as you say, that's part of it because it's all encompassing in that sense. And I was thinking about these service sectors, and I was thinking about how many of them are very complicated with, the work that they do, and a few big companies like the companies that service lifts, but then hundreds and hundreds of much smaller organizations. And I wondered whether that had been a topic that was discussed a little bit. I think Sanna will say more about this, but it was like the scale of the smallness of some of the companies is perhaps a big challenge.
Sure, and great to see you, Mike. Sure. I think it's such a challenge that we can expect, and Sanna will talk about that this is going to be a gradual process. Mm-hmm. I mean, there's no organization anywhere in the world that I can I wouldn't expect anyone to have this kind of control. But if you take workplace safety, it is already there. You are obliged even to report on sort of every sort of serious injury that happens within your sort of contractual agreement that you have also with your service partners. I'm not sure it happens in reality, but it should be there. What we are talking about here is, of course, a subset then. A subset of what happens in the workplace in the road transport system. But it's going to be interesting to see in sort of what control sort of large corporations already have today of the employees of themselves and the contractors in that sector you're talking about. Yeah. In reality, I don't have a clue how good they are, but that's a part of this interesting journey.
Sure, and I think that's what Magnus was saying when we said it's both in all kinds of ways. It's a fascinating sort of. It's a big important, but it's also a big challenge in that sense. And from a research point of view, it is to sort of to map these chains, then to quantify them. And I know Sanna will tell more about that, and we come back to it. I think in the end discussion. Because I think some of the trends are in a good direction. And I think this thing of companies taking more care and responsibility, that's a good direction. And then I think of some of the recent things which came even during the pandemic, and more things delivered to people's homes by people in a gig economy, let's say. And I think that's potentially in a bad direction in that sense, because that's potentially weakening the link between reporting and responsibility. So I think trying to deal with these things is going to be a big task. But I mean, that's also written into the decision that was made in 2000 in February at the conference. So looking forward to it.
Very good. Then we move on to our next speaker, who is Sanna Everby from AFRY. And she will give us more details regarding sort of, okay, but how do you actually do this? What kinds of measures do you have and how? So this is a pre-study, a feasibility study. So please, Sanna, welcome.
Yeah, thank you. I hope my voice will carry today, so bear with me. So when we started to implement Vision Zero over 20 years ago, we changed our thinking from the responsibility of the perfect driver to a system where people are allowed to make mistakes without risking their lives. And now is the time to take the next step toward achieving our goal. And that means changing our perspective to looking at the entire value chain of companies and organizations. So my name is Sanna Everby, and I'm a traffic planner and project leader at AFRY. And in this project, I, together with Claes Tingevall and our colleagues at AFRY, are working with FIA, Federation Internationale de l'Automobile, to develop a road safety index for companies and organizations. And as Claes talked about earlier, it is in the value chain of different companies that we can find accident, and therefore we should look to prevent them. The aim of the FIA Road Safety Index is to show the impact of traffic safety on a company or organization from a value chain perspective. The index is in line with the global goals, the third ministerial conference, and the UN resolution on improving global road safety. And the index is based on established principles for workplace safety and ISO 39001. So that's the foundations of this index. And after the third ministerial conference on traffic safety, it became apparent that change needed to be made and the time was ready to make that change. So in the spring of 2020, last year, we at AFRY together with FIA developed a feasibility study for a new traffic safety index. And during this year, we have developed the prototype for this index that further defining what it should include in our framework. And then we have also made a first draft of the manual for this. And right now we are testing this index together with 3 global companies, 2 local FEI clubs, and 1 governmental organization. And in a year, we plan to have an official launch of this new road safety index. Sorry. The starting point of the road safety index is the value chain. It is crucial to know and understand the entire impact of our value chain in order to achieve actual change. We know that most companies and organizations may never be able to catalog 100% of their value chain, but that doesn't mean that they shouldn't aim for it. So in this case, we distinguish between the supply chain and the value chain. The supply chain is often viewed as the process from raw material to the product until the product reaches the customer or the store. And with a value chain perspective, we both add the product's life after it reaches the store or the customer, as well as the impact the company or organization has on third party and the impact the subcontractors have on traffic safety. And we're also adding the product or the service itself in those cases where it has an impact on road safety. So for example, like Uber, their service is to drive people around. So it's not just, so it's also their customers we are looking at and their safety. So we are practically adding the lower part of this to the supply chain. So we have the supply chain here, and then we are adding, and we also look at the third party that is infected by the company and the organization's activities in the traffic. And here we are missing quite a few pictures. I am supposed to show you the supposed to be able to see this one. I don't know how to make it bigger for you. I'm so sorry. I don't know why this presentation won't work. So anyway, the FER Road Safety Index awards the steps a company and organization has taken. And to get full points, they need to fulfill a high ambition that can be observed, analyzed, and valued. So the index right now, we are covering the commitment and the footprint. And later we're going to add plans, monitoring, and safety culture. Okay, so here you're supposed to see one of the parts that's the commitment part. And so the first step is for the top management to commit. I wish I could show you the pictures. I'm so sorry. And to follow, the top management should start with committing, and they should commit to follow laws and regulation. And that is often seen as something that just be done. And still the speed limit isn't held. And this part, the commitment part, is to be viewed as shifting the responsibility to the top management. The driver is, of course, still responsible for keeping the laws, but the company needs to take active steps in making it the natural choice for the driver. So here we're looking at the company's traffic safety policy, safety target, how they follow law and regulation, and 4 safety performance factors. I think I have it as a PDF. Yes, now at least I can show you the pictures. So the 4 safety performance factors: speed, what kind of vehicles they use, the driver's fitness to drive, and the safety gear. So that's what we're looking for in the commitment and what we are asking from the top management. And then the second thing we'll look at is the footprint. And the footprint is defined as, Claes mentioned before, the number of fatalities and seriously injured persons as a result of road crashes occurring within an organization's entire value chain. All casualties resulting from relevant and significant activities, service, and products should be included in the calculation. So here we look at both the employed, the contracted, and the third party, as well as customers, clients, or citizens when the operation has an impact on these. So that part is for companies that has some more part in traffic safety, like the government that's building roads, or like a service provider, and also the vehicle manufacturers, of course. So that is what we look at when we look at the footprint. And the index isn't finished yet. And the plan is to launch the remaining parts in a few years. As Claes was talked about, it's quite big for a company to take it all in at the same time. So we are dividing it into smaller pieces. And in 2024, we will launch the monitoring parts and the plans. And in 2026, we plan to launch the safety culture management. So as a summary, we can say that a road safety index, this is a road safety index that is developed for FER with the aim to simulate progress within the field of traffic safety through transparency. It is designed to measure how a company or organization uses the transport system and their safety footprint in the entire value chain. It follows the recommendation in the Stockholm Declaration and in the traffic safety related global goals. And the pilots are starting right now. So we are planning to finish this, the manual and the index, so we can launch it in the second part of next year. Yeah, thank you.
Very much, Sanna, for that overview. And I think all of you who have listened here, you see that, there are so many pieces of this jigsaw that has to fit together and has to be, some of them are more developed than others. So a lot of work to do. At the same time, quite a lot of things are there. We just need to find them and need to put them together in a good way. We have a question from the audience. I'm not sure who of you would like to answer, and that is, how do we actually do this? How can we split the responsibility between what is normally a responsibility for a nation or maybe for a region? You were touching on this in your introduction class, and a corporation or another type of large organization. How do we? Because it's kind of in different dimensions, in a sense. Would you like, is it Claes who wants to go for that one? Or?
Sanna, do you want me to?
You can go ahead.
Yeah. No, I think we should avoid sort of the word sort of responsibility, but talk about sphere of influence. And you, Sanna, you touched on that as well. I mean, if you have an organization where the top management would take on the role to make sure that the transports, for example, are following rules and regulations and so on, it would be expected. And not thinking about sort of the enforcement, but to make sure that these transports are running within sort of that kind of requirement, which would mean, in the long run, monitoring or quality assurance, like you make sure you cannot drive the vehicle if you are under the influence, or you can't be speeding and things like that. It is a shift, of course. It doesn't take away, it doesn't take away any legal obligations and things like that, but it opens up for that the expectation would be that a corporation that is aiming for a high rating here, because it is a rating system that Sanna described. If you aim for a high rating, you need to have these kinds of factors in control. But let's talk about sphere of influence and nothing else, because otherwise we're into the legal frameworks, and of course they will exist anyway, but this is not about that.
Good, thank you. Because just as a follow-up, then also from the person who asked the question, because some things like the infrastructure and so on, that is done by certain actors, whereas the culture, as you were talking about, the speeding and the behavior is another thing. So yes, good, thank you.
Vehicle choice, for example, would be also a factor, and with all the safety system you would be expected to have.
Mike, do you have any questions before we move on?
Just maybe one to Sanna, because it was very nice to see you online, Sanna, because we had the conversation on the telephone. But thank you very much for the presentation. I know it was some glitches, but it was very clear what you were telling about was very clear from here, so no problems. And I suppose I'm just sort of a little bit curious about the timeline in a way, because, as you say, it's a lot for companies to take in, and so you've got to establish this timeline. And sometimes I find 2026 looks like it could be tomorrow, very near, and other times 2026 seems like, but that's 6 years after 2020 when they talked about this. It's a long time. I suppose it's about being realistic, isn't it? And trying to tackle actually quite a hard bit first in some ways, because it's very detailed. But the timeline, do you feel like it's a little bit on track after in terms of the scoping study? Does it give you confidence that it's a little bit, that it's on track?
Yeah, I think it is. When we're talking to our pilot companies, it feels like it's a good way to move forward and to start with established the main goals of the company, and to include traffic safety in how they work and in their culture. So that's an important starting point before we can add the rest.
And the pilot companies give you a kind of very concrete approach to this, I guess, don't they? Because they tell you where there are big problems with the, well, where there are, as you say, sometimes not many problems with the data, because actually you collect some of this already. Maybe don't use it in the same way, but they collect it. And other times when perhaps there are things that we'll have to think about collecting in some other way, which will be, again, more, cause more resource. So using these pilot companies seems like a really good way to have developed it.
Yeah.
Yeah, good.
Good, and we also have another question from the audience here, and I will read this from my screen. So, is the impact of perceived unsafety, I mean that you actually avoid doing certain trips, going by bike and so on, because of the risks, the being hit by a truck or a car, is that included in this kind of assessment?
It's not included in this index, but it will be an effect if you have safer roads and if we build safer roads. So if we for once look at like the infrastructure provider, like a municipality, so if we look at their rating and how they work, there it can be a factor, but it's not a factor for like freight companies and such.
Okay, good. Thank you very much. Then we actually have a third person, or a fifth, depending on how you count, who will be involved in this discussion, and that is Anders Kullgren, who is head of research at Folksam. So, Anders, welcome to this session as well. And now we're very curious to understand and see. Okay, Folksam, an insurance company. What is your role? Why are you interested in this? And sort of what's the background? Please, Anders.
Yeah, thank you. I hope you can hear me now.
We can.
Yeah, good. So actually, yes, as you know, I'm a researcher more in the traffic safety area. We have followed the development of this, but in this case, I can also speak for Folksam as a big investor in this area, maybe that could be of more interest. So of course, we are very positive to this initiative. I mean, we have seen so much positive in the development of the footprints in, for example, the climate area. And we believe this introduction of the footprint in the safety area would mean a lot in the future. And I can just share some experiences how Folksam has acted and as an investor in this sustainability area, for example, regarding, for example, then the climate footprints. That, I mean, the companies that choose not to report in different sustainability areas will have some problems. It will result that they get a low scoring, for example, in sustainability evaluations that is performed by consulted companies, which sells then this information to large investors. And of course, depending on the investor, you could act differently, but you could choose not to invest in those that have a low scoring. Or if you already have some kind of relation, you can start discussing with the companies, not reporting why they are not doing it. And you can also then, of course, have discussions how the developments are going on. So I think our experience is that there will be a pressure to be transparent and open about footprints in all sustainability areas, as we have seen so far in the footprint area, climate reporting, for example. So we are, in summary, we're very positive, of course.
Let's look into some questions. Mike,
yes,
again, would you like to?
Is this for Anders particularly,
or
just have some
I think
we can have them for everybody, maybe.
Yeah.
Yeah. No, I just had one follow-up question to that about the data side of it, because thinking about the data, I guess there's a lot of complicated places that the data sits, and some of it's obviously, as we heard in a previous presentation, some of it's has to be secure and it's confidential and so on. But is there a role for some of the companies that hold, for example, insurance information at an aggregate level to help to target some? I mean, could we see this initiative developing? Of course, it's going to be all-encompassing at some point, but to begin with, maybe it has to be a little bit more targeted to be most effective, could there be ways to use the data to help to target where the efforts are most valuable? I'm not sure whether Anders. I wasn't asking you to say, I wasn't asking you to commit to giving the data to somebody, but I was just thinking, are there possibilities to use? This is a huge initiative. It seems to me. You know, very complex chains. We're talking about multiple interactions, and we have to capture hard information to make an index that somebody can stand up and, you know, put this in front of them and say, we believe in these numbers. And I'm just thinking that there probably is a lot of data out there. I mean, we hear about big data. There's a huge amount of data. Yes. It seems to me it's often not quite the right data we want, or somebody's said it's my data, you can't have it, and so on. But I'm just wondering whether in this area we have these companies that are taking a kind of lead by helping the scoping study. I would imagine that in the beginning there'll be what I would call, but it sounds negative, the usual suspects, if you like, who will be willing to take part because they believe in this and they believe in the philosophy that Klaas mentioned at the start, that actually doing something good for your company and the world could actually be good from an investment point of view. But that leaves a big tail of not quite sure. You say you're from the tax department and you're here to help me, and so on. So I'm just asking whether the data can help to, can there be some data that can guide us as to where to focus the effort?
Yeah, of course. And I agree, it will be a challenge for, depending on the company. Many companies will be a big challenge if you should include the entire value chain, of course. And of course, there could be a lot of data sources used to target where you need to put the most efforts in. And insurance data is, of course, one source of information that can be used because we have all the claims reports from different areas then, so that, of course, can be used.
Good.
Can I add to that a little bit?
Please.
Because, as you say, I mean, if you just say, you know, in a number of countries, the fatalities and maybe some of the serious injuries are quite sort of well known to the community, but it's not classified in a way that it is useful for a corporation looking at its value chain. I mean, there's no recording of that it belongs to, let's say, a big corporation. It doesn't really say that now they were driving for duty for this kind of operations or something like that. And that's going to be a question, of course, to the authorities, if they are willing to classify and if they can do it, willing and can classify according to value chain. I'm not overly optimistic about that. At least it will take a lot of time and you'll get into a lot of very complex questions about integrity and so on. But as you yourself pointed out, in the workplace area, it is a norm. It is even legally binding that you need to have this in control and report. So we will give, in the index that Sanna described, we will give quite a number of points if you at least can describe what has happened to your employees, to those who are employed and contracted, because that's already under sort of obligation. The question is, how detailed is that information? Do you know that it happened in the transport system or something like that? But the many points you get if you can also control the figures of the third parties, everyone you hit. And if you, there's a great study made in the EU by ETSC that says that for every truck driver that is killed in a heavy goods vehicle, he kills 10 outside. He doesn't kill, but 10 outside are killed, which means the third parties in that kind of parts of the supply chain looks like that means that you really have to find them then. We have given the advice to the three big corporations, well, advice, but we're hinting at they need to collect the data themselves. There's no one else other than insurance companies, maybe, that can help them to find these cases. But that's going to be a real challenge. And it would be great if this research community could help out here with how you actually go about doing that. and if you can use automatic notification of things or whatever you're going to need to do out there. But anyway, this is a huge challenge, but of course we shouldn't give up already from the beginning. This is going to happen, I'm sure.
When I first read about the initiative, I was really interested in it because I've spent most of my career working in London and was aware of the questions about the construction sector, which had done a lot about on-site accidents, or well, accidents isn't the word, but anyway, on things that happen on-site. But then, as soon as the vehicle left the construction site, it wasn't anything to do with the construction activity, if you like. And then they started to work on that, and they found a lot of ways to then improve things, even though they might not have had all these numbers. Just the action of looking at it started to make things improve, and they took more responsibility, and they were able to develop case studies and tell, okay, some stories about it maybe. But I think there's a lot to be gained, of course, by the whole thing of the index, but hopefully in the process of going towards the index also we could see benefits, I think. Is that a shared view at all, or am I talking as, oh, they're people from London, they've always got these funny views?
No, not at all. I think you're just sharing our optimism. I mean, going deeper and deeper into these issues, and especially combining it with both what happens in the road safety culture with ISO 39001 and all the definitions you got there for organizations that wish to have a management system, and combining that what has happened with workplace safety, but also, as Anders pointed out, with a sort of carbon footprint and things like that.
Yeah.
If you put everything like this into the same basket, and you can see the beauty of when you sort of attach things that happens due to a corporation's activities with the top management's sort of course, interest in understanding what they can do about it. I mean, it is going to, a lot of things are going really to happen. That's why this is a game changer of probably in a way that we haven't seen for a very long time. I mean, attaching or not blaming, because blaming is a word we don't use, of course, but sort of attaching sort of events that has got to do with harm out in the community with the name of or an organization and its owners and its investors is something, it's a giant step. So we're probably even more enthusiastic and optimistic than what you are, but even if you come from London, in Sweden can be very optimistic as well.
In Sweden, yeah, of course. I don't know if, Sanna, did you want to, I think you were going to add something, but I might have misunderstood it's a bit difficult to read the signs on the video screens, as it were.
Yeah, and I also believe in the power of awareness, that shining the light on the question will make a difference and an impact. And companies, big companies starting doing this, and then smaller companies will see that even if they don't immediately adopt the index, they see that they can make changes and that changes is possible. So I think that is one part of the process we will see. To make examples that others also can make changes.
Good.
Can I follow up with a different sort of direction with the question? I mean, obviously the three presentations are from Sweden, and this initiative seminar is in Gothenburg, and Sweden's very well established in this road safety question, so I think that's very appropriate. But could this also be something where Sweden can make a big contribution through, as you say, we can come back in a minute maybe to some of the research challenges, but is it something that's it's clearly important to globalize it, but can it also be something where Sweden can show leadership in that sense? Or is that to misunderstand it?
Yeah, hopefully we can and we should show a leadership. We have quite we have the rules and regulations for it, and we have the reporting down now. But these pilot companies we have, they are global.
Yeah.
And they are not mainly suited in Sweden.
No. Okay.
So
Thank you. A question that is more on a kind of a detail level, because you are mentioning sort of the numbers and the ratings and so on. So that would be done by sort of external evaluators somehow, or what is the plan? Similar to when you have your ISO 9000 hearings and so on.
Shall I? Sanna, you can answer that.
Yeah. We haven't really landed that question yet. I'm not sure, Claes, what the latest discussion with FEA is.
No, I think we just now the sort of prototypes are developed in a way where you would involve people from sort of the outside helping out with the rating. But because it's a prototyping means that we need to learn a lot. But I think it could be, and as Anders pointed out, it could be either, you know, one of the big sort of auditing organizations. It could be the company itself doing this kind of rating. If you can do it as sort of a hostile rating, meaning, you know, you just look at the company from the outside, that is probably something later. Now it would involve the corporation doing a lot of the work and having some kind of, not third party or auditing, but at least with the help of experts in this field to do it. But in the end, it's going to be sort of so clear and so not easy, but still sort of so clear and defined so well that most organizations should be able to do it and then have someone coming in and have a look at it. That's the idea, at least.
Do you think there will be some sort of, is it possible that there will be also, in a sense, there are incentives to do this, as you've described, the incentive of access to investment and so on. These are sort of quite high-level incentives, if I can put it like that. I mean, there are other things that could be given as incentives. You could give road transport, freight transport companies access to areas with a good record, or you could have these kind of or they could be given reduced loading charges or something, or reduced insurance premiums or whatever. Are there other incentives that could be used? And is that something that would be looked at in the scoping study, or will it sort of stay at this rather quite, what I would say is quite a high level of, well, it should be that the investment follows the good companies and so on?
I think, I don't know if you got that expression in London, but here we used to say you clean a stair from the top and then down, which means sort of if large and multinational corporations start doing this, it will cover so many of the transport service providers, the manufacturers of vehicles, which would have them to report a lot of things, and so many others. And if you see these corporations, and then with companies like Volkswagen putting some mild expectations at least, and with the state governments also, because they are so involved in business. I mean, 10 to 20% of public procurement of the global economy is public procurement. I mean, there's so many quite mild ways of making sure that this will happen. And if you got sort of a lot of the big ones like FIA, that's why it's good that they are there. They exist everywhere in the world. They've set up the NCAPs and the IRAPs and things like that. It is probably going to be so natural. I think it's more sort of how serious and what effects you will see as a big corporation on your safety footprint when you start to apply the principles and the practices that you can already quite early in the process start to make sure they happen in the organization. I mean, it's likely that it will happen in that way. Then you can put more pressure because you already have today, at least in the EU, that it is mandatory to report on sustainability issues for large corporations. If that would cover traffic safety, not sure yet. That will take a few years, but it might happen as well. But I think the financial sector has a very big role, at least in the beginning, like Volkswagen and their colleagues.
Yeah, I think it's very interesting, the comment that was made by but in your presentations, in a sense, but and by the comments you've made about how the carbon footprint is quite well established. These other ways of doing it, the obligation to produce certain types of report, and there obviously are sort of some things that can be seen as very similar in that sense, and then there are others which are more complex or more difficult, perhaps, to do. I think do we have time for one more question?
I think we have one or two more, yes,
yeah, okay.
Absolutely.
Because you mentioned one thing which came up in the discussion after Anders had spoken, Claes, and I wonder whether and that was about data and the need for data and the quality of the data, and you said, well, this is something where researchers could come with ideas and suggestions. Outside of the data, what have been some of the broader research challenges, in a sense, in the scoping study? Have you identified some areas which are inherently quite difficult to? You feel that you need more research. They're going to be challenging areas to go ahead with. Everything else.
No, there's so many great research questions. I mean, what happens with a large car fleet when you start to use that kind of technology that's really cutting the edges? I mean, the top kind of things you can do to vehicles, which you would expect some organizations to take up. And especially if you go to low and middle income countries, which would gain really much, where you've got so many vulnerable road users killed and seriously injured there, with a traffic environment that is so different from what we are used to see how these kinds of technologies like pedestrian detection and braking and geofencing of maximum speed and a lot of other things as well. I mean, it's a massive sort of kind of questions we can start really to demonstrate that if they work or not. I mean, because we know that in these kinds of environments, there's not going to be any regulation. They're weak governments, they're weak authorities. There's no real market for this kind of sort of more better or a transfer of this kind of technology. To look at that is going to be enormously interesting also from the researchers, and especially in terms of research, of course. So I mean, there's no end to it, if I may call it so. But then also for sort of how it will work with monitoring of fitness to drive, not under influence, what will happen in the UK when you say no, no, sorry.
And we drive on the other side, yeah.
Yeah, on the other side, and all those very interesting questions. So I think it opens up, and I mean, like, as you know, a lot of the research now is actually driven by automotive industry and others. Now you can see many more organizations wishing to really get deeper into understanding what they can do, because reducing your safety footprint will drive the whole thing. I think so many questions will come up, because what we try to do is really to get around this, just apply some common sense and send our drivers to some advanced driving courses. I mean, that's where you won't get any benefits in our rating. I mean, if you're dealing with those kinds of things, or we just inform our drivers they should be more careful, I mean, you won't get any point for that. It is really using best practice, best kind of knowledge and research-based interventions you can do. That's where you get your points. But of course, you need to follow up, and you need to do a lot of understanding with new things you can apply to it. So there's no end to it. Sorry for being so optimistic, but we're carried away now by all the things we can do.
Very, very good. And thank you very much to all of you. We will need to round up. We do have some additional questions, but I think this has also sort of started to run this thought process in many heads now. Okay, well, what does it actually mean? And that's something that we have experienced as well when we've sort of presented this a number of times now. It takes a little while, and then people start to think, and then you get all these sorts of different thoughts and ideas and so on. So we will continue to do that. So we will close this final fifth session now, and we'll hand over to Kajsa to summarize the day for us.
Thank you, Magnus.
Thank you.
That summarized the day. Oh, good luck. Thank you, Magnus, for that introduction. Well, where are we going? That was how we started the day, with that question. And during the day, I would really say that we had learned a lot about different trends, different research directions, and different solutions that both practitioners and researchers work with in relation to the challenges we have in the transport system. But it also became obvious that the solutions promoted by the different researchers and practitioners, some agree on, like hydrogen, is that the best solution? But others disagree on which is the best track for the future. And obviously, this is not strange at all, since, as now I'm quoting George Gill for today, reality is messy, and we have to live with that. And that means that for us as researchers and practitioners, some of us will focus on some components of the transport system, this messy transport system, but others will need to focus on the interfaces between these components to try to somehow deal with this messiness. So I would say that maybe someone said here today that we have done too little about these interfaces, and that is, I think, something that we could also bring along for our future discussion, the future coming years and initiative seminars. And maybe a conclusion, I don't know, it's my reflection, is that maybe we can never, ever manage this messiness, but we certainly need to manage in this messiness. And I think that is something that we maybe can work on, maybe not hoping to solve it. So this is an ongoing discussion. We don't end today. We will come back. We will have different seminars. We will have a new initiative seminars coming up in 2022. And we certainly hope that we can meet here, all, not only 8 people here around us now. So we welcome you back for next year. And this, of course, could not have been done without the contributions by many people. First of all, of course, all the speakers who have provided different perspectives and input to this messiness of the transport system that we have really learned a lot about. Then, of course, we have the management team of Area of Advanced Transport, some being here today, being moderators, Dan, Mike, Magnus, and Selma, and others then that have not been able, due to cold and sicknesses, that they needed to stay at home, like Sinisa, Erika, and Johan. Then we have Anna and Johanna, who has organized all the very hard stuff around the event and the communications and all that. So thank you a lot. And then last but not least, we have the tech team from AV providers that has made this event possible. So also thank you for doing all these tech things with the mics and everything. So let's end this day by saying that we need to continue to manage in this messiness, no matter we want it or not. Okay? So see you in 2022. And now don't forget to fuel up for some active mobility. That we can agree on, that fuel. Okay, thank you.